Symbolic logic ****************************************************************************************************************************************************************************************************************************************************************************************
by
Lewis_Carroll PG_3 PG_3 a syllogism worked out. That story of yours, about your once meeting the sea serpent, always sets me off yawning. I never yawn, unless when I'm listening to something totally devoid of interest. The premises, separately. Diagram representing all, diagram representing never the premises, combined. Diagram representing the combination, the conclusion. Diagram representing the conclusion. That story of yours, about your once meeting the sea serpent, is totally devoid of interest. Symbolic Logic Part I Elementary by Lewis Carroll 2nd 4th edition price 2 shillings London Macmillan & Co., Limited New York, The Macmillan Company 1897 All rights reserved PG_the Richard Clay and Sons, Limited, London and Bungay PG_AE Advertisement. An envelope containing 2 blank diagrams, biliteral and triliteral, and 9 counters, 4 red and 5 grey, may be had from Messrs Macmillan, for 3D, by post 4D. I shall be grateful to any reader of this book who will point out any mistakes or misprints he may happen to notice in it, or any passage which he thinks is not clearly expressed. I have a quantity of MS in hand for parts 2 and 3, and hope to be able, should life, and health, and opportunity, be granted to me, to publish them in the course of the next few years. Their contents will be as follows. Part 2. Advanced. Further investigations in the subjects of Part I propositions of other forms, such as not all X are Y. Triliteral and multiliteral propositions, such as all ABC are do. Hypotheticals. Dilemmas. And C Part 3. Transcendental. Analysis of a proposition into its elements. Numerical and geometrical problems. The theory of inference. The construction of problems. And many other curiosa logica. PG_AT Preface to the 4th edition. The chief alterations, since the first edition, have been made in the chapter on classification, pp 2, 3, and the book on propositions, pp 10–19. The chief additions have been the questions on words and phrases, added to the examination papers at p94, and the notes inserted at pp 164, 194. In Book I, Chapter 2, I have adopted a new definition of classification, which enables me to regard the whole universe as a class and thus to dispense with the very awkward phrase "a set of things." In the chapter on propositions of existence I have adopted a new normal form in which the class, whose existence is affirmed or denied, is regarded as the predicate, instead of the subject, of the proposition, thus evading a very subtle difficulty which besets the other form. These subtle difficulties seem to lie at the root of every tree of knowledge, and they are far more hopeless to grapple with than any that occur in its higher branches. For example, the difficulties of the 47th proposition of Euclid are mere child's play compared with the mental torture endured in the effort to think out the essential nature of a straight line. And, in the present work, the difficulties of the five liars problem, at p. 192, are trifles, light as air compared with the bewildering question what is a thing. In the chapter on propositions of relation I have inserted a new section, containing the proof that a proposition, beginning with all is a double proposition, a fact that is quite independent of the arbitrary rule, laid down in the next section, that such a proposition is to be understood as implying the actual existence of its subject. This proof was given, in the earlier editions, incidentally, in the course of the discussion of the biliteral diagram, but its proper place, in this treatise, is where I have now introduced it. PG_X in the Srites examples, I have made a good many verbal alterations, in order to evade a difficulty, which I fear will have perplexed some of the readers of the first three editions. Some of the premises were so worded that their terms were not specieses of the univ, named in the dictionary, but of a larger class, of which the univ was only a portion. In all such cases, it was intended that the reader should perceive that what was asserted of the larger class was thereby asserted of the univ, and should ignore, as superfluous, all that it asserted of its other portion. Thus, in X. 15, the univ was stated to be ducks in this village, and the third premise was Mrs. Bond has no grey ducks, i.e. no grey ducks are ducks belonging to Mrs. Bond. Here the terms are not specieses of the univ, but of the larger class ducks of which the univ is only a portion, and it was intended that the reader should perceive that what is here asserted of ducks is thereby asserted of ducks in this village, and should treat this premise as if it were Mrs. Bond has no grey ducks in this village, and should ignore, as superfluous, what it asserts as to the other portion of the class ducks, viz. Mrs. Bond has no grey ducks out of this village. In the appendix I have given a new version of the problem of the five liars. My object, in doing so, is to escape the subtle and mysterious difficulties which beset all attempts at regarding a proposition as being its own subject, or a set of propositions as being subjects for one another. It is certainly a most bewildering and unsatisfactory theory. One cannot help feeling that there is a great lack of substance in all this shadowy host, that, as the procession of phantoms glides before us, there is not one that we can pounce upon, and say here is a proposition that must be either true or false. That it is but a Barmecide feast, to which we have been bidden, and that its prototype is to be found in that mythical island, whose inhabitants earned a precarious living by taking in each other's washing. By simply translating telling two truths into taking both of two condiments, salt and mustard, telling two lies into taking neither of them, and telling a truth and a lie, order not specified, into taking only one condiment, it is not specified PG_switch, I have escaped all those metaphysical puzzles, and have produced a problem which, when translated into a set of symbolized premises, furnishes the very same data as were furnished by the problem of the five liars. The coined words, introduced in previous editions, such as eliminans and retinans, perhaps hardly need any apology. They were indispensable to my system, but the new plural, here used for the first time, viz. Srites, will, I fear, be condemned as bad English, unless I say a word in its defense. We have 3 singular nouns, in English, of plural form, series, species, and srites. In all 3, the awkwardness of using the same word for both singular and plural must often have been felt. This has been remedied, in the case of series, by coining the plural serieses, which has already found its way into the dictionaries. So I am no rash innovator, but am merely following suit, in using the new plural srites. In conclusion, let me point out that even those who are obliged to study formal logic, with a view to being able to answer examination papers in that subject, will find the study of symbolic logic most helpful for this purpose, in throwing light upon many of the obscurities with which formal logic abounds, and in furnishing a delightfully easy method of testing the results arrived at by the cumbrous processes which formal logic enforces upon its votaries. This is, I believe, the very first attempt, with the exception of my own little book, The Game of Logic, published in 1886, a very incomplete performance, that has been made to popularize this fascinating subject. It has cost me years of hard work, but if it should prove, as I hope it may, to be of real service to the young, and to be taken up, in high schools and in private families, as a valuable addition to their stock of healthful mental recreations, such a result would more than repay 10 times the labor that I have expended on it. LC 29 Bedford Street, Strand. Christmas, 1896. PG_I Introduction. To Learners. NB. Some remarks, addressed to teachers, will be found in the appendix, at p165. The learner, who wishes to try the question fairly, whether this little book does, or does not, supply the materials for a most interesting mental recreation, is earnestly advised to adopt the following rules. 1. Begin at the beginning, and do not allow yourself to gratify a mere idle curiosity by dipping into the book, here and there. This would very likely lead to your throwing it aside, with the remark, "This is much too hard for me," and thus losing the chance of adding a very large item to your stock of mental delights. This rule, of not dipping, is very desirable with other kinds of books, such as novels, for instance, where you may easily spoil much of the enjoyment you would otherwise get from the story, by dipping into it further on, so that what the author meant to be a pleasant surprise comes to you as a matter of course. Some people, I know, make a practice of looking into Volume 3 first, just to see how the story ends, and perhaps it is as well just to know that all ends happily, that the much persecuted lovers do marry after all, that he is proved to be quite innocent of the murder, that the wicked cousin is completely foiled in his plot and gets the punishment he deserves, and that the rich uncle in India, question. Why in India? ANS. Because, somehow, uncles never can get rich anywhere else, dies at exactly the right moment, before taking the trouble to read volume IPG_ITHIS, I say, is just permissible with a novel, where volume 3 has a meaning, even for those who have not read the earlier part of the story, but, with a scientific book, it is sheer insanity. You will find the latter part hopelessly unintelligible, if you read it before reaching it in regular course. 2. Don't begin any fresh chapter, or section, until you are certain that you thoroughly understand the whole book up to that point, and that you have worked, correctly, most if not all of the examples which have been set. So long as you are conscious that all the land you have passed through is absolutely conquered, and that you are leaving no unsolved difficulties behind you, which will be sure to turn up again later on, your triumphal progress will be easy and delightful. Otherwise, you will find your state of puzzlement get worse and worse as you proceed, till you give up the whole thing in utter disgust. 3. When you come to any passage you don't understand, read it again. If you still don't understand it, read it again. If you fail, even after 3 readings, very likely your brain is getting a little tired. In that case, put the book away, and take to other occupations, and next day, when you come to it fresh, you will very likely find that it is quite easy. 4. If possible, find some genial friend, who will read the book along with you, and will talk over the difficulties with you. Talking is a wonderful smoother over of difficulties. When I come upon anything, in logic or in any other hard subject, that entirely puzzles me, I find it a capital plan to talk it over, aloud, even when I am all alone. One can explain things so clearly to one's self. And then, one is so patient with one's self, one never gets irritated at one's own stupidity. If, dear reader, you will faithfully observe these rules, and so give my little book a really fair trial, I promise you, most confidently, that you will find symbolic logic to be one of the most, if not the most, fascinating of mental recreations. In this first part, I have carefully avoided all difficulties which seemed to me to be beyond the grasp of an intelligent child of, say, 12 or 14 years of age. I have myself taught most of its contents, viva voce, to many children, and have PG_IT found them take a real intelligent interest in the subject. For those who succeed in mastering Part I, and who begin, like Oliver, asking for more, I hope to provide, in Part II, some tolerably hard nuts to crack, nuts that will require all the nut crackers they happen to possess. Mental recreation is a thing that we all of us need for our mental health, and you may get much healthy enjoyment, no doubt, from games, such as backgammon, chess, and the new game Halma. But, after all, when you have made yourself a first-rate player at any one of these games, you have nothing real to show for it, as a result. You enjoyed the game, and the victory, no doubt, at the time, but you have no result that you can treasure up and get real good out of. And, all the while, you have been leaving unexplored a perfect mine of wealth. Once master the machinery of symbolic logic, and you have a mental occupation always at hand, of absorbing interest, and one that will be of real use to you in any subject you may take up. It will give you clearness of thought, the ability to see your way through a puzzle, the habit of arranging your ideas in an orderly and get-at-able form, and, more valuable than all, the power to detect fallacies, and to tear to pieces the flimsy illogical arguments, which you will so continually encounter in books, in newspapers, in speeches, and even in sermons, and which so easily delude those who have never taken the trouble to master this fascinating art. Try it. That is all I ask of you. LC 29 Bedford Street, Strand. The 21st of February, 1896. PG_14 PG_XV Contents Book I Things and Their Attributes. Chapter I Introductory. Page Things 1 Attributes Adjuncts Chapter 2. Classification. Classification 1 1/2 Class Peculiar Attributes Genus Species Differentia Real and Unreal, or Imaginary. Classes 2 Individual A class regarded as a single thing 2 1/2 PG_XV Corpta 3. Division 1. Introductory. Division 3 Codivisional classes 2. Dichotomy. Dichotomy 3 1/2 Arbitrary limits of classes Subdivision of classes 4 Chapter 4. Names. Name 4 1/2 Real and unreal names 3 ways of expressing a name 2 senses in which a plural name may be used 5 Chapter V Definitions. Definition 6 Examples worked as models PG_XA Book 2. Propositions. Chapter I Propositions generally. 1. Introductory. Technical meaning of some 8 proposition normal form of a proposition subject, predicate, and terms 9-2. Normal form of a proposition. Its 4 parts: 1. Sign of quantity, 2. Name of subject, 3. Copula, 4. Name of predicate 3. Various kinds of propositions. 3 kinds of propositions. 1. Begins with some. Called a particular proposition, also a proposition in I-10. 2. Begins with no. Called a universal negative proposition, also a proposition in E. 3. Begins with all. Called a universal affirmative proposition, also a proposition in a PG_XA proposition, whose subject is an individual, is to be regarded as universal. 2 kinds of propositions: propositions of existence, and propositions of relation. Chapter 2. Propositions of existence. Proposition of existence 11 Chapter 3. Propositions of relation. 1. Introductory. Proposition of relation 12 Universe of discourse or univ. 2. Reduction of a proposition of relation to normal form. Rules 13 Examples worked 3. A proposition of relation, beginning with all, is a double proposition. Its equivalents to 2 propositions 17 PG_19 4. What is implied, in a proposition of relation, as to the reality of its terms? Propositions beginning with some 19 propositions beginning with no propositions beginning with all 5. Translation of a proposition of relation into one or more propositions of existence. Rules 20 Examples Workbook 3. The bilateral diagram. Chapter I Symbols and Cells. The diagram assigned to a certain set of things, viz. Our univ.22 univ. Divided into the X-class and the X-class 23. The north and south halves assigned to these two classes. The X-class subdivided into the XY class and the XY class. The northwest and northeast cells assigned to these two classes. The X-class similarly divided. The southwest and southeast cells similarly assigned. The west and east halves have thus been assigned to the Y-class and the Y-class. Table I. Attributes of classes, and compartments, or cells, assigned to them 25. PG_XX Chapter 2. Counters. Meaning of a red counter placed in a cell 26. Meaning of a red counter placed on a partition. American phrase sitting on the fence. Meaning of a gray counter placed in a cell. Chapter 3. Representation of propositions. 1. Introductory. The word things to be henceforward omitted. 27. Unilateral proposition. Bilateral do. Proposition in terms of certain letters. 2. Representation of propositions of existence. The proposition some X exist. 28. 3 other similar propositions. The proposition no X exist. 3 other similar propositions. 29. The proposition some X Y exist. 3 other similar propositions. The proposition no X Y exist. 3 other similar propositions. The proposition no X exist is double, and is equivalent to the two propositions no XY exist and no XY exist. 30. PG_XZ 3. Representation of propositions of relations. The proposition some X are Y. 3 other similar propositions. The proposition some Y are X. 31. 3 other similar propositions. Trio of equivalent propositions, viz. Some X Y exist equals some X are Y equals some Y are X. Converse propositions, and conversion. 3 other similar trios. 32. The proposition no X are Y. 3 other similar propositions. The proposition no Y are X. 3 other similar propositions. Trio of equivalent propositions, viz. No X Y exist equals no X are Y equals no Y are X. 33. 3 other similar trios. The proposition all X are Y is double, and is equivalent to the two propositions some X are Y and no X are Y. 7 other similar propositions. 34. Table 2. Representation of propositions of existence. 34. Table 3. Representation of propositions of relation. 35. Chapter 4. Interpretation of bilateral diagram, when marked with counters. Interpretation of diagram representing XY exists. 36. And of 3 other similar arrangements. PG_XZ. Interpretation of diagram representing XY does not exist. And of 3 other similar arrangements. Interpretation of diagram representing X exists. 37. And of 3 other similar arrangements. Interpretation of diagram representing X exists with and without Y. And of 3 other similar arrangements. Interpretation of diagram representing X does not exist. And of 3 other similar arrangements. Interpretation of diagram representing all X are Y. And of 7 other similar arrangements. 38. Book 4. The trilateral diagram. Chapter I Symbols and Cells. Change of biliteral into triliteral diagram 39. The XY class subdivided into the XYM class and the XYM class 40 PG_XY inner and outer cells of the northwest quarter assigned to these classes the XY class, the XY class, and the XY class similarly subdivided the inner and outer cells of the northeast, the southwest, and the southeast quarter similarly assigned the inner square and the outer border have thus been assigned to the M class and the M class rules for finding readily the compartment, or cell, assigned to any given attribute or attributes table for attributes of classes, and compartments, or cells, assigned to them 42 Chapter 2. Representation of propositions in terms of X and M, or of Y and M1. Representation of propositions of existence in terms of X and M, or of Y and M. The propositions some XM exist 43. 7 other similar propositions. The proposition no XM exist 44. 7 other similar propositions 2. Representation of propositions of relation in terms of X and M, or of Y and M. The pair of converse propositions some XRM equals some MRX 7 other similar pairs. The pair of converse propositions no XRM equals no MRX 7 other similar pairs. The proposition all XRM 45. 15 other similar propositions. Table V. Representations of propositions in terms of X and M 46. Table 6. Representations of propositions in terms of Y and M 47. Table 7. Representations of propositions in terms of X and M 48. Table 8. Representations of propositions in terms of Y and M 49. PG_XIV Chapter 3. Representation of two propositions of relation, one in terms of X and M, and the other in terms of Y and M, on the same diagram. The digits I and O to be used instead of red and gray counters. 50 rules. Examples worked. Chapter 4. Interpretation, in terms of X and Y, of triliteral diagram, when marked with counters or digits. Rules 53. Examples worked. 54. Book V. Syllogisms. Chapter I. Introductory. Syllogism 56. Premises. Conclusion. Eliminans retinans. Consequent. The symbol therefore. Specimen. Syllogisms 57. PG_XV Chapter 2. Problems in syllogisms. 1. Introductory. Concrete and abstract propositions. 59. Method of translating a proposition from concrete into abstract form. 2 forms of problems. 2. Given a pair of propositions of relation, which contain between them a pair of codivisional classes, and which are proposed as premises, to ascertain what conclusion, if any, is consequent from them. Rules 60. Examples worked fully. The same worked briefly, as models 64. 3. Given a trio of propositions of relation, of which every two contain a pair of codivisional classes, and which are proposed as a syllogism, to ascertain whether the proposed conclusion is consequent from the proposed premises, and, if so, whether it is complete. Rules 66. Examples worked briefly, as models PG_XV Book 6. The method of subscripts. Chapter I. Introductory. Meaning of X1, XY1, and C.70 entity meaning of x0, xy0, and C. Nullity the symbols and like and unlike signs Chapter 2. Representation of propositions of relation. The pair of converse propositions some x are y equals some y are x 71. Three other similar pairs. The pair of converse propositions no x are y equals no y are x. Three other similar pairs. The proposition all x are y 72. The proposition all x are y is double, and is equivalent to the two propositions some x exist and no x and y. 7 other similar propositions. Rule for translating all x are y from abstract into subscript form, and vice versa. PG_XAY Chapter 3. Syllogisms. 1. Representation of syllogisms. Rules 73-2. Formulae for syllogisms. 3 formulae worked out. Fig. IXM0YM0XY075. Its two variants, alpha and beta. Fig. 2XM0YM1XY176. Fig. 3XM0YM0M1XY177. Table 9. Formulae and rules. 78 examples worked briefly, as models. 3. Fallacies. Fallacy 81. Method of finding forms of fallacies. 82 forms best stated in words. 3 forms of fallacies. 1. Fallacy of like eliminans not asserted to exist. 2. Fallacy of unlike eliminans with an entity premise. 83. 3. Fallacy of two entity premises. 4. Method of proceeding with a given pair of propositions. Rules 84. PG_XAT Book 7. Srites. Chapter I. Introductory. Srites 85. Premises. Partial conclusion, complete conclusion, or conclusion. Eliminans retinens consequent the symbol therefore specimen. Srites 86. Chapter 2. Problems in srites. 1. Introductory. Form of problem 87. 2 methods of solution. 2. Solution by method of separate syllogisms. Rules 88. Example worked. PG_XAX 3. Solution by method of underscoring. Underscoring 91. Subscripts to be omitted. Example worked fully. 92. Example worked briefly, as model 93. 17. Examination papers 94. Book 8. Examples, with answers and solutions. Chapter I. Examples. 1. Propositions of relation, to be reduced to normal form 97. 2. Pairs of abstract propositions, one in terms of x and m, and the other in terms of y and m, to be represented on the same triliteral diagram 98. 3. Marked triliteral diagrams, to be interpreted in terms of x and y 99. 4. Pairs of abstract propositions, proposed as premises, conclusions to be found 100. PG_XXX 5. Pairs of concrete propositions, proposed as premises, conclusions to be found 1016. Trios of abstract propositions, proposed as syllogisms, to be examined 1067. Trios of concrete propositions, proposed as syllogisms, To be examined 1078. Sets of abstract propositions, proposed as premises for treatises, conclusions to be found 110-9. Sets of concrete propositions, proposed as premises for treatises, conclusions to be found 112 Chapter 2. Answers. Answers to 1125, 2126, 3127, 4, 5128, 6137, 1131, 8132, 9 PG_XXI Chapter 3. Solutions. 1. Propositions of relation reduced to normal form. Solutions for 1134. 2. Method of diagrams. Solutions for four numbers 1 to 12,136, 5 1 to 12,138, 6 1 to 10,141, 7 1 to 6,144. 3. Method of subscripts. Solutions for 4146, 5 numbers 13 to 24,147, 6,148, 7,158, 1,155, 9,157. Notes 164. Appendix, addressed to teachers 165. Notes to Appendix 195. Index 1. Tables 1972. Words and see explained. PG_XXY PG001 Book I Things and Their Attributes. Chapter I Introductory. The universe contains things. For example, I London Roses Redness Old English Books the letter which I received yesterday. Things have attributes. For example, large red old which I received yesterday. One thing may have many attributes, and one attribute may belong to many things. Thus, the thing a rose may have the attributes red scented full-blown and C. And the attribute red may belong to the things a rose a brick a ribbon and C. Any attribute, or any set of attributes, may be called an adjunct. This word is introduced in order to avoid the constant repetition of the phrase attribute or set of attributes. Thus, we may say that a rose has the attribute red, or the adjunct red whichever we prefer, or we may say that it has the adjunct red, scented and full-blown. PG001 Chapter 2. Classification. Classification, or the formation of classes, is a mental process, in which we imagine that we have put together, in a group, certain things. Such a group is called a class. This process may be performed in three different ways, as follows. 1. We may imagine that we have put together all things. The class so formed, i.e. the class things, contains the whole universe. 2. We may think of the class things and may imagine that we have picked out from it all the things which possess a certain adjunct not possessed by the whole class. This adjunct is said to be peculiar to the class so formed. In this case, the class things is called a genus with regard to the class so formed. The class, so formed, is called a species of the class things, and its peculiar adjunct is called its differentia Pg002. As this process is entirely mental, we can perform it whether there is, or is not, an existing thing which possesses that adjunct. If there is, the class is said to be real; if not, it is said to be unreal, or imaginary. For example, we may imagine that we have picked out, from the class things, all the things which possess the adjunct material, artificial, consisting of houses and streets, and we may thus form the real class towns. Here we may regard things as a genus, towns as a species of things, and material, artificial, consisting of houses and streets as its differentia. Again, we may imagine that we have picked out all the things which possess the adjunct weighing a ton, easily lifted by a baby, and we may thus form the imaginary class things that weigh a ton and are easily lifted by a baby. 3. We may think of a certain class, not the class things, and may imagine that we have picked out from it all the members of it which possess a certain adjunct not possessed by the whole class. This adjunct is said to be peculiar to the smaller class so formed. In this case, the class thought of is called a genus with regard to the smaller class picked out from it. The smaller class is called a species of the larger, and its peculiar adjunct is called its differentia. For example, we may think of the class towns and imagine that we have picked out from it all the towns which possess the attribute lit with gas, and we may thus form the real class towns lit with gas. Here we may regard towns as a genus, towns lit with gas as a species of towns, and lit with gas as its differentia. If, in the above example, we were to alter lit with gas into paved with gold, we should get the imaginary class towns paved with gold. A class containing only one member is called an individual. For example, the class towns having 4 million inhabitants, which class contains only one member, viz. London, Pg002 hence, any single thing, which we can name so as to distinguish it from all other things, may be regarded as a one-member class. Thus London may be regarded as the one-member class, picked out from the class towns which has, as its differentia, having 4 million inhabitants. A class, containing 2 or more members, is sometimes regarded as one single thing. When so regarded, it may possess an adjunct which is not possessed by any member of it taken separately. Thus, the class the soldiers of the 10th Regiment, when regarded as one single thing, may possess the attribute formed in square which is not possessed by any member of it taken separately. Pg003 Chapter 3. Division 1. Introductory. Division is a mental process, in which we think of a certain class of things, and imagine that we have divided it into 2 or more smaller classes. Thus, we might think of the class books and imagine that we had divided it into the 2 smaller classes, bound books and unbound books, or into the 3 classes: books priced at less than a shilling books priced at more than a shilling, or into the 26 classes: books whose names begin with A, books whose names begin with B and C. A class that has been obtained by a certain division is said to be codivisional with every class obtained by that division. Thus, the class bound books is codivisional with each of the two classes, bound books and unbound books. Similarly, the Battle of Waterloo may be said to have been contemporary with every event that happened in 1815. Hence a class, obtained by division, is codivisional with itself. Thus, the class bound books is codivisional with itself. Similarly, the Battle of Waterloo may be said to have been contemporary with itself. Pg 0031/2. Dichotomy. If we think of a certain class, and imagine that we have picked out from it a certain smaller class, it is evident that the remainder of the large class does not possess the differentia of that smaller class. Hence it may be regarded as another smaller class, whose differentia may be formed from that of the class first picked out, by prefixing the word not, and we may imagine that we have divided the class first thought of into two smaller classes, whose differentiae are contradictory. This kind of division is called dichotomy. For example, we may divide books into the two classes whose differentiae are old and not old. In performing this process, we may sometimes find that the attributes we have chosen are used so loosely, in ordinary conversation, that it is not easy to decide which of the things belong to the one class and which to the other. In such a case, it would be necessary to lay down some arbitrary rule, as to where the one class should end and the other begin. Thus, in dividing books into old and not old, we may say let all books printed before AD 1801 be regarded as old and all others as not old. Henceforwards let it be understood that, if a class of things be divided into two classes, whose differentiae have contrary meanings, each differentia is to be regarded as equivalent to the other with the word not prefixed. Thus, if books be divided into old and new, the attribute old is to be regarded as equivalent to not new and the attribute new as equivalent to not old. Pg 004. After dividing a class, by the process of dichotomy, into two smaller classes, we may subdivide each of these into two still smaller classes, and this process may be repeated over and over again, the number of classes being doubled at each repetition. For example, we may divide books into old and new, i.e. not old. We may then subdivide each of these into English and foreign, i.e. not English, thus getting four classes, viz. 1. Old English, 2. Old Foreign, 3. New English, 4. New Foreign. If we had begun by dividing into English and foreign and had then subdivided into old and new, the four classes would have been 1. English Old, 2. English New, 3. Foreign Old, 4. Foreign New. The reader will easily see that these are the very same four classes which we had before. Pg 0041/2 Chapter 4. Names. The word thing, which conveys the idea of a thing, without any idea of an adjunct, represents any single thing. Any other word, or phrase, which conveys the idea of a thing, with the idea of an adjunct, represents anything which possesses that adjunct, i.e., it represents any member of the class to which that adjunct is peculiar. Such a word, or phrase, is called a name, and, if there be an existing thing which it represents, it is said to be a name of that thing. For example, the words thing, treasure, town, and the phrases valuable thing, material, artificial thing, consisting of houses and streets, town lit with gas, town paved with gold, Old English book. Just as a class is said to be real, or unreal, according as there is, or is not, an existing thing in it, so also a name is said to be real, or unreal, according as there is, or is not, an existing thing represented by it. Thus, town lit with gas is a real name, town paved with gold is an unreal name. Every name is either a substantive only, or else a phrase consisting of a substantive and one or more adjectives, or phrases used as adjectives. Every name, except thing, may usually be expressed in three different forms: a. the substantive thing, and one or more adjectives, or phrases used as adjectives, conveying the ideas of the attributes, pg 005, b. a substantive, conveying the idea of a thing with the ideas of some of the attributes, and one or more adjectives, or phrases used as adjectives, conveying the ideas of the other attributes, c. a substantive conveying the idea of a thing with the ideas of all the attributes. Thus, the phrase material living thing, belonging to the animal kingdom, having 2 hands and 2 feet is a name expressed in form, a. If we choose to roll up together the substantive thing and the adjectives material, living, belonging to the animal kingdom so as to make the new substantive animal, we get the phrase animal having 2 hands and 2 feet, which is a name, representing the same thing as before, expressed in form, b. And, if we choose to roll up the whole phrase into one word, so as to make the new substantive man, we get a name, still representing the very same thing, expressed in form, c. A name, whose substantive is in the plural number, may be used to represent either 1. members of a class, regarded as separate things, or 2. a whole class, regarded as one single thing. Thus, when I say some soldiers of the 10th Regiment are tall or the soldiers of the 10th Regiment are brave, I am using the name soldiers of the 10th Regiment in the first sense, and it is just the same as if I were to point to each of them separately, and to say this soldier of the 10th Regiment is tall, that soldier of the 10th Regiment is tall, and so on. But, when I say the soldiers of the 10th Regiment are formed in square, I am using the phrase in the second sense, and it is just the same as if I were to say the 10th Regiment is formed in square. PG 006 Chapter V Definitions. It is evident that every member of a species is also a member of the genus out of which that species has been picked, and that it possesses the differentia of that species. Hence it may be represented by a name consisting of 2 parts, one being a name representing any member of the genus, and the other being the differentia of that species. Such a name is called a definition of any member of that species, and to give it such a name is to define it. Thus, we may define a treasure as a valuable thing. In this case we regard things as the genus, and valuable as the differentia. The following examples of this process may be taken as models for working others. Note that, in each definition, the substantive, representing a member, or members, of the genus, is printed in capitals. 1. Define a treasure. ANS. A valuable thing. 2. Define treasures. ANS. Valuable things. 3. Define a town. ANS. A material artificial thing, consisting of houses and streets. PG 0074. Define men. ANS. Material, living things, belonging to the animal kingdom, having 2 hands and 2 feet, or else animals having 2 hands and 2 feet. 5. Define London. ANS. The material artificial thing, which consists of houses and streets, and has 4 million inhabitants, or else the town which has 4 million inhabitants. Note that we here use the article the instead of a, because we happen to know that there is only one such thing. The reader can set himself any number of examples of this process, by simply choosing the name of any common thing, such as house, tree, knife, making a definition for it, and then testing his answer by referring to any English dictionary. PG 008 Book 2. Propositions. Chapter I. Propositions generally. 1. Introductory. Note that the word some is to be regarded, henceforward, as meaning one or more. The word proposition as used in ordinary conversation, may be applied to any word, or phrase, which conveys any information whatever. Thus the words yes and no are propositions in the ordinary sense of the word, and so are the phrases you owe me 5 farthings and I don't. Such words as oh, or never, and such phrases as fetch me that book. Which book do you mean, do not seem, at first sight, to convey any information, but they can easily be turned into equivalent forms which do so, viz. I am surprised I will never consent to it. I order you to fetch me that book. I want to know which book you mean. But a proposition as used in this first part of symbolic logic has a peculiar form, which may be called its normal PG 009 form, and if any proposition, which we wish to use in an argument, is not in normal form, we must reduce it to such a form, before we can use it. A proposition when in normal form, asserts, as to certain 2 classes, which are called its subject and predicate either, 1. That some members of its subject are members of its predicate, or, 2. That no members of its subject are members of its predicate, or, 3. That all members of its subject are members of its predicate. The subject and the predicate of a proposition are called its terms. 2 propositions, which convey the same information, are said to be equivalent. Thus, the 2 propositions, I see John and John is seen by me, are equivalent. 2. Normal form of a proposition. A proposition, in normal form, consists of 4 parts, viz. 1. The word some or no or all. This word, which tells us how many members of the subject are also members of the predicate, is called the sign of quantity. 2. Name of subject. 3. The verb are, or is. This is called the copula. 4. Name of predicate. PG 0103. Various kinds of propositions. A proposition that begins with some is said to be particular. It is also called a proposition in I. Note that it is called particular because it refers to a part only of the subject. A proposition that begins with no is said to be universal negative. It is also called a proposition in E. A proposition that begins with all is said to be universal affirmative. It is also called a proposition in A. Note that they are called universal because they refer to the whole of the subject. A proposition whose subject is an individual is to be regarded as universal. Let us take, as an example, the proposition John is not well. This of course implies that there is an individual, to whom the speaker refers when he mentions John, and whom the listener knows to be referred to. Hence the class men referred to by the speaker when he mentions John is a one-member class, and the proposition is equivalent to all the men, who are referred to by the speaker when he mentions John, are not well. Propositions are of two kinds: propositions of existence and propositions of relation. These shall be discussed separately. pg 011 Chapter 2. Propositions of existence. A proposition of existence, when in normal form, has, for its subject, the class existing things. Its sign of quantity is some or no. Note that, though its sign of quantity tells us how many existing things are members of its predicate, it does not tell us the exact number. In fact, it only deals with two numbers, which are, in ascending order, 0 and 1 or more. It is called a proposition of existence because its effect is to assert the reality, i.e. the real existence, or else the imaginariness, of its predicate. Thus, the proposition some existing things are honest men asserts that the class honest men is real. This is the normal form, but it may also be expressed in any one of the following forms. 1. Honest men exist. 2. Some honest men exist. 3. The class honest men exists. 4. There are honest men. 5. There are some honest men. Similarly, the proposition no existing things are men 50 feet high asserts that the class men 50 feet high is imaginary. This is the normal form, but it may also be expressed in any one of the following forms. 1. Men 50 feet high do not exist. 2. No men 50 feet high exist. 3. The class men 50 feet high does not exist. 4. There are not any men 50 feet high. 5. There are no men 50 feet high. pg 012 Chapter 3. Propositions of relation. 1. Introductory. A proposition of relation, of the kind to be here discussed, has, for its terms, two species of the same genus, such that each of the two names conveys the idea of some attribute not conveyed by the other. Thus, the proposition some merchants are misers is of the right kind, since merchants and misers are species of the same genus men, and since the name merchants conveys the idea of the attribute mercantile, and the name misers the idea of the attribute miserly, each of which ideas is not conveyed by the other name. But the proposition some dogs are setters is not of the right kind, since, Although it is true that dogs and setters are species of the same genus animals, it is not true that the name dogs conveys the idea of any attribute not conveyed by the name setters. Such propositions will be discussed in Part 2. The genus, of which the two terms are species, is called the universe of discourse or, more briefly, the univ. The sign of quantity is some or no or all. Note that, though its sign of quantity tells us how many members of its subject are also members of its predicate, it does not tell us the exact number. In fact, it only deals with three numbers, which are, in ascending order, 0, 1 or more, the total number of members of the subject. It is called a proposition of relation because its effect is to assert that a certain relationship exists between its terms. pg 0132. Reduction of a proposition of relation to normal form. The rules for doing this are as follows. 1. Ascertain what is the subject, i.e., ascertain what class we are talking about. 2. If the verb, governed by the subject, is not the verb are, or is, substitute for it a phrase beginning with are, or is. 3. Ascertain what is the predicate, i.e., ascertain what class it is, which is asserted to contain some, or none, or all, of the members of the subject. 4. If the name of each term is completely expressed, i.e., if it contains a substantive, there is no need to determine the univ, but, if either name is incompletely expressed, and contains attributes only, it is then necessary to determine a univ, in order to insert its name as the substantive. 5. Ascertain the sign of quantity. 6. Arrange in the following order: sign of quantity, subject, copula, predicate. Let us work a few examples to illustrate these rules. 1. Some apples are not ripe. 1. The subject is apples. 2. The verb is are. 3. The predicate is not ripe ******. As no substantive is expressed, and we have not yet settled what the univ is to be, we are forced to leave a blank. 4. Let univ be fruit. 5. The sign of quantity is some. 6. The proposition now becomes some apples are not ripe fruit. pg 0142. None of my speculations have brought me as much as 5%. 1. The subject is my speculations. 2. The verb is have brought, for which we substitute the phrase are ****** that have brought. 3. The predicate is ***** that have brought and c. 4. Let univ be transactions. 5. The sign of quantity is none of. 6. The proposition now becomes none of my speculations are transactions that have brought me as much as 5%. 3. None but the brave deserve the fair. To begin with, we note that the phrase none but the brave is equivalent to no not brave. 1. The subject has for its attribute not brave, but no substantive is supplied. So we express the subject as not brave *****. 2. The verb is deserve, for which we substitute the phrase are deserving of. 3. the predicate is ***** deserving of the fair. 4. Let univ be persons. 5. The sign of quantity is no. 6. The proposition now becomes no, not brave persons are persons deserving of the fair. 4. A lame puppy would not say thank you if you offered to lend it a skipping rope. 1. The subject is evidently lame puppies and all the rest of the sentence must somehow be packed into the predicate. 2. The verb is would not say and see, for which we may substitute the phrase are not grateful for. 3. The predicate may be expressed as ***** not grateful for the loan of a skipping rope. 4. Let univ be puppies. 5. The sign of quantity is all. 6. The proposition now becomes all lame puppies are puppies not grateful for the loan of a skipping rope. pg 015. 5. No one takes in the times, unless he is well educated. 1. The subject is evidently persons who are not well educated. No one evidently means no person. 2. The verb is takes in, for which we may substitute the phrase are persons taking in. 3. The predicate is persons taking in the times. 4. Let univ be persons. 5. The sign of quantity is no. 6. The proposition now becomes no persons who are not well educated are persons taking in the times. 6. My carriage will meet you at the station. 1. The subject is my carriage. This, being an individual, is equivalent to the class my carriages. Note that this class contains only one member. 2. The verb is will meet, for which we may substitute the phrase are ***** that will meet. 3. The predicate is ***** that will meet you at the station. 4. Let univ be things. 5. The sign of quantity is all. 6. The proposition now becomes all my carriages are things that will meet you at the station. 7. Happy is the man who does not know what toothache means. 1. The subject is evidently the man and see. Note that in this sentence, the predicate comes first. At first sight, the subject seems to be an individual, but on further consideration, we see that the article the does not imply that there is only one such man. Hence the phrase the man who is equivalent to all men who. 2. The verb is are. 3. The predicate is happy *****. 4. Let univ be men. 5. The sign of quantity is all. 6. The proposition now becomes all men who do not know what toothache means are happy men. pg 016. 8. Some farmers always grumble at the weather, whatever it may be. 1. The subject is farmers. 2. The verb is grumble, for which we substitute the phrase are ***** who grumble. 3. The predicate is **** who always grumble and see. 4. Let univ be persons. 5. The sign of quantity is some. 6. The proposition now becomes some farmers are persons who always grumble at the weather, whatever it may be. 9. no lambs are accustomed to smoke cigars. 1. The subject is lambs. 2. The verb is are. 3. The predicate is accustomed and c. 4. Let univ be animals. 5. The sign of quantity is no. 6. The proposition now becomes no lambs are animals accustomed to smoke cigars. 10. I can't understand examples that are not arranged in regular order, like those I am used to. 1. The subject is examples that and see. 2. The verb is I can't understand, which we must alter, so as to have examples instead of I as the nominative case. It may be expressed as are not understood by me. 3. The predicate is not understood by me. 4. Let univ be examples. 5. The sign of quantity is all. 6. The proposition now becomes all examples that are not arranged in regular order, like those I am used to are examples not understood by me. PG 0173. A proposition of relation, beginning with all, is a double proposition. A proposition of relation, beginning with all, asserts, as we already know, that all members of the subject are members of the predicate. This evidently contains, as a part of what it tells us, the smaller proposition some members of the subject are members of the predicate. Thus, the proposition all bankers are rich men evidently contains the smaller proposition some bankers are rich men. The question now arises: what is the rest of the information which this proposition gives us? In order to answer this question, let us begin with the smaller proposition, some members of the subject are members of the predicate, and suppose that this is all we have been told, and let us proceed to inquire what else we need to be told, in order to know that all members of the subject are members of the predicate. Thus, we may suppose that the proposition some bankers are rich men is all the information we possess, and we may proceed to inquire what other proposition needs to be added to it, in order to make up the entire proposition all bankers are rich men. Let us also suppose that the univ, i.e. the genus, of which both the subject and the predicate are specieses, has been divided, by the process of dichotomy, into two smaller classes, viz. 1. The predicate, 2. The class whose differentiar is contradictory to that of the predicate. Thus, we may suppose that the genus men, of which both bankers and rich men are specieses, has been divided into the two smaller classes, rich men, poor men. PG 018. Now we know that every member of the subject is, as shown at P6, a member of the univ. Hence every member of the subject is either in class 1, or else in class 2. Thus, we know that every banker is a member of the genus men. Hence, every banker is either in the class rich men, or else in the class poor men. Also we have been told that, in the case we are discussing, some members of the subject are in class 1. What else do we need to be told, in order to know that all of them are there? Evidently we need to be told that none of them are in class 2, i.e. that none of them are members of the class whose differentiar is contradictory to that of the predicate. Thus, we may suppose we have been told that some bankers are in the class rich men. What else do we need to be told, in order to know that all of them are there? Evidently we need to be told that none of them are in the class poor men. Hence a proposition of relation, beginning with all, is a double proposition, and is equivalent to, i.e. gives the same information as, the two propositions, 1. Some members of the subject are members of the predicate, 2. No members of the subject are members of the class whose differentiar is contradictory to that of the predicate. Thus, the proposition all bankers are rich men is a double proposition, and is equivalent to the two propositions, 1. Some bankers are rich men, 2. No bankers are poor men. Pg 0194. What is implied, in a proposition of relation, as to the reality of its terms? Note that the rules, here laid down, are arbitrary, and only apply to part I of my symbolic logic. A proposition of relation, beginning with some, is henceforward to be understood as asserting that there are some existing things, which, being members of the subject, are also members of the predicate, i.e. that some existing things are members of both terms at once. Hence it is to be understood as implying that each term, taken by itself, is real. Thus, the proposition some rich men are invalids is to be understood as asserting that some existing things are rich invalids. Hence it implies that each of the two classes, rich men and invalids, taken by itself, is real. A proposition of relation, beginning with no, is henceforward to be understood as asserting that there are no existing things which, being members of the subject, are also members of the predicate, i.e. that no existing things are members of both terms at once. But this implies nothing as to the reality of either term taken by itself. Thus, the proposition no mermaids are milliners is to be understood as asserting that no existing things are mermaid milliners. But this implies nothing as to the reality, or the unreality, of either of the two classes, mermaids and milliners, taken by itself. In this case, as it happens, the subject is imaginary, and the predicate real. A proposition of relation, beginning with all, contains, c3, a similar proposition beginning with some. Hence it is to be understood as implying that each term, taken by itself, is real. Thus, the proposition all hyenas are savage animals contains the proposition some hyenas are savage animals. Hence it implies that each of the two classes, hyenas and savage animals, taken by itself, is real. Pg 0205. Translation of a proposition of relation into one or more propositions of existence. We have seen that a proposition of relation, beginning with some asserts that some existing things, being members of its subject, are also members of its predicate. Hence, it asserts that some existing things are members of both, i.e. it asserts that some existing things are members of the class of things which have all the attributes of the subject and the predicate. Hence, to translate it into a proposition of existence, we take existing things as the new subject, and things, which have all the attributes of the subject and the predicate, as the new predicate. Similarly for a proposition of relation beginning with no. A proposition of relation, beginning with all, is, as shown in 3, equivalent to two propositions, one beginning with some and the other with no, each of which we now know how to translate. Let us work a few examples, to illustrate these rules. 1. Some apples are not ripe. Here we arrange thus, some sign of quantity. Existing things subject. Are copula. Not ripe apples predicate. Or thus, some existing things are not ripe apples pg 021, 2. Some farmers always grumble at the weather, whatever it may be. Here we arrange thus, some existing things are farmers who always grumble at the weather, whatever it may be. 3. No lambs are accustomed to smoke cigars. Here we arrange thus, no existing things are lambs accustomed to smoke cigars. 4. None of my speculations have brought me as much as 5%. Here we arrange thus, no existing things are speculations of mine, which have brought me as much as 5%. 5. None but the brave deserve the fair. Here we note, to begin with, that the phrase none but the brave is equivalent to no not brave men. We then arrange thus, no existing things are not brave men deserving of the fair. 6. All bankers are rich men. This is equivalent to the two propositions some bankers are rich men and no bankers are poor men. Here we arrange thus, some existing things are rich bankers, and no existing things are poor bankers. Work examples 1, 1 4, p97, pg 022 book 3. The biliteral diagram. An annotated biliteral diagram chapter I symbols and cells. First, let us suppose that the above diagram is an enclosure assigned to a certain class of things, which we have selected as our universe of discourse or, more briefly, as our univ. For example, we might say let univ be books, and we might imagine the diagram to be a large table, assigned to all books. The reader is strongly advised, in reading this chapter, not to refer to the above diagram, but to draw a large one for himself, without any letters, and to have it by him while he reads, and keep his finger on that particular part of it, about which he is reading. Pg 023. Secondly, let us suppose that we have selected a certain adjunct, which we may call X, and have divided the large class, to which we have assigned the whole diagram, into the two smaller classes whose differentiae are X and not X, which we may call X, and that we have assigned the north half of the diagram to the one, which we may call the class of X things or the X class, and the south half to the other, which we may call the class of X things or the X class. For example, we might say let X mean old so that X will mean new, and we might suppose that we had divided books into the two classes whose differentiae are old and new, and had assigned the north half of the table to old books and the south half to new books. Thirdly, let us suppose that we have selected another adjunct, which we may call Y, and have subdivided the X class into the two classes whose differentiae are Y and Y, and that we have assigned the northwest cell to the one, which we may call the XY class, and the northeast cell to the other, which we may call the XY class. For example, we might say let Y mean English so that Y will mean foreign, and we might suppose that we had subdivided old books into the two classes whose differentiae are English and foreign, and had assigned the northwest cell to old English books, and the northeast cell to old foreign books. Fourthly, let us suppose that we have subdivided the X class in the same manner, and have assigned the southwest cell to the XY class, and the southeast cell to the XY class. For example, we might suppose that we had subdivided new books into the two classes New English books and New Foreign books, and had assigned the southwest cell to the one, and the southeast cell to the other. It is evident that, if we had begun by dividing for Y and Y, and had then subdivided for X and X, we should have got the PG024 same four classes. Hence we see that we have assigned the west half to the Y class, and the east half to the Y class. Diagram representing books. Thus, in the above example, we should find that we had assigned the west half of the table to English books and the east half to foreign books. We have, in fact, assigned the 4/4 of the table to 4 different classes of books, as here shown. The reader should carefully remember that, in such a phrase as the X things, the word things means that particular kind of things, to which the whole diagram has been assigned. Thus, if we say let univ be books, we mean that we have assigned the whole diagram to books. In that case, if we took X to mean old, the phrase the X things would mean the old books. The reader should not go on to the next chapter until he is quite familiar with the blank diagram I have advised him to draw. He ought to be able to name, instantly, the adjunct assigned to any compartment named in the right-hand column of the following table. Also he ought to be able to name, instantly, the compartment assigned to any adjunct named in the left-hand column. To make sure of this, he had better put the book into the hands of some genial friend, while he himself has nothing but the blank diagram, and get that genial friend to question him on this table, dodging about as much as possible. The questions and answers should be something like this. PG025 Table I adjuncts of classes. Compartments, or cells, assigned to them. X north half. X south Y west Y east X Y northwest cell. XY east XY southwest XY east Q adjunct for west half. A Y. Q compartment for XY. A northeast cell. Q adjunct for southwest cell. A XY dot. And C. After a little practice, he will find himself able to do without the blank diagram, and will be able to see it mentally, in my mind's eye, Horatio, while answering the questions of his genial friend. When this result has been reached, he may safely go on to the next chapter. PG026 Chapter 2. Counters. Let us agree that a red counter, placed within a cell, shall mean this cell is occupied, i.e. there is at least one thing in it. Let us also agree that a red counter, placed on the partition between two cells, shall mean the compartment, made up of these two cells, is occupied, but it is not known whereabouts, in it, its occupants are. Hence it may be understood to mean at least one of these two cells is occupied, possibly both are. Our ingenious American cousins have invented a phrase to describe the condition of a man who has not yet made up his mind which of two political parties he will join. Such a man is said to be sitting on the fence. This phrase exactly describes the condition of the red counter. Let us also agree that a gray counter, placed within a cell, shall mean this cell is empty, i.e. there is nothing in it. The reader had better provide himself with 4 red counters and 5 gray ones. pg 027 Chapter 3. Representation of propositions. 1. Introductory. Henceforwards, in stating such propositions as some X things exist or no X things are Y things, I shall omit the word things, which the reader can supply for himself, and shall write them as some X exist or no X are Y. Note that the word things is here used with a special meaning, as explained at p. 23. A proposition, containing only one of the letters used as symbols for attributes, is said to be unilateral. For example, some X exist, no Y exist, and c. A proposition, containing 2 letters, is said to be bilateral. For example, some X Y exist, no X are Y, and c. A proposition is said to be in terms of the letters it contains, whether with or without accents. Thus, some X Y exist, no X are Y, and C, are said to be in terms of X and Y. pg 0282. Representation of propositions of existence. Let us take, first, the proposition some X exist. Note that this proposition is, as explained at p. 12, equivalent to some existing things are X things. Diagram representing X exists. This tells us that there is at least one thing in the north half, that is, that the north half is occupied. And this we can evidently represent by placing a red counter, here represented by a dotted circle, on the partition which divides the north half. In the book's example, this proposition would be some old books exist. Similarly, we may represent the 3 similar propositions some X exist, some Y exist, and some Y exist. The reader should make out all these for himself. In the book's example, these propositions would be some new books exist, and c. Let us take, next, the proposition no X exist. Diagram representing X does not exist. This tells us that there is nothing in the north half, that is, that the north half is empty, that is, that the northwest cell and the northeast cell are both of them empty. And this we can represent by placing 2 gray counters in the north half, 1 in each cell. The reader may perhaps think that it would be enough to place a gray counter on the partition in the north half, and that, just as a red counter, so placed, would mean this half is occupied, so a gray one would mean this half is empty. This, however, would be a mistake. We have seen that a red counter, so placed, would mean at least one of these two cells is occupied, possibly both are. Hence a gray one would merely mean at least one of these two cells is empty, possibly both are. But what we have to represent is that both cells are certainly empty, and this can only be done by placing a gray counter in each of them. In the book's example, this proposition would be no old books exist. Pg 029. Similarly, we may represent the three similar propositions no X exist, no Y exist, and no Y exist. The reader should make out all these for himself. In the book's example, these three propositions would be no new books exist, and C. Let us take, next, the proposition some XY exist. Diagram representing XY exists. This tells us that there is at least one thing in the northwest cell, that is, that the northwest cell is occupied. And this we can represent by placing a red counter in it. In the book's example, this proposition would be some old English books exist. Similarly, we may represent the three similar propositions some XY exist, some XY exist, and some XY exist. The reader should make out all these for himself. In the book's example, these three propositions would be some old foreign books exist, and C. Let us take, next, the proposition no XY exist. Diagram representing XY does not exist. This tells us that there is nothing in the northwest cell, that is, that the northwest cell is empty. And this we can represent by placing a gray counter in it. In the book's example, this proposition would be no old English books exist. Similarly, we may represent the three similar propositions no XY exist, no XY exist, and no XY exist. The reader should make out all these for himself. In the book's example, these three propositions would be no old foreign books exist, and C. Pg 030. Diagram representing X does not exist. We have seen that the proposition no X exist may be represented by placing two gray counters in the north half, one in each cell. We have also seen that these two gray counters, taken separately, represent the two propositions no XY exist and no XY exist. Hence we see that the proposition no X exist is a double proposition, and is equivalent to the two propositions no XY exist and no XY exist. In the book's example, this proposition would be no old books exist. Hence this is a double proposition, and is equivalent to the two propositions no old English books exist and no old foreign books exist. 3. Representation of propositions of relation. Let us take, first, the proposition some X are Y. Diagram representing XY exists. This tells us that at least one thing, in the north half, is also in the west half. Hence it must be in the space common to them, that is, in the northwest cell. Hence the northwest cell is occupied. And this we can represent by placing a red counter in it. Note that the subject of the proposition settles which half we are to use, and that the predicate settles in which portion of it we are to place the red counter. In the book's example, this proposition would be some old books are English. Similarly, we may represent the three similar propositions some X are Y, some X are Y, and some X are Y. The reader should make out all these for himself. In the book's example, these three propositions would be some old books are foreign, and C. pg 031. Let us take, next, the proposition some Y are X. Diagram representing XY exists. This tells us that at least one thing, in the west half, is also in the north half. Hence it must be in the space common to them, that is, in the northwest cell. Hence the northwest cell is occupied. And this we can represent by placing a red counter in it. In the book's example, this proposition would be some English books are old. Similarly, we may represent the three similar propositions some Y are X, some Y are X, and some Y are X. The reader should make out all these for himself. In the book's example, these three propositions would be some English books are new, and C. Diagram representing XY exists. We see that this one diagram has now served to represent no less than three propositions, viz. 1. Some XY exist, 2. Some X are Y, 3. Some Y are X. Hence these three propositions are equivalent. In the book's example, these propositions would be 1. Some old English books exist, 2. Some old books are English, 3. Some English books are old. The two equivalent propositions, some X are Y and some Y are X, are said to be converse to each other, and the process of changing one into the other is called converting, or conversion. For example, if we were told to convert the proposition some apples are not ripe, we should first choose our univ. Say fruit, and then complete the proposition by supplying the substantive fruit in the predicate, so that it would be some apples are not ripe fruit, and we should then convert it by interchanging its terms, so that it would be some not ripe fruit are apples. pg 032. Similarly, we may represent the three similar trios of equivalent propositions, the whole set of four trios being as follows. 1. Some XY exist equals some X are Y equals some Y are X. 2. Some XY exist equals some X are Y equals some Y are X. 3. Some XY exist equals some X are Y equals some Y are X. 4. Some XY exist equals some X are Y equals some Y are X. Let us take, next, the proposition no X are Y. Diagram representing XY does not exist. This tells us that no thing, in the north half, is also in the west half. Hence there is nothing in the space common to them, that is, in the northwest cell. Hence the northwest cell is empty. And this we can represent by placing a grey counter in it. In the book's example, this proposition would be no old books are English. Similarly, we may represent the three similar propositions no X are Y, and no X are Y, and no X are Y. The reader should make out all these for himself. In the book's example, these three propositions would be no old books are foreign, and C. Let us take, next, the proposition no Y are X. Diagram representing xy does not exist. This tells us that no thing, in the west half, is also in the north half. Hence there is nothing in the space common to them, that is, in the northwest cell. That is, the northwest cell is empty. And this we can represent by placing a gray counter in it. In the book's example, this proposition would be no English books are old. Similarly, we may represent the three similar propositions no yrx, no yrx, and no yrx. The reader should make out all these for himself. In the book's example, these three propositions would be no English books are new, and C.PG033 diagram representing xy does not exist. We see that this one diagram has now served to present no less than three propositions, viz. 1. No xy exist, 2. No xry, 3. No yrx. Hence these three propositions are equivalent. In the book's example, these propositions would be 1. No old English books exist, 2. No old books are English, 3. No English books are old. The two equivalent propositions, no xry and no yrx, are said to be converse to each other. For example, if we were told to convert the proposition no porcupines are talkative, we should first choose our univ. Say animals, and then complete the proposition, by supplying the substantive animals in the predicate, so that it would be no porcupines are talkative animals, and we should then convert it, by interchanging its terms, so that it would be no talkative animals are porcupines. Similarly, we may represent the three similar trios of equivalent propositions, the whole set of four trios being as follows: 1. No xy exist equals no xry equals no yrx. 2. No xy exist equals no xry equals no yrx. 3. No xy exist equals no xry equals no yrx. 4. No xy exist equals no xry equals no yrx. Diagram representing all xry. Let us take, next, the proposition all xry. We know, CP 17, that this is a double proposition, and equivalent to the two propositions some xry and no xry, each of which we already know how to represent. Note that the subject of the given proposition settles which half we are to use, and that its predicate settles in which portion of that half we are to place the red counter. PG034 Table 2. Some x exist diagram representing x exists no x exist diagram representing x does not exist some x exist diagram representing x prime exists no x exist diagram representing x prime does not exist some y exist diagram representing y exists no y exist diagram representing y does not exist some y exist diagram representing y prime exists no y exist diagram representing y prime does not exist. Similarly, we may represent the seven similar propositions all x are y, all x are y, all x are y, all y are x, all y are x, all y are x, and all y are x. Diagram representing x exists. Let us take, lastly, the double proposition some x are y and some are y, each part of which we already know how to represent. Similarly, we may represent the three similar propositions, some x are y and some are y, some y are x and some are x, some y are x and some are x. The reader should now get his genial friend to question him, severely, on these two tables. The inquisitor should have the tables before him, but the victim should have nothing but a blank diagram, and the counters with which he is to represent the various propositions named by his friend. For example, some y exist, no y are x, all x are y, and C and CPG 035 Table 3. Some x y exist equals some x are y equals some y are x. Diagram representing x y exists all x are y. Diagram representing all x are y. Some x y exist equals some x are y equals some y are x. Diagram representing x y exists all x are y. Diagram representing all x are y prime. Some x y exist equals some x are y equals some y are x. Diagram representing x y exists all x are y. Diagram representing all x prime are y. Some x y exist equals some x are y equals some y are x. Diagram representing x prime y prime exists all x are y. Diagram representing all x prime are y prime no x y exist equals no x are y equals no y are x. Diagram representing x y does not exist all y are x. Diagram representing all y are x no x y exist equals no x are y equals no y are x. Diagram representing x y prime does not exist all y are x. Diagram representing all y are x prime no x y exist equals no x are y equals no y are x. Diagram representing x prime y does not exist all y are x. Diagram representing all y prime are x no x y exist equals no x are y equals no y are x. Diagram representing x prime y prime does not exist all y are x. Diagram representing all y prime are x prime some x are y, and some are y. Diagram representing x exists with and without y. Some y are x and some are x. Diagram representing y exists with and without x. Some x are y, and some are y. Diagram representing x prime exists with and without y. Some y are x and some are x. Diagram representing y prime exists with and without x. PG 036 Chapter 4. Interpretation of biliteral diagram when marked with counters. The diagram is supposed to be set before us, with certain counters placed upon it, and the problem is to find out what proposition, or propositions, the counters represent. As the process is simply the reverse of that discussed in the previous chapter, we can avail ourselves of the results there obtained, as far as they go. Diagram representing x y exists first. Let us suppose that we find a red counter placed in the northwest cell. We know that this represents each of the trio of equivalent propositions some x y exist equals some x are y equals some y are x. Similarly, we may interpret a red counter, when placed in the northeast, or southwest, or southeast cell. Diagram representing x y does not exist. Next, let us suppose that we find a gray counter placed in the northwest cell. We know that this represents each of the trio of equivalent propositions no x y exist equals no x are y equals no y are x. Similarly, we may interpret a gray counter, when placed in the northeast, or southwest, or southeast cell. PG037 diagram representing X exists next. Let us suppose that we find a red counter placed on the partition which divides the north half. We know that this represents the proposition some X exist. Similarly, we may interpret a red counter, when placed on the partition which divides the south, or west, or east half. Diagram representing X exists with and without Y next. Let us suppose that we find two red counters placed in the north half, one in each cell. We know that this represents the double proposition some X are Y and some are Y. Similarly, we may interpret two red counters, when placed in the south, or west, or east half. Diagram representing X does not exist next. Let us suppose that we find two gray counters placed in the north half, one in each cell. We know that this represents the proposition no X exist. Similarly, we may interpret two gray counters, when placed in the south, or west, or east half. Diagram representing all X are Y. Lastly, let us suppose that we find a red and a gray counter placed in the north half, the red in the northwest cell, and the gray in the northeast cell. We know that this represents the proposition, all X are Y. Note that the half, occupied by the two counters, settles what is to be the subject of the proposition, and that the cell, occupied by the red counter, settles what is to be its predicate. PG038. Similarly, we may interpret a red and a gray counter, when placed in any one of the 7 similar positions: red in northeast, gray in northwest, red in southwest, gray in southeast, red in southeast, gray in southwest, red in northwest, gray in southwest, red in southwest, gray in northwest, red in northeast, gray in southeast, red in southeast, gray in northeast. Once more, the genial friend must be appealed to, and requested to examine the reader on tables 2 and 3, and to make him not only represent propositions, but also interpret diagrams when marked with counters. The questions and answers should be like this: Q represent no X or Y. A gray counter in SE cell. Q interpret red counter on E partition. A some Y exist. Q represent all Y are X. A red in NE cell, gray in SE. Q interpret gray counter in SW cell. A no XY exist equals no XRY equals no YRX. And C. At first, the examinee will need to have the board and counters before him, but he will soon learn to dispense with these, and to answer with his eyes shut or gazing into vacancy. Work examples 1, 5, 8, P97. PG039 Book 4. The triliteral diagram. An annotated biliteral diagram. An annotated triliteral diagram. Chapter I. Symbols and cells. First, let us suppose that the above left-hand diagram is the biliteral diagram that we have been using in Book 3. And that we change it into a triliteral diagram by drawing an inner square, so as to divide each of its 4 cells into 2 portions, thus making 8 cells altogether. The right-hand diagram shows the result. The reader is strongly advised, in reading this chapter, not to refer to the above diagrams, but to make a large copy of the right-hand one for himself, without any letters, and to have it by him while he reads, and keep his finger on that particular part of it, about which he is reading. Pg 040. Secondly, let us suppose that we have selected a certain adjunct, which we may call M, and have subdivided the XY class into the two classes whose differentiae are M and M, and that we have assigned the NW inner cell to the one, which we may call the class of XYM things, or the XYM class, and the NW outer cell to the other, which we may call the class of XYM things, or the XYM class. Thus, in the book's example, we might say let M mean bound, so that M will mean unbound, and we might suppose that we had subdivided the class Old English books into the two classes, Old English bound books and Old English unbound books, and had assigned the NW inner cell to the one, and the NW outer cell to the other. Thirdly, let us suppose that we have subdivided the XY class, the XY class, and the XY class in the same manner, and have, in each case, assigned the inner cell to the class possessing the attribute M, and the outer cell to the class possessing the attribute M. Thus, in the book's example, we might suppose that we had subdivided the New English books into the two classes, New English bound books and New English unbound books, and had assigned the SW inner cell to the one, and the SW outer cell to the other. It is evident that we have now assigned the inner square to the M class, and the outer border to the M class. Thus, in the book's example, we have assigned the inner square to bound books and the outer border to unbound books. When the reader has made himself familiar with this diagram, he ought to be able to find, in a moment, the compartment assigned to a particular pair of attributes, or the cell assigned to a particular trio of attributes. The following rules will help him in doing this. 1. Arrange the attributes in the order X, Y, MPG 041. 2. Take the first of them and find the compartment assigned to it. 3. Then take the second, and find what portion of that compartment is assigned to it. 4. Treat the third, if there is one, in the same way. For example, suppose we have to find the compartment assigned to YM. We say to ourselves Y has the west half, and M has the inner portion of that west half. Again, suppose we have to find the cell assigned to XYM. We say to ourselves X has the south half, Y has the west portion of that south half, i.e. has the southwest quarter, and M has the outer portion of that southwest quarter. The reader should now get his genial friend to question him on the table given on the next page, in the style of the following specimen dialogue. Q adjunct for south half, inner portion. AXM. Q compartment for M. A the outer border. Q adjunct for northeast quarter, outer portion. XYM. Q compartment for YM. A west half, inner portion. Q adjunct for south half. X. Q compartment for XYM. A southeast quarter, inner portion. and C and CPG042 Table 4. Adjunctive classes. Compartments, or cells, assigned to them. X north half. X south Y west Y east M inner square. M outer border. X Y northwest quarter. X Y east X Y southwest X Y east X M north half inner portion. X M outer X M south inner X M outer Y M west inner Y M outer Y M east inner Y M outer X Y M northwest quarter, inner portion. XYM outer XYM east inner XYM outer XYM southwest inner XYM outer XYM east inner XYM outer PG043 Chapter 2. Representation of propositions in terms of X and M, or of Y and M1. Representation of propositions of existence in terms of X and M, or of Y and M. Diagram representing XM exists. Let us take, first, the proposition some XM exist. Note that the full meaning of this proposition is, as explained at p12, some existing things are XM things. This tells us that there is at least one thing in the inner portion of the north half, that is, that this compartment is occupied. And this we can evidently represent by placing a red counter on the partition which divides it. In the book's example, this proposition would mean some old bound books exist, or there are some old bound books. Similarly, we may represent the 7 similar propositions: some XM exist, some XM exist, some XM exist, some YM exist, some YM exist, some YM exist, and some YM exist. Diagram representing XM does not exist. PG044. Let us take, next, the proposition no XM exist. This tells us that there is nothing in the inner portion of the north half, that is, that this compartment is empty. And this we can represent by placing 2 gray counters in it, one in each cell. Similarly, we may represent the 7 similar propositions, in terms of X and M, or of Y and M, viz. No XM exist, no XM exist, and C. These 16 propositions of existence are the only ones that we shall have to represent on this diagram. 2. Representation of propositions of relation in terms of X and M, or of Y and M. Diagram representing XM exists. Let us take, first, the pair of converse propositions some X are M equals some M are X. We know that each of these is equivalent to the proposition of existence some XM exist, which we already know how to represent. Similarly, for the 7 similar pairs, in terms of X and M, or of Y and M. Diagram representing XM does not exist. Let us take, next, the pair of converse propositions no X are M equals no M are X. We know that each of these is equivalent to the proposition of existence no XM exist, which we already know how to represent. Similarly, for the 7 similar pairs, in terms of X and M, or of Y and M. Diagram representing all X are M. PG045. Let us take, next, the proposition all X are M. We know, CP18, that this is a double proposition, and equivalent to the 2 propositions some X are M and no X are M, each of which we already know how to represent. Similarly for the 15 similar propositions, in terms of x and m, or of y and m. These 32 propositions of relation are the only ones that we shall have to represent on this diagram. The reader should now get his genial friend to question him on the following 4 tables. The victim should have nothing before him but a blank triliteral diagram, a red counter, and 2 grey ones, with which he is to represent the various propositions named by the inquisitor, for example no yrm, some xm exist, and c. PG 046 Table V diagram representing xm exists some xm exist equals some xrm equals some mrx diagram representing xm does not exist no xm exist equals no xrm equals no mrx diagram representing xm prime exists some xm exist equals some xrm equals some mrx diagram representing xm prime does not exist no xm exist equals no xrm equals no mrx diagram representing x prime m exists some xm exist equals some xrm equals some mrx diagram representing x prime m does not exist no xm exist equals no xrm equals no mrx diagram representing x prime m prime exists some xm exist equals some xrm equals some mrx diagram representing x prime m prime does not exist no xm exist equals no xrm equals no mrx PG 047 Table 6 diagram representing ym exists some ym exist equals some yrm equals some mry diagram representing ym does not exist no ym exist equals no yrm equals no mry diagram representing ym prime exists some ym exist equals some yrm equals some mry diagram representing ym prime does not exist no ym exist equals no yrm equals no mry diagram representing y prime m exists some ym exist equals some yrm equals some mry diagram representing y prime m does not exist no ym exist equals no yrm equals no mry diagram representing y prime m prime exists some ym exist equals some yrm equals some mry diagram representing y prime m prime does not exist no ym exist equals no yrm equals no mry PG 048 Table 7 diagram representing all xrm diagram representing all xrm prime all xrm diagram representing all x prime rm all xrm diagram representing all x prime rm prime all xrm diagram representing all mrx diagram representing all mrx prime all mrx diagram representing all m prime rx all mrx diagram representing all m prime rx prime all mrx PG 049 Table 8 diagram representing all yrm diagram representing all yrm prime all yrm diagram representing all y prime rm all yrm diagram representing all y prime rm prime all yrm diagram representing all mry diagram representing all mry prime all mry diagram representing all m prime ry all mry diagram representing all m prime ry prime all mry PG 050 Chapter 3 representation of two propositions of relation, one in terms of x and m, and the other in terms of y and m, on the same diagram. The reader had better now begin to draw little diagrams for himself, and to mark them with the digits I and O. Instead of using the board and counters, he may put AI to represent a red counter. This may be interpreted to mean there is at least one thing here, and AO to represent a gray counter. This may be interpreted to mean there is nothing here. The pair of propositions that we shall have to represent will always be one in terms of x and m, and the other in terms of y and m. When we have to represent a proposition beginning with all, we break it up into the two propositions to which it is equivalent. When we have to represent, on the same diagram, propositions, of which some begin with some and others with no, we represent the negative ones first. This will sometimes save us from having to put AI on a fence and afterwards having to shift it into a cell. Let us work a few examples. 1. No XRM, no YRM. Let us first represent no XRM. This gives us diagram A. Then, representing no YRM on the same diagram, we get diagram BPG051AB. Diagram representing XM' does not exist. Diagram representing XM' and Y'M do not exist. 2. Some MRX, no MRY. If, neglecting the rule, we were begin with some MRX, we should get diagram A. And if we were then to take no MRY, which tells us that the inner NW cell is empty, we should be obliged to take the I off the fence, as it no longer has the choice of two cells, and to put it into the inner NE cell, as in diagram C. This trouble may be saved by beginning with no MRY, as in diagram B. And now, when we take some MRX, there is no fence to sit on. The I has to go, at once, into the NE cell, as in diagram CABC. Diagram A representing XM exists. Diagram B representing YM does not exist. Diagram C representing XM exists and YM does not exist. 3. No XRM, all MRY. Here we begin by breaking up the second into the two propositions to which it is equivalent. Thus we have three propositions to represent, viz. 1. No XRM, 2. Some MRY, 3. No MRY. These we will take in the order 1, 3, 2. First we take no. 1, viz. No XRM. This gives us diagram A PG052. Adding to this, no. 3, viz. No MRY, we get diagram B. This time the I, representing no. 2, viz. Some MRY has to sit on the fence, as there is no O to order it off. This gives us diagram CABC. Diagram A representing X'M' does not exist. Diagram B representing X'M' and Y'M do not exist. Diagram C representing X'M' and Y'M do not exist and Ym does exist. 4. All MRX, all YRM. Here we break up both propositions, and thus get 4 to represent, viz. 1. Some MRX, 2. No MRX, 3. Some YRM, 4. No YRM. These we will take in the order 2, 4, 1, 3. First we take no. 2, viz. No MRX. This gives us diagram A. To this we add no. 4, viz. No YRM, and thus get diagram B. If we were to add to this no. 1, viz. Some MRX, we should have to put the I on a fence, so let us try no. 3, instead, viz. Some YRM. This gives us diagram C. And now there is no need to trouble about no. 1, as it would not add anything to our information to put AI on the fence. The diagram already tells us that some MRX dot ABC diagram A representing X prime M does not exist. Diagram B representing X prime M prime and Y M prime do not exist. Diagram C representing X prime M prime and Y prime M do not exist and Y M does exist. Work examples 1, 9, 12, P97, 2, 120, P98. PG 053 Chapter 4. Interpretation, in terms of X and Y, of triliteral diagram, when marked with counters or digits. The problem before us is, given a marked triliteral diagram, to ascertain what propositions of relation, in terms of X and Y, are represented on it. The best plan, for a beginner, is to draw a biliteral diagram alongside of it, and to transfer, from the one to the other, all the information he can. He can then read off, from the biliteral diagram, the required propositions. After a little practice, he will be able to dispense with the biliteral diagram, and to read off the result from the triliteral diagram itself. To transfer the information, observe the following rules. 1. Examine the NW quarter of the triliteral diagram. 2. If it contains AI, in either cell, it is certainly occupied, and you may mark the NW quarter of the biliteral diagram with AI. 3. If it contains two OS, one in each cell, it is certainly empty, and you may mark the NW quarter of the biliteral diagram with AO. PG 054, 4. Deal in the same way with the NE, the SW, and the SE quarter. Let us take, as examples, the results of the 4 examples worked in the previous chapters. 1. Diagram representing example 1 in the NW quarter, only one of the two cells is marked as empty, so we do not know whether the NW quarter of the biliteral diagram is occupied or empty, so we cannot mark it. Diagram representing conclusion of example 1 in the NE quarter, we find 2 OS, so this quarter is certainly empty, and we mark it so on the biliteral diagram. In the SW quarter, we have no information at all. In the SE quarter, we have not enough to use. We may read off the result as no XRY, or no YRX, whichever we prefer. 2. Diagram representing example 2 in the NW quarter, we have not enough information to use. Diagram representing conclusion of example 2 in the NE quarter, we find AI. This shows us that it is occupied, so we may mark the NE quarter on the biliteral diagram with AI. In the SW quarter, we have not enough information to use. In the SE quarter, we have none at all. We may read off the result as some x are y, or some y are x, whichever we prefer. PG 055, 3. Diagram representing example 3 in the NW quarter, we have no information. The I, sitting on the fence, is of no use to us until we know on which side he means to jump down. Diagram representing conclusion of example 2 in the NE quarter, we have not enough information to use. Neither have we in the SW quarter. The SE quarter is the only one that yields enough information to use. It is certainly empty, so we mark it as such on the bilateral diagram. We may read off the results as no x are y, or no y are x, whichever we prefer. 4. Diagram representing example 4. Diagram representing partial conclusion of example 4. The NW quarter is occupied, in spite of the O in the outer cell. So we mark it with a I on the bilateral diagram. The NE quarter yields no information. Diagram representing complete conclusion of example 4. The SW quarter is certainly empty. So we mark it as such on the bilateral diagram. The SE quarter does not yield enough information to use. We read off the result as all y are x. Review tables v. 6, pp 46, 47. Work examples 1, 13, 16, p 97, 2, 21, 32, p 98, 3, 120, p 99. PG 056 Book V Syllogisms. Chapter I Introductory. When a trio of bilateral propositions of relation is such that 1. All their 6 terms are species of the same genus, 2. Every 2 of them contain between them a pair of codivisional classes, 3. The 3 propositions are so related that, if the first 2 were true, the third would be true. The trio is called a syllogism. The genus, of which each of the 6 terms is a species, is called its universe of discourse, or, more briefly, its univ. The first 2 propositions are called its premises, and the third its conclusion. Also the pair of codivisional terms in the premises are called its eliminans, and the other 2 its retinans. The conclusion of a syllogism is said to be consequent from its premises, hence it is usual to prefix to it the word therefore, or the symbol therefore. PG 057. Note that the eliminans are so called because they are eliminated, and do not appear in the conclusion, and that the retinans are so called because they are retained, and do appear in the conclusion. Note also that the question, whether the conclusion is or is not consequent from the premises, is not affected by the actual truth or falsity of any of the trio, but depends entirely on their relationship to each other. As a specimen syllogism, let us take the trio no x things are m things, no y things are m things. No x things are y things, which we may write, as explained at p 26, thus, no x are m, no y are m. No x are y. Here the first and second contain the pair of codivisional classes m and m, the first and third contain the pair x and x, and the second and third contain the pair y and y. Also the three propositions are, as we shall see hereafter, so related that, if the first two were true, the third would also be true. Hence the trio is a syllogism. The two propositions, no XRM and no YRM, are its premises. The proposition no XRY is its conclusion. The terms M and M are its eliminans, and the terms X and Y are its retinans. Hence we may write it thus, no XRM, no YRM. Therefore no XRY. As a second specimen, let us take the trio all cats understand French, some chickens are cats. Some chickens understand French. These, put into normal form, are all cats are creatures understanding French, some chickens are cats. Some chickens are creatures understanding French. Here all the six terms are species of the genus creatures. Also the first and second propositions contain the pair of codivisional classes cats and cats. The first and third contain the pair creatures understanding French and creatures understanding French, and the second and third contain the pair chickens and chickens. pg 058. Also the three propositions are, as we shall see at p64, so related that, if the first two were true, the third would be true. The first two are, as it happens, not strictly true in our planet. But there is nothing to hinder them from being true in some other planet, say Mars or Jupiter, in which case the third would also be true in that planet, and its inhabitants would probably engage chickens as nursery governesses. They would thus secure a singular contingent privilege, unknown in England, namely, that they would be able, at any time when provisions ran short, to utilize the nursery governess for the nursery dinner. Hence the trio is a syllogism, the genus creatures is its univ. The two propositions, all cats understand French and some chickens are cats, are its premises. The proposition some chickens understand French is its conclusion. The terms cats and cats are its eliminans, and the terms creatures understanding French and chickens are its retinans. Hence we may write it thus, all cats understand French, some chickens are cats, therefore some chickens understand French. pg 059 Chapter 2. Problems in syllogisms. 1. Introductory. When the terms of a proposition are represented by words, it is said to be concrete, when by letters, abstract. To translate a proposition from concrete into abstract form, we fix on a univ, and regard each term as a species of it, and we choose a letter to represent its differentia. For example, suppose we wish to translate some soldiers are brave into abstract form. We may take men as univ, and regard soldiers and brave men as species of the genus men, and we may choose X to represent the peculiar attribute, say military, of soldiers and Y to represent brave. Then the proposition may be written some military men are brave men, i.e. some X men are Y men, i.e., omitting men as explained at p26, some X are Y. In practice, we should merely say let univ be men, X equals soldiers, Y equals brave, and at once translate some soldiers are brave into some X are Y. The problems we shall have to solve are of two kinds. viz. 1. Given a pair of propositions of relation, which contain between them a pair of codivisional classes, and which are proposed as premises, to ascertain what conclusion, if any, is consequent from them. 2. Given a trio of propositions of relation, of which every two contain a pair of codivisional classes, and which are proposed as a syllogism, to ascertain whether the proposed conclusion is consequent from the proposed premises, and, if so, whether it is complete. These problems we will discuss separately. PG 0602. Given a pair of propositions of relation, which contain between them a pair of codivisional classes, and which are proposed as premises, to ascertain what conclusion, if any, is consequent from them. The rules for doing this are as follows. 1. Determine the universe of discourse. 2. Construct a dictionary, making M and M, or M and M, represent the pair of codivisional classes, and X, or X, and Y, or Y, the other two. 3. Translate the proposed premises into abstract form. 4. Represent them, together, on a triliteral diagram. 5. Ascertain what proposition, if any, in terms of X and Y, is also represented on it. 6. Translate this into concrete form. It is evident that, if the proposed premises were true, this other proposition would also be true. Hence it is a conclusion consequent from the proposed premises. Let us work some examples. 1. No son of mine is dishonest. People always treat an honest man with respect. Taking men as univ, we may write these as follows. No sons of mine are dishonest men, all honest men are men treated with respect. We can now construct our dictionary, viz. M equals honest, X equals sons of mine, Y equals treated with respect. Note that the expression X equals sons of mine is an abbreviated form of X equals the differentiar of sons of mine, when regarded as a species of men. The next thing is to translate the proposed premises into abstract form, as follows. No X are M, all M are Y. Diagram representing X M prime does not exist and all M are Y. PG 061. Next, by the process described at P50, we represent these on a triliteral diagram. Thus, diagram representing X Y prime does not exist. Next, by the process described at P53, we transfer to a biliteral diagram all the information we can. The result we read as no X are Y or as no Y are X, whichever we prefer. So we refer to our dictionary, to see which will look best, and we choose no X are Y, which, translated into concrete form, is no son of mine fails to be treated with respect. 2. All cats understand French, some chickens are cats. Taking creatures as univ, we write these as follows. All cats are creatures understanding French, some chickens are cats. We can now construct our dictionary, viz. M equals cats, X equals understanding French, Y equals chickens. The proposed premises, translated into abstract form, are all M are X, some Y are M. In order to represent these on a triliteral diagram, we break up the first into the two propositions to which it is equivalent, and thus get the three propositions: 1. Some m are x, 2. No m are x, 3. Some y are m. Diagram representing xm and ym exist and x prime m does not exist. The rule, given at p50, would make us take these in the order 2, 1, 3. This, however, would produce the result alternative diagram representing xm and ym exist and x prime m does not exist pg062, so it would be better to take them in the order 2, 3, 1. Numbers 2 and 3 give us the result here shown, and now we need not trouble about no. 1. As the proposition some m are x is already represented on the diagram. Diagram representing xy exists. Transferring our information to a bilateral diagram, we get this result. We can read either as some x are y or some y are x. After consulting our dictionary, we choose some y are x, which, translated into concrete form, is some chickens understand French. 3. All diligent students are successful, all ignorant students are unsuccessful. Let univ be students, m equals successful, x equals diligent, y equals ignorant. These premises, in abstract form, are all x are m, all y are m. These, broken up, give us the four propositions: 1. Some x are m, 2. No x are m, 3. Some y are m, 4. No y are m. Diagram representing four propositions which we will take in the order 2, 4, 1, 3. Representing these on a trilateral diagram, we get diagram representing all x are y prime and all y are x prime, and this information, transferred to a bilateral diagram, is here. We get two conclusions, viz. all x are y, all y are x pg063, and these, translated into concrete form, are all diligent students are not ignorant, i.e., learned. All ignorant students are not diligent, i.e., idle. CP4. 4. Of the prisoners who were put on their trial at the last assizes, all, against whom the verdict guilty was returned, were sentenced to imprisonment. Some, who were sentenced to imprisonment, were also sentenced to hard labor. Let univ be the prisoners who were put on their trial at the last assizes, m equals who were sentenced to imprisonment, x equals against whom the verdict guilty was returned, y equals who were sentenced to hard labor. The premises, translated into abstract form, are all x are m, some m are y. Breaking up the first, we get the 3, 1, some x are m, 2, no x are m, 3, some m are y. Diagram representing xm and ym exist and xm does not exist, representing these, in the order 2, 1, 3, on a trilateral diagram, we get no conclusion at all. You would very likely have guessed, if you had seen only the premises, that the conclusion would be some, against whom the verdict guilty was returned, were sentenced to hard labor. But this conclusion is not even true, with regard to the assizes I have here invented. Not true, you exclaim. Then who were they, who were sentenced to imprisonment and were also sentenced to hard labor. They must have had the verdict guilty returned against them, or how could they be sentenced? Well, it happened like this, you see. They were 3 ruffians, who had committed highway robbery. When they were put on their trial, they pleaded guilty. So no verdict was returned at all, and they were sentenced at once. I will now work out, in their briefest form, as models for the reader to imitate in working examples, the above 4 concrete problems. PG 064, 1, CP 60, no son of mine is dishonest. People always treat an honest man with respect. Univ. Men, M equals honest, X equals my sons, Y equals treated with respect. No X are M, all M are Y. Diagram representing X M prime does not exist and all M are Y. Diagram representing X Y prime does not exist, therefore no X are Y, i.e. no son of mine ever fails to be treated with respect. 2. CP 61, all cats understand French, some chickens are cats. Univ. Creatures, M equals cats, X equals understanding French, Y equals chickens. All M are X, some Y are M. Diagram representing all M are X and Y M exists. Diagram representing X Y exists, therefore some Y are X, i.e. some chickens understand French. 3. CP 62, all diligent students are successful, all ignorant students are unsuccessful. Univ. Students, M equals successful, X equals diligent, Y equals ignorant. All X are M, all Y are M. Diagram representing all X are M and all Y are M prime. Diagram representing all X are Y prime and all Y are X prime, therefore all X are Y, all Y are X, i.e. all diligent students are learned, and all ignorant students are idle. PG 065, 4, CP 63, of the prisoners who were put on their trial at the last assizes, all, against whom the verdict guilty was returned, were sentenced to imprisonment. Some, who were sentenced to imprisonment, were also sentenced to hard labor. Univ. Prisoners who were put on their trial at the last assizes, M equals sentenced to imprisonment, X equals against whom the verdict guilty was returned, Y equals sentenced to hard labor. All X are M, some M are Y. Diagram representing all X are M and Y M exists, there is no conclusion. Review tables 7, 8, pp 48, 49. Work examples 1, 1721, p 97, 4, 16, p 100, 5, 16, p 101, pg 0663. Given a trio of propositions of relation, of which every 2 contain a pair of codivisional classes, and which are proposed as a syllogism, to ascertain whether the proposed conclusion is consequent from the proposed premises, and, if so, whether it is complete. The rules, for doing this, are as follows. 1. Take the proposed premises, and ascertain, by the process described at p60, what conclusion, if any, is consequent from them. 2. If there be no conclusion, say so. 3. If there be a conclusion, compare it with the proposed conclusion, and pronounce accordingly. I will now work out, in their briefest form, as models for the reader to imitate in working examples, 6 problems. 1. All soldiers are strong, all soldiers are brave. Some strong men are brave. Univ. Men, M equals soldiers, X equals strong, Y equals brave. PG 067 all M are X, all M are Y. Some X are Y. Diagram representing all M are X and all M are Y. Diagram representing X, Y exists, therefore some X are Y. Hence proposed conclusion is right. 2. I admire these pictures. When I admire anything I wish to examine it thoroughly. I wish to examine some of these pictures thoroughly. Univ. Things, M equals admired by me, X equals these pictures, Y equals things which I wish to examine thoroughly. All X are M, all M are Y. Some X are Y. Diagram representing all X are M and all M are Y. Diagram representing all X are Y, therefore all X are Y. Hence proposed conclusion is incomplete, the complete one being I wish to examine all these pictures thoroughly. 3. None but the brave deserve the fair, some braggarts are cowards. Some braggarts do not deserve the fair. Univ. Persons, M equals brave, X equals deserving of the fair, Y equals braggarts. No M are X, some Y are M. Some Y are X. Diagram representing X M prime does not exist and Y M prime exists. Diagram representing X prime Y exists, therefore some Y are X. Hence proposed conclusion is right. PG 068, 4. All soldiers can march, some babies are not soldiers. Some babies cannot march. Univ. Persons, M equals soldiers, X equals able to march, Y equals babies. All M are X, some Y are M. Some Y are X. Diagram representing all M are X and Y M prime exists, there is no conclusion. 5. All selfish men are unpopular, all obliging men are popular. All obliging men are unselfish. Univ. Men, M equals popular, X equals selfish, Y equals obliging. All X are M, all Y are M. All Y are X. Diagram representing all X are M prime and all Y are X prime. Diagram representing all X are Y prime and all Y are X prime, therefore all X are Y, all Y are X. Hence proposed conclusion is incomplete, the complete one containing, in addition, all selfish men are disobliging. 6. No one, who means to go by the train and cannot get a conveyance, and has not enough time to walk to the station, can do without running. This party of tourists mean to go by the train and cannot get a conveyance, but they have plenty of time to walk to the station. This party of tourists need not run. Univ. Persons meaning to go by the train, and unable to get a conveyance, M equals having enough time to walk to the station, X equals needing to run, Y equals these tourists. PG 069 no MRX, all YRM. All YRX. Diagram representing X prime M prime does not exist and all YRM there is no conclusion. Here is another opportunity, gentle reader, for playing a trick on your innocent friend. Put the proposed syllogism before him, and ask him what he thinks of the conclusion. He will reply, "Why, it's perfectly correct, of course." And if your precious logic book tells you it isn't, don't believe it. You don't mean to tell me those tourists need to run. If I were one of them, and knew the premises to be true, I should be quite clear that I needn't run, and I should walk. And you will reply, "But suppose there was a mad bull behind you?" And then your innocent friend will say, Ha! I must think that over a bit." You may then explain to him, as a convenient test of the soundness of a syllogism, that, if circumstances can be invented which, without interfering with the truth of the premises, would make the conclusion false, the syllogism must be unsound. Review Tables V8, pp 46-49. Work Examples 4, 712, p100, 5, 712, p101, 6, 110, p106, 7, 16, pp107, 108. PG 070 Book 6. The Method of Subscripts. Chapter I Introductory. Let us agree that x1 shall mean some existing things have the attribute x, i.e., more briefly, some x exist, also that xy1 shall mean some xy exist, and so on. Such a proposition may be called an entity. Note that, when there are two letters in the expression, it does not in the least matter which stands first, xy1 and yx1 mean exactly the same. Also that x0 shall mean no existing things have the attribute x, i.e., more briefly, no x exist. Also that xy0 shall mean no xy exist, and so on. Such a proposition may be called a nullity. Also that shall mean and. Thus AB1 CD0 means some AB exist and no CD exist. Also that shall mean would, if true, prove. Thus, x0 xy0 means the proposition no x exist would, if true, prove the proposition no xy exist. When two letters are both of them accented, or both not accented, they are said to have like signs, or to be like. When one is accented, and the other not, they are said to have unlike signs, or to be unlike. PG 071 Chapter 2. Representation of propositions of relation. Let us take, first, the proposition some x are y. This, we know, is equivalent to the proposition of existence some x y exist. CP 31. Hence it may be represented by the expression xy1. The converse proposition some y r x may of course be represented by the same expression, viz. xy1. Similarly we may represent the three similar pairs of converse propositions, viz. Some x r y equals some y r x, some x r y equals some y r x, some x r y equals some y r x. Let us take, next, the proposition no x r y. This, we know, is equivalent to the proposition of existence no x y exist. CP 33. Hence it may be represented by the expression xy0. The converse proposition no yrx may of course be represented by the same expression, viz. xy0. Similarly we may represent the three similar pairs of converse propositions, viz. No xry equals no yrx, no xry equals no yrx, no xry equals no yrx. PG072. Let us take, next, the proposition all x are y. Now it is evident that the double proposition of existence some x exist and no xy exist tells us that some x things exist, but that none of them have the attribute y, that is, it tells us that all of them have the attribute y, that is, it tells us that all x are y. Also it is evident that the expression x1 xy0 represents this double proposition. Hence it also represents the proposition all x are y. The reader will perhaps be puzzled by the statement that the proposition all x are y is equivalent to the double proposition some x exist and no xy exist, remembering that it was stated, at p33, to be equivalent to the double proposition some x are y and no x are y, i.e. some xy exist and no xy exist. The explanation is that the proposition some xy exist contains superfluous information. Some x exist is enough for our purpose. This expression may be written in a shorter form, viz. x1 y0, since each subscript takes effect back to the beginning of the expression. Similarly we may represent the seven similar propositions all x are y, all x are y, all x are y, all y are x, all y are x, all y are x, and all y are x. The reader should make out all these for himself. It will be convenient to remember that, in translating a proposition, beginning with all, from abstract form into subscript form, or vice versa, the predicate changes sign, that is, changes from positive to negative, or else from negative to positive. Thus, the proposition all y are x becomes y1 x0, where the predicate changes from x to x. Again, the expression x1 y0 becomes all x are y, where the predicate changes for y to y. PG 073 Chapter 3. Syllogisms. 1. Representation of syllogisms. We already know how to represent each of the three propositions of a syllogism in subscript form. When that is done, all we need, besides, is to write the three expressions in a row, with between the premises, and before the conclusion. Thus the syllogism no x are m, all m are y, therefore no x are y may be represented thus, xm0 m1 y0 xy0. When a proposition has to be translated from concrete form into subscript form, the reader will find it convenient, just at first, to translate it into abstract form, and thence into subscript form. But, after a little practice, he will find it quite easy to go straight from concrete form to subscript form. pg 0742. Formulae for solving problems in syllogisms. When once we have found, by diagrams, the conclusion to a given pair of premises, and have represented the syllogism in subscript form, we have a formula, by which we can at once find, without having to use diagrams again, the conclusion to any other pair of premises having the same subscript forms. Thus, the expression xm0ym0xy0 is a formula, by which we can find the conclusion to any pair of premises whose subscript forms are xm0ym0. For example, suppose we had the pair of propositions no gluttons are healthy, no unhealthy men are strong proposed as premises. Taking men as our universe, and making m equals healthy, x equals gluttons, y equals strong, we might translate the pair into abstract form, thus, no x are m, no m are y. These, in subscript form, would be xm0 my0, which are identical with those in our formula. Hence we at once know the conclusion to be xy0, that is, in abstract form, no x are y, that is, in concrete form, no gluttons are strong. I shall now take three different forms of pairs of premises, and work out their conclusions, once for all, by diagrams, and thus obtain some useful formulae. I shall call them Fig. I, Fig. 2, and Fig. 3 pg 075 Fig. I. This includes any pair of premises which are both of them nullities, and which contain unlike eliminands. The simplest case is xm0ym0 diagram representing xm and ym prime do not exist. Diagram representing xy does not exist, therefore xy0. In this case we see that the conclusion is a nullity, and that the retinands have kept their signs. And we should find this rule to hold good with any pair of premises which fulfill the given conditions. The reader had better satisfy himself of this, by working out, on diagrams, several varieties, such as m1x0ym0, which xy0, xm0 m1y0, which xy0, xm0 ym0, which xy0, m1x0 m1y0, which xy0. If either retinand is asserted in the premises to exist, of course it may be so asserted in the conclusion. Hence we get two variants of Fig. I, viz. Alpha, where one retinand is so asserted, beta, where both are so asserted. The reader had better work out, on diagrams, examples of these two variants, such as m1x0 y1m0, which proves y1x0, x1m0 m1y0, which proves x1y0, x1m0 y1m0, which proves x1y0 y1x0. The formula, to be remembered, is xm0 ym0 xy0 with the following two rules. 1. Two nullities, with unlike eliminands, yield a nullity, in which both retinands keep their signs. pg 076, 2. A retinand, asserted in the premises to exist, may be so asserted in the conclusion. Note that Rule 1 is merely the formula expressed in words. Fig. 2. This includes any pair of premises, of which one is a nullity and the other an entity, and which contain like eliminans. The simplest case is XM0YM1 diagram representing XM does not exist and YM does exist, diagram representing X'(Y) exists, therefore XY1. In this case we see that the conclusion is an entity, and that the nullity retinant has changed its sign. And we should find this rule to hold good with any pair of premises which fulfill the given conditions. The reader had better satisfy himself of this, by working out, on diagrams, several varieties, such as XM0YM1, which XY1, X1M0YM1, which XY1, M1X0YM1, which XY1. The formula, to be remembered, is XM0YM1XY1 with the following rule: a nullity and an entity, with like eliminans, yield an entity, in which the nullity retinant changes its sign. Note that this rule is merely the formula expressed in words. PG077 Fig. 3. This includes any pair of premises which are both of them nullities, and which contain like eliminans asserted to exist. The simplest case is XM0YM0M1. Note that M1 is here stated separately, because it does not matter in which of the two premises it occurs, so that this includes the three forms M1X0YM0, XM0M1Y0, and M1X0M1Y0. Diagram representing XM and YM do not exist and M does exist. Diagram representing X'(Y' exists, therefore XY1. In this case we see that the conclusion is an entity, and that both retinants have changed their signs. And we should find this rule to hold good with any pair of premises which fulfill the given conditions. The reader had better satisfy himself of this, by working out, on diagrams, several varieties, such as XM0M1Y0, which XY1, M1X0MY0, which XY1, M1X0M1Y0, which XY1. The formula, to be remembered, is XM0YM0M1XY1 with the following rule, which is merely the formula expressed in words: two nullities, with like eliminans asserted to exist, yield an entity, in which both retinants change their signs. In order to help the reader to remember the peculiarities and formulae of these three figures, I will put them all together in one table. PG078 Table 9. Fig. IXM0YM0XY0 two nullities, with unlike eliminans, yield a nullity, in which both retinants keep their signs. A retinant, asserted in the premises to exist, may be so asserted in the conclusion. Fig. 2XM0YM1XY1 a nullity and an entity, with like eliminans, yield an entity, in which the nullity retinant changes its sign. Fig. 3XM0YM0M1XY1 two nullities, with like eliminans asserted to exist, yield an entity, in which both retinants change their signs. I will now work out, by these formulae, as models for the reader to imitate, some problems in syllogisms which have been already worked, by diagrams, in Book V, Chap. 2, 1, CP 64, no son of mine is dishonest, people always treat an honest man with respect. Univ. Men, M equals honest, X equals my sons, Y equals treated with respect. X M0 M1 Y0 X Y0, Fig. I.e. no son of mine ever fails to be treated with respect. PG 079, 2, CP 64, all cats understand French, some chickens are cats. Univ. Creatures, M equals cats, X equals understanding French, Y equals chickens. M1x0 Y M1x Y1, Fig. 2 i.e. some chickens understand French. 3. CP 64, all diligent students are successful, all ignorant students are unsuccessful. Univ. Students, M equals successful, X equals diligent, Y equals ignorant. X1 M0 Y1 M0 X1 Y0 Y1 X0, Fig. I, beta. I.e. all diligent students are learned, and all ignorant students are idle. 4. CP 66, all soldiers are strong, all soldiers are brave. Some strong men are brave. Univ. Men, M equals soldiers, X equals strong, Y equals brave. M1x0 M1y0 xy1, Fig. 3 hence proposed conclusion is right. 5. CP 67, I admire these pictures, when I admire anything, I wish to examine it thoroughly. I wish to examine some of these pictures thoroughly. Univ. Things, M equals admired by me, X equals these, Y equals things which I wish to examine thoroughly. X1 M0 M1 Y0 X1 Y0, Fig. I, alpha. Hence proposed conclusion, XY1, is incomplete, the complete one being I wish to examine all these pictures thoroughly. PG 080, 6, CP 67, none but the brave deserve the fair, some braggarts are cowards. Some braggarts do not deserve the fair. Univ. Persons, M equals brave, X equals deserving of the fair, Y equals braggarts. MX0 YM1 XY1, Fig. 2 hence proposed conclusion is right. 7. CP 69, no one, who means to go by the train and cannot get a conveyance, and has not enough time to walk to the station, can do without running. This party of tourists mean to go by the train and cannot get a conveyance, but they have plenty of time to walk to the station. This party of tourists need not run. Univ. Persons meaning to go by the train, and unable to get a conveyance, M equals having enough time to walk to the station, X equals needing to run, Y equals these tourists. MX0 Y1 M0 do not come under any of the three figures. Hence it is necessary to return to the method of diagrams, as shown at P69. Hence there is no conclusion. Work examples for 1220, P100, 5, 1324, pp 101, 102, 6, 16, p 106, 7, 13, pp 107, 108. Also read note A at p164.pg0813. Fallacies. Any argument which deceives us, by seeming to prove what it does not really prove, may be called a fallacy, derived from the Latin verb fallo, I deceive. But the particular kind, to be now discussed, consists of a pair of propositions, which are proposed as the premises of a syllogism, but yield no conclusion. When each of the proposed premises is a proposition in I, or E, or A, the only kinds with which we are now concerned, the fallacy may be detected by the method of diagrams by simply setting them out on a triliteral diagram, and observing that they yield no information which can be transferred to the biliteral diagram. But suppose we were working by the method of subscripts and had to deal with a pair of proposed premises, which happened to be a fallacy. How could we be certain that they would not yield any conclusion? Our best plan is, I think, to deal with fallacies in the same way as we have already dealt with syllogisms, that is, to take certain forms of pairs of propositions, and to work pg08 them out, once for all, on the triliteral diagram, and ascertain that they yield no conclusion, and then to record them, for future use, as formulae for fallacies, just as we have already recorded our 3 formulae for syllogisms. Now, if we were to record the 2 sets of formulae in the same shape, viz. by the method of subscripts, there would be considerable risk of confusing the 2 kinds. Hence, in order to keep them distinct, I propose to record the formulae for fallacies in words, and to call them forms instead of formulae. Let us now proceed to find, by the method of diagrams, 3 forms of fallacies which we will then put on record for future use. They are as follows: 1. Fallacy of like eliminans not asserted to exist. 2. Fallacy of unlike eliminans with an entity premise. 3. Fallacy of 2 entity premises. These shall be discussed separately, and it will be seen that each fails to yield a conclusion. 1. Fallacy of like eliminans not asserted to exist. It is evident that neither of the given propositions can be an entity, since that kind asserts the existence of both of its terms, cp 20. Hence they must both be nullities. Hence the given pair may be represented by xm0 ym0, with or without x1, y1. These, set out on triliteral diagrams, are xm0 ym0 x1 m0 ym0 diagram representing xm and ym do not exist. Diagram representing all x are m prime and ym does not exist. xm0 y1 m0 x1 m0 y1 m0 diagram representing xm does not exist and all y are m prime. Diagram representing all x are m prime and all y are m prime. pg083, 2. Fallacy of unlike eliminans with an entity premise. Here the given pair may be represented by xm0 ym1, with or without x1 or m1. These, set out on triliteral diagrams, Rxm0 ym1x1 m0 ym1 m1 x0 ym1 diagram representing xm does not exist and ym prime does exist. Diagram representing all xrm prime and ym prime exists. Diagram representing all mrx prime and ym prime exists. 3. Fallacy of two-entity premises. Here the given pair may be represented by either xm1 ym1 or xm1 ym1. These, set out on triliteral diagrams, are xm1 ym1 xm1 ym1 diagram representing xm and ym exist. Diagram representing xm and ym prime exist. pg 0844. Method of proceeding with a given pair of propositions. Let us suppose that we have before us a pair of propositions of relation, which contain between them a pair of codivisional classes, and that we wish to ascertain what conclusion, if any, is consequent from them. We translate them, if necessary, into subscript form, and then proceed as follows. 1. We examine their subscripts, in order to see whether they are a pair of nullities, or b. a nullity and an entity, or c. a pair of entities. 2. If they are a pair of nullities, we examine their eliminans, in order to see whether they are unlike or like. If their eliminans are unlike, it is a case of Fig. We then examine their retinans, to see whether one or both of them are asserted to exist. If one retinand is so asserted, it is a case of Fig. Alpha. If both, it is a case of Fig. Beta. If their eliminans are like, we examine them, in order to see whether either of them is asserted to exist. If so, it is a case of Fig. 3. If not, it is a case of fallacy of like eliminans not asserted to exist. 3. If they are a nullity and an entity, we examine their eliminans, in order to see whether they are like or unlike. If their eliminans are like, it is a case of Fig. 2. If unlike, it is a case of fallacy of unlike eliminans with an entity premise. 4. If they are a pair of entities, it is a case of fallacy of two entity premises. Work examples for 111, p100, 5, 112. P101, 6, 712, P106, 7, 712, P108, PG 085 Book 7. Sritheses. Chapter I Introductory. When a set of three or more biliteral propositions are such that all their terms are species of the same genus, and are also so related that two of them, taken together, yield a conclusion, which, taken with another of them, yields another conclusion, and so on, until all have been taken, it is evident that, if the original set were true, the last conclusion would also be true. Such a set, with the last conclusion tacked on, is called a Srites. The original set of propositions is called its premises. Each of the intermediate conclusions is called a partial conclusion of the Srites. The last conclusion is called its complete conclusion or, more briefly, its conclusion. The genus, of which all the terms are species, is called its universe of discourse, or, more briefly, its univ. The terms, used as eliminans in the syllogisms, are called its eliminans, and the two terms, which are retained, and therefore appear in the conclusion, are called its retinens. Note that each partial conclusion contains one or two eliminans, but that the complete conclusion contains retinens only. The conclusion is said to be consequent from the premises, for which reason it is usual to prefix to it the word therefore, or the symbol therefore. Note that the question, whether the conclusion is or is not consequent from the premises, is not affected by the actual truth or falsity of any one of the propositions which make up the srites, but depends entirely on their relationship to one another. Pg 086 as a specimen srites. Let us take the following set of 5 propositions. 1. No A are B. 2. All B are C. 3. All C are D. 4. No E are A. 5. All H are E. Here the first and second, taken together, yield no A are C. This, taken along with the third, yields no A are D. This, taken along with the fourth, yields no D are E. And this, taken along with the fifth, yields all H are D. Hence, if the original set were true, this would also be true. Hence the original set, with this tacked on, is a srites. The original set is its premises. The proposition all H are D is its conclusion. The terms A, B, C, E are its eliminans, and the terms D and H are its retinens. Hence we may write the whole srites thus: no A are B, all B are C, all C are D, no E are A, all H are E. Therefore all H are D. In the above srites, the 3 partial conclusions are the positions no A are E, no A are D, no D are E, but, if the premises were arranged in other ways, other partial conclusions might be obtained. Thus, the order 41523 yields the partial conclusions no C are B, all H are B, all H are C. There are altogether 9 partial conclusions to this srites, which the reader will find it an interesting task to make out for himself. Pg 087 Chapter 2. Problems in srites. 1. Introductory. The problems we shall have to solve are of the following form. Given 3 or more propositions of relation, which are proposed as premises, to ascertain what conclusion, if any, is consequent from them. We will limit ourselves, at present, to problems which can be worked by the formulae of Fig. I, CP 75. Those that require other formulae are rather too hard for beginners. Such problems may be solved by either of 2 methods, viz. 1. The method of separate syllogisms. 2. The method of underscoring. These shall be discussed separately. Pg 0882. Solution by method of separate syllogisms. The rules for doing this are as follows. 1. Name the universe of discourse. 2. Construct a dictionary, making A, B, C, and C represent the terms. 3. Put the proposed premises into subscript form. 4. Select 2 which, containing between them a pair of codivisional classes, can be used as the premises of a syllogism. 5. Find their conclusion by formula. 6. Find a third premise which, along with this conclusion, can be used as the premises of a second syllogism. 7. Find a second conclusion by formula. 8. Proceed thus, until all the proposed premises have been used. 9. Put the last conclusion, which is the complete conclusion of the rights, into concrete form. As an example of this process, let us take, as the proposed set of premises, 1. All the policemen on this beat sup with our cook. 2. No man with long hair can fail to be a poet. 3. Amos Judd has never been in prison. 4. Our cook's cousins all love cold mutton. 5. None but policemen on this beat are poets. 6. None but her cousins ever sup with our cook. 7. Men with short hair have all been in prison. Univ. Men, A equals Amos Judd, B equals cousins of our cook, C equals having been in prison, D equals long-haired, E equals loving cold mutton, H equals poets, K equals policeman on this beat, L equals supping with our cook PG089. We now have to put the proposed premises into subscript form. Let us begin by putting them into abstract form. The result is 1. All KRL, 2. No DRH, 3. All RC, 4. All BRE, 5. No KRH, 6. No BRL, 7. All DRC. And it is now easy to put them into subscript form, as follows: 1. K1L0, 2. DH0, 3. A1C0, 4. B1E0, 5. KH0, 6. BL0, 7. D1C0. We now have to find a pair of premises which will yield a conclusion. Let us begin with no. 1, and look down the list, till we come to one which we can take along with it, so as to form premises belonging to Fig. I. We find that no. 5 will do, since we can take K as our eliminand. So our first syllogism is 1. K1L0, 5. KH0, therefore LH0. 8. We must now begin again with LH0 and find a premise to go along with it. We find that no. 2 will do, H being our eliminand. So our next syllogism is 8. LH0, 2. DH0, therefore LD0. 9. We have now used up numbers 1, 5, and 2, and must search among the others for a partner for LD0. We find that no. 6 will do. So we write 9, LD0, 6. BL0, therefore DB0. 10. Now what can we take along with DB0? No. 4 will do. 10. DB0, 4. B1E0, therefore D0. 11. PG090. Along with this we may take no. 7. 11. D0. 7. D1C0, therefore CE0. 12. And along with this we may take no. 3. 12. CE0, 3. A1C0, therefore A1E0. This complete conclusion, translated into abstract form, is all a RE, and this, translated into concrete form, is Amos Judd loves cold mutton. In actually working this problem, the above explanations would, of course, be omitted, and all that would appear on paper would be as follows: 1. K1L0, 2. DH0, 3. A1C0, 4. B1E0, 5. KH0, 6. BL0, 7. D1C0, 1. K1L0, 5. KH0 therefore LH0. 8. LH0, 2. DH0 therefore LD0. 9. LD0, 6. BL0 therefore DB0. 10. DB0, 4. B1E0 therefore D0. 11. D0, 7. D1C0 therefore CE0. 12. CE0, 3. A1C0 therefore A1E0. Note that, in working as by this process, we may begin with any premise we choose. PG0913. Solution by method of underscoring. Consider the pair of premises xm0 ym0 which yield the conclusion xy0. We see that, in order to get this conclusion, we must eliminate m, and write x and y together in one expression. Now, if we agree to mark m and m as eliminated, and to read the two expressions together, as if they were written in one, the two premises will then exactly represent the conclusion, and we need not write it out separately. Let us agree to mark the eliminated letters by underscoring them, putting a single score under the first, and a double one under the second. The two premises now become xm0 ym0 which we read as xy0. In copying out the premises for underscoring, it will be convenient to omit all subscripts. As to the 0s we may always suppose them written, and, as to the 1s, we are not concerned to know which terms are asserted to exist, except those which appear in the complete conclusion, and for them it will be easy enough to refer to the original list. PG092. I will now go through the process of solving, by this method, the example worked into. The data are 1K1L02 DH03 A1C04 B1E05 KH06 BL07 D1C0. The reader should take a piece of paper and write out this solution for himself. The first line will consist of the above data, the second must be composed, bit by bit, according to the following directions. We begin by writing down the first premise, with its numeral over it, but omitting the subscripts. We have now to find a premise which can be combined with this, i.e., a premise containing either K or L. The first we find is number 5, and this we tack on, with a. To get the conclusion from these, K and K must be eliminated, and what remains must be taken as one expression. So we underscore them, putting a single score under K, and a double one under K. The result we read as LH. We must now find a premise containing either L or H. Looking along the row, we fix on number 2, and tack it on. Now these three nullities are really equivalent to LHDH, in which H and H must be eliminated, and what remains taken as one expression. So we underscore them. The result reads as LD. We now want a premise containing L or D. Number 6 will do. These four nullities are really equivalent to LDBL. So we underscore L and L. The result reads as DB. We now want a premise containing D or B. Number 4 will do. Here we underscore B and B. The result reads as D. We now want a premise containing D or E. Number 7 will do. Here we underscore D and D. The result reads as CE. We now want a premise containing C or E. Number 3 will do, in fact must do, as it is the only one left. Here we underscore C and C, and, as the whole thing now reads as EA, we tack on EA0 as the conclusion, with A. We now look along the row of data, to see whether E or A has been given as existent. We find that A has been so given in number 3. So we add this fact to the conclusion, which now stands as EA0 A1, i.e. A1 E0, i.e. all A are E. If the reader has faithfully obeyed the above directions, his written solution will now stand as follows:
1K1L02DH03A1C05KH2DH6BL07D1C01KL5KH2DH6BL4B7DC3AC0A1 i.e. A1E0, i.e. all A are EPG093. The reader should now take a second piece of paper, and copy the data only, and try to work out the solution for himself, beginning with some other premise. If he fails to bring out the conclusion A1E0, I would advise him to take a third piece of paper, and begin again. I will now work out, in its briefest form, a series of 5 premises, to serve as a model for the reader to imitate in working examples. 1. I greatly value everything that John gives me. 2. Nothing but this bone will satisfy my dog. 3. I take particular care of everything that I greatly value. 4. This bone was a present from John. 5. The things, of which I take particular care, are things I do not give to my dog. Univ. Things: A equals given by John to me, B equals given by me to my dog, C equals greatly valued by me, D equals satisfactory to my dog, E equals taken particular care of by me, H equals this bone. 1 A1C02 HD03C1E04 H1A05 E1B01 AC3CE4 HA2 HD5 IBDB0 i.e. nothing that I give my dog satisfies him, or my dog is not satisfied with anything that I give him. Note that, in working a series by this process, we may begin with any premise we choose. For instance, we might begin with number 5, and the result would then be 5 IB3CE1AC4 HA2 HDBD0. Work examples for 2530, P100, 5, 2530, P102, 6, 1315, P106, 7, 1315, P108, 8, 14, 13, 14, 19, 24, PP110, 111, 9, 14,
26, 27, 40, 48, pp 112, 116, 119, 121. pg 094. The reader, who has successfully grappled with all the examples hitherto set, and who thirsts, like Alexander the Great, for more worlds to conquer, may employ his spare energies on the following 17 examination papers. He is recommended not to attempt more than one paper on any one day. The answers to the questions about words and phrases may be found by referring to the index at p. 197. I4, 31, p. 100, 5, 31-34, p. 102, 6, 16, 17, p. 106, 7, 16, p. 108, 8, 5, 6, p. 110, 9, 5, 22, 42, pp 112, 115, 119. What is classification? And what is a class? 2-4, 32, p. 100, 5, 35-38, pp 102, 103, 6, 18, p. 107, 7, 17, 18, p. 108, 8, 7, 8, p. 110, 9, 6, 23, 43, pp 112, 115, 119. What are genus, species, and differentia? 3-4, 33, p. 100, 5, 39-42, p. 103, 6, 19, 20, p. 107, 7, 19, p. 109, 8, 9, 10, p. 111, 9, 7, 24, 44, pp 113, 116, 120. What are real and imaginary classes? 4-4, 34, p. 100, 5, 43-46, p. 103, 6, 21, p. 107, 7, 20, 21, p. 109, 8, 11, 12, p. 111, 9, 8, 25, 45, pp 113, 116, 120. What is division? When are classes said to be codivisional? V4, 35, p. 100, 5, 47-50, p. 103, 6, 22, 23, p. 107, 7, 22, p. 109, 8, 15, 16, p. 111, 9, 9, 28, 46, pp 113, 116, 120. What is dichotomy? What arbitrary rule does it sometimes require? PG 0956. 4, 36, p. 100, 5, 51-54, p. 103, 6, 24, p. 107, 7, 23, 24, P109, 8, 17, P111, 9, 10, 29, 47, pp 113, 117, 120. What is a definition? 7-4, 37, p100, 5, 55-58, pp 103, 104, 6, 25, 26, p107, 7, 25, p109, 8, 18, p111, 9, 11, 30, 49, pp 113, 117, 121. What are the subject and the predicate of a proposition? What is its normal form? 8-4, 38, p100, 5, 59-62, p104, 6, 27, p107, 7, 26, 27, p109, 8, 20, p111, 9, 12, 31, 50, pp 113, 117, 121. What is a proposition in I? In E? And in O? 9-4, 39, p100, 5, 63-66, p104, 6, 28, 29, p107, 7, 28, p109, 8, 21, p111, 9, 13, 32, 51, pp 114, 117, 121. What is the normal form of a proposition of existence? X4, 40, P100, 5, 67-70, P104, 6, 30, P107, 7, 29, 30, P109, 8, 22, P111, 9, 14, 33, 52, pp 114, 117, 122. What is the universe of discourse? 11-4, 41, p100, 5, 71-74, p104, 6, 31, 32, p107, 7, 31, p109, 8, 23, p111, 9, 15, 34, 53, pp 114, 118, 122. What is implied, in a proposition of relation, as to the reality of its terms? 12-4, 42, p100, 5, 75-78, p105, 6, 33, p107, 7, 32, 33, pp 109, 110, 8, 25, p111, 9, 16, 35, 54, pp 114, 118, 122. Explain the phrase sitting on the fence. 13-5, 7983, p. 105, 6, 34, 35, p. 107, 7, 34, p. 110, 8, 26, p. 111, 9, 17, 36, 55, pp. 114, 118, 122. What are converse propositions? 14.5, 84-88, p. 105, 6, 36, p. 107, 7, 35, 36, p. 110, 8, 27, p. 111, 9, 18, 37, 56, pp. 114, 118, 123. What are concrete and abstract propositions? pg 09615. 5, 8993, p. 105, 6, 37, 38, p. 107, 7, 37, p. 110, 8, 28, p. 111, 9, 19, 38, 57, pp. 115, 118, 123. What is a syllogism? And what are its premises and its conclusion? 16.5, 94-97, p. 106, 6, 39, p. 107, 7, 38, 39, p. 110, 8, 29, p. 111, 9, 20, 39, 58, pp. 115, 119, 123. What is a rights? And what are its premises, its partial conclusions, and its complete conclusion? 17.5, 98-101, p. 106, 6, 40, p. 107, 7, 40, p. 110, 8, 30, p. 111, 9, 21, 41, 59, 60, pp. 115, 119, 124. What are the universe of discourse, the eliminans, and the retinans, of a syllogism, and of a rights? pg 097 Book 8. Examples, answers, and solutions. NB reference tags for examples, answers and solutions will be found in the right margin. Chapter I Examples. X11. Propositions of relation, to be reduced to normal form. 1. I have been out for a walk. 2. I am feeling better. 3. No one has read the letter but John. 4. Neither you nor I are old. 5. No fat creatures run well. 6. None but the brave deserve the fair. 7. No one looks poetical unless he is pale. 8. Some judges lose their tempers. 9. I never neglect important business. 10. What is difficult needs attention. 11. What is unwholesome should be avoided. 12. All the laws passed last week relate to excise. 13. Logic puzzles me. 14 There are no Jews in the house. 15 Some dishes are unwholesome if not well cooked. 16 Unexciting books make one drowsy. 17 When a man knows what he's about, he can detect a sharper. 18 You and I know what we're about. 19 Some bald people wear wigs. 20 Those who are fully occupied never talk about their grievances. 21 No riddles interest me if they can be solved. PG 098X22. Pairs of abstract propositions, one in terms of x and m, and the other in terms of y and m, to be represented on the same triliteral diagram. 1 No xrm, no mry2. No xrm, all mry3. Some xrm, no mry4. All mrx, all mry. 5 All mrx, all mry. 6 All xrm, no yrm7. All xrm, all yrm. 8 Some mrx, no mry9. All mrx, no mry10. No mrx, no yrm. 11 No xrm, no mry12. Some xrm, all yrm13. All xrm, no mry14. Some xrm, all mry15. No mrx, all yrm16. All xrm, no yrm17. Some mrx, no mry. 18 All xrm, some mry. 19 All mrx, some mry. 20 No xrm, some yrm21. Some xrm, all yrm22. No mrx, some mry23. No mrx, all yrm. 24 All mrx, no yrm. 25 Some mrx, no yrm26. All mrx, some yrm. 27 Some mrx, no yrm. 28 No xrm, all mry. 29 No xrm, no mry. 30 No xrm, some yrm. 31 Some mrx, all yrm, 32. All xrm, all yrm PG 099X33. Marked triliteral diagrams, to be interpreted in terms of X and Y. 12 Diagram including XY exists. Diagram including no useful information. 34 Diagram including all Y prime are X prime. Diagram including XY does not exist. 56 Diagram including all Y prime are X. Diagram including all X prime are Y. 78 Diagram including all X are Y. Diagram including all X prime are Y prime and all Y are X. 910 Diagram including all X prime are Y prime. Diagram including all X are Y prime. 1112 Diagram including no useful information. Diagram including X prime Y prime exists. 1314 Diagram including X Y prime exists. Diagram including X Y prime does not exist. 1516 Diagram including X Y exists. Diagram including all Y are X. 1718 Diagram including all all x prime are y and all y prime are x diagram including all x are y prime and all y are x prime 1920 diagram including all x are y and all y prime are x prime diagram including all y are x prime pg 100 x44. Pairs of abstract propositions, proposed as premises, conclusions to be found. 1. No MRX, all MRY. 2. No MRX, some MRY. 3. All MRX, all MRY. 4. No XRM, all YRM. 5. Some MRX, no YRM. 6. No XRM, no MRY. 7. No MRX, some YRM. 8. All MRX, no MRY. 9. Some XRM, no MRY. 10. All XRM, all YRM. 11. No MRX, all YRM. 12. No XRM, all YRM. 13. All MRX, no YRM. 14. All MRX, all MRY. 15. No XRM, no MRY. 16. All XRM, all YRM. 17. No XRM, all MRY. 18. No XRM, no MRY. 19. All MRX, all MRY. 20. No MRX, all MRY. 21. All XRM, some MRY. 22. Some XRM, all YRM. 23. All MRX, some YRM. 24. No XRM, all YRM. 25. Some MRX, all YRM. 26. No MRX, all YRM. 27. All XRM, all YRM. 28. All MRX, some MRY. 29. No MRX, all YRM. 30. All XRM, some YRM. 31. All XRM, all YRM. 32. No XRM, all MRY. 33. No MRX, no MRY. 34. No MRX, some YRM. 35. No MRX, all YRM. 36. All MRX, some YRM. 37. All MRX, no YRM. 38. No MRX, no MRY. 39. Some MRX, no MRY. 40. No XRM, all YRM. 41. All XRM, no YRM. 42. No MRX, no YRM. PG 101x55. Pairs of concrete propositions, proposed as premises, conclusions to be found. 1. I have been out for a walk, I am feeling better. 2. No one has read the letter but John, no one, who has not read it, knows what it is about. 3. Those who are not old like walking, you and I are young. 4. Your course is always honest, your course is always the best policy. 5. No fat creatures run well, some greyhounds run well. 6. Some, who deserve the fair, get their deserts, none but the brave deserve the fair. 7. Some Jews are rich, all Esquimaux are Gentiles. 8. Sugar plums are sweet, some sweet things are liked by children. 9. John is in the house, everybody in the house is ill. 10 umbrellas are useful on a journey, what is useless on a journey should be left behind. 11 audible music causes vibration in the air, inaudible music is not worth paying for. 12 some holidays are rainy, rainy days are tiresome. 13 no Frenchman like plum pudding, all Englishmen like plum pudding. 14 no portrait of a lady, that makes her simper or scowl, is satisfactory. No photograph of a lady ever fails to make her simper or scowl. 15 all pale people are phlegmatic, no one looks poetical unless he is pale. 16 no old misers are cheerful, some old misers are thin. 17 no one, who exercises self-control, fails to keep his temper, some judges lose their tempers. PG 10218. All pigs are fat, nothing that is fed on barley water is fat. 19 all rabbits, that are not greedy, are black, no old rabbits are free from greediness. 20 some pictures are not first attempts, no first attempts are really good. 21 I never neglect important business, your business is unimportant. 22 some lessons are difficult, what is difficult needs attention. 23 all clever people are popular, all obliging people are popular. 24 thoughtless people do mischief, no thoughtful person forgets a promise. 25 pigs cannot fly, pigs are greedy. 26 all soldiers march well, some babies are not soldiers. 27 no bride cakes are wholesome, what is unwholesome should be avoided. 28 John is industrious, no industrious people are unhappy. 29 no philosophers are conceited, some conceited persons are not gamblers. 30 some excise laws are unjust, all the laws passed last week relate to excise. 31 no military men write poetry, none of my lodgers are civilians. 32 no medicine is nice, senna is a medicine. 33 some circulars are not read with pleasure, no begging letters are read with pleasure. 34 all Britons are brave, no sailors are cowards. 35 nothing intelligible ever puzzles me, logic puzzles me. 36 some pigs are wild, all pigs are fat. PG 10337. All wasps are unfriendly, all unfriendly creatures are unwelcome. 38 no old rabbits are greedy, all black rabbits are greedy. 39 some eggs are hard-boiled, no eggs are uncrackable. 40 no antelope is ungraceful, graceful creatures delight the eye. 41 all well-fed canaries sing loud, no canary is melancholy if it sings loud. 42 some poetry is original, no original work is producible at will. 43 no country, that has been explored, is infested by dragons, unexplored countries are fascinating. 44 no coals are white, no niggers are white. 45 no bridges are made of sugar, some bridges are picturesque. 46 no children are patient, no impatient person can sit still. 47 no quadrupeds can whistle, some cats are quadrupeds. 48 bores are terrible, you are a bore. 49 Some oysters are silent, no silent creatures are amusing. 50 There are no Jews in the house, no Gentiles have beards a yard long. 51 Canaries, that do not sing loud, are unhappy, no well-fed canaries fail to sing loud. 52 All my sisters have colds, no one can sing who has a cold. 53 All that is made of gold is precious, some caskets are precious. 54 Some buns are rich, all buns are nice. 55 All my cousins are unjust, all judges are just. PG 10456. Pain is wearisome, no pain is eagerly wished for. 57 All medicine is nasty, senna is a medicine. 58 Some unkind remarks are annoying, no critical remarks are kind. 59 No tall men have woolly hair, niggers have woolly hair. 60 All philosophers are logical, an illogical man is always obstinate. 61 John is industrious, all industrious people are happy. 62 These dishes are all well cooked, some dishes are unwholesome if not well cooked. 63 No exciting books suit feverish patients, unexciting books make one drowsy. 64 No pigs can fly, all pigs are greedy. 65 When a man knows what he's about, he can detect a sharper, you and I know what we're about. 66 Some dreams are terrible, no lambs are terrible. 67 No bald creature needs a hairbrush, no lizards have hair. 68 All battles are noisy, what makes no noise may escape notice. 69 All my cousins are unjust, no judges are unjust. 70 All eggs can be cracked, some eggs are hard-boiled. 71 Prejudiced persons are untrustworthy, some unprejudiced persons are disliked. 72 No dictatorial person is popular, she is dictatorial. 73 Some bald people wear wigs, all your children have hair. 74 No lobsters are unreasonable, no reasonable creatures expect impossibilities. PG 10575. No nightmare is pleasant, unpleasant experiences are not eagerly desired. 76 No plum cakes are wholesome, some wholesome things are nice. 77 Nothing that is nice need be shunned, some kinds of jam are nice. 78 All ducks waddle, nothing that waddles is graceful. 79 Sandwiches are satisfying, nothing in this dish is unsatisfying. 80 No rich man begs in the street, those who are not rich should keep accounts. 81 Spiders spin webs, some creatures, that do not spin webs, are savage. 82 Some of these shops are not crowded, no crowded shops are comfortable. 83 Prudent travelers carry plenty of small change, imprudent travelers lose their luggage. 84 Some geraniums are red, all these flowers are red. 85 None of my cousins are just, all judges are just. 86 No Jews are mad, all my lodgers are Jews. 87 Busy folk are not always talking about their grievances, discontented folk are always talking about their grievances. 88 None of my cousins are just, no judges are unjust. 89 All teetotalers like sugar, no nightingale drinks wine. 90 No riddles interest me if they can be solved, all these riddles are insoluble. 91 All clear explanations are satisfactory, some excuses are unsatisfactory. 92 All elderly ladies are talkative, all good-tempered ladies are talkative. 93 No kind deed is unlawful, what is lawful may be done without scruple. PG 106 94. No babies are studious, no babies are good violinists. 95 All shillings are round, all these coins are round. 96 No honest men cheat, no dishonest men are trustworthy. 97 None of my boys are clever, none of my girls are greedy. 98 All jokes are meant to amuse, no act of parliament is a joke. 99 No eventful tour is ever forgotten, uneventful tours are not worth writing a book about. 100 All my boys are disobedient, all my girls are discontented. 101 No unexpected pleasure annoys me, your visit is an unexpected pleasure. X66. Trios of abstract propositions, proposed as syllogisms, to be examined. 1. Some xrm, no mry. Some xry. 2. All xrm, no yrm. No yrx. 3. Some xrm, all yrm. Some xry. 4. All xrm, no yrm. All xry. 5. Some mrx, no mry. Some xry. 6. No xrm, all yrm. All yrx. 7. Some mrx, all yrm. Some xry. 8. No mrx, all yrm. All yrx. 9. Some mrx, no mry. Some xry. 10. All mrx, all mry. Some yrx. 11. All xrm, some yrm. Some yrx. 12. No xrm, no mry. No xry. 13. No xrm, all yrm. All yrx. 14. All mrx, all mry. Some yrx. 15. Some mrx, all yrm. Some xry. 16. No xrm, all yrm. Some yrx. 17. No mrx, all mry. Some xry. PG 10718. No xrm, some mry. Some xry. 19. Some mrx, all mry. Some yrx. 20. No xrm, some mry. Some xry. 21. No mrx, all mry. Some xry. 22. All xrm, some yrm. All xry. 23. All mrx, no mry. No xry. 24. All xrm, all mry. All xry. 25. No xrm, all mry. No xry. 26. All MRX, all YRM. All YRX. 27. All XRM, no MRY. All XRY. 28. All XRM, no YRM. All XRY. 29. No XRM, no MRY. No XRY. 30. All XRM, all MRY. All XRY. 31. All XRM, no YRM. All XRY. 32. No XRM, no YRM. No XRY. 33. All MRX, all YRM. All YRX. 34. All XRM, some YRM. Some YRX. 35. Some XRM, all MRY. Some XRY. 36. All MRX, all YRM. All YRX. 37. No MRX, all MRY. Some XRY. 38. No XRM, no MRY. No XRY. 39. No MRX, some MRY. Some XRY. 40. No MRX, some YRM. Some XRYX. 7. Trios of concrete propositions, proposed as syllogisms, to be examined. 1. No doctors are enthusiastic, you are enthusiastic. You are not a doctor. 2. Dictionaries are useful, useful books are valuable. Dictionaries are valuable. 3. No misers are unselfish, none but misers save eggshells. No unselfish people save eggshells. 4. Some epicures are ungenerous, all my uncles are generous. My uncles are not epicures. PG 1085. Gold is heavy, nothing but gold will silence him. Nothing light will silence him. 6. Some healthy people are fat, no unhealthy people are strong. Some fat people are not strong. 7. I saw it in a newspaper. All newspapers tell lies. It was a lie. 8. Some cravats are not artistic, I admire anything artistic. There are some cravats that I do not admire. 9. His songs never last an hour, a song that lasts an hour is tedious. His songs are never tedious. 10. Some candles give very little light, candles are meant to give light. Some things that are meant to give light give very little. 11. All who are anxious to learn work hard. Some of these boys work hard. Some of these boys are anxious to learn. 12. All lions are fierce, some lions do not drink coffee. Some creatures that drink coffee are not fierce. 13. No misers are generous, some old men are ungenerous. Some old men are misers. 14. No fossil can be crossed in love, an oyster may be crossed in love. Oysters are not fossils. 15. All uneducated people are shallow, students are all educated. No students are shallow. 16. All young lambs jump, no young animals are healthy, unless they jump. All young lambs are healthy. 17. Ill-managed business is unprofitable, railways are never ill-managed. All railways are profitable. 18. No professors are ignorant, all ignorant people are vain. No professors are vain. PG 10919. A prudent man shuns high-owness, no banker is imprudent. No banker fails to shun high-owness. 20. All wasps are unfriendly, no puppies are unfriendly. Puppies are not wasps. 21. No Jews are honest, some Gentiles are rich. Some rich people are dishonest. 22. No idlers win fame, some painters are not idle. Some painters win fame. 23. No monkeys are soldiers, all monkeys are mischievous. Some mischievous creatures are not soldiers. 24. All these bonbons are chocolate creams, all these bonbons are delicious. Chocolate creams are delicious. 25. No muffins are wholesome, all buns are unwholesome. Buns are not muffins. 26. Some unauthorized reports are false, all authorized reports are trustworthy. Some false reports are not trustworthy. 27. Some pillows are soft, no pokers are soft. Some pokers are not pillows. 28. Improbable stories are not easily believed, none of his stories are probable. None of his stories are easily believed. 29. No thieves are honest, some dishonest people are found out. Some thieves are found out. 30. No muffins are wholesome, all puffy food is unwholesome. All muffins are puffy. 31. No birds, except peacocks, are proud of their tails, some birds, that are proud of their tails, cannot sing. Some peacocks cannot sing. 32. Warmth relieves pain, nothing that does not relieve pain is useful in toothache. Warmth is useful in toothache. PG 11033. No bankrupts are rich, some merchants are not bankrupts. Some merchants are rich. 34. Bores are dreaded, no bore is ever begged to prolong his visit. No one, who is dreaded, is ever begged to prolong his visit. 35. All wise men walk on their feet, all unwise men walk on their hands. No man walks on both. 36. No wheelbarrows are comfortable, no uncomfortable vehicles are popular. No wheelbarrows are popular. 37. No frogs are poetical, some ducks are unpoetical. Some ducks are not frogs. 38. No emperors are dentists, all dentists are dreaded by children. No emperors are dreaded by children. 39. Sugar is sweet, salt is not sweet. Salt is not sugar. 40. Every eagle can fly, some pigs cannot fly. Some pigs are not eagles. X88. Sets of abstract propositions, proposed as premises for treatises, conclusions to be found. NB. At the end of this section instructions are given for varying these examples. 1. No CRD, 2. All RD, 3. All BRC, 2. 1. All DRB, 2. No RC, 3. No BRC, 3. 1. No BRA, 2. No CRD, 3. All DRB 4. 1 No BRC, 2. All RB, 3. No CRD 5. 1 All BRA, 2. No BRC, 3. No RD 6. 1 All RB, 2. No BRC, 3. All DRA 7. 1 No DRB, 2. All BRA, 3. No CRD. 8 1. No BRD, 2. No RB, 3. All CRD PG 1119. 1 All BRA, 2. No RD, 3. All BRC 10. 1 No CRD, 2. All BRC, 3. No RD. 11 1. No BRC, 2. All DRA, 3. All CRA. 12 1. No CRB, 2. All CRD, 3. All BRA 13. 1 All DRE, 2. All CRA, 3. No BRD, 4. All ERA. 14 1. All ERB, 2. All RE, 3. All DRB, 4. All RC, 15. 1 No BRD, 2. All ERC, 3. All BRA, 4. All DRC. 16 1. No RE, 2. All DRC, 3. All RB, 4. All ERD 17. 1 All DRC, 2. All RE, 3. No BRD, 4. All CRE. 18 1. All RB, 2. All DRE, 3. All RC, 4. No BRE 19. 1 No BRC, 2. All ERH, 3. All RB, 4. No DRH, 5. All ERC 20. 1 No DRH, 2. No CRE, 3. All HRB, 4. No RD, 5. No BRE. 21 1. All BRA, 2. No DRH, 3. No CRE, 4. No RH, 5. All CRB 22. 1 All ERD, 2. No BRH, 3. All CRD, 4. All RE, 5. No CRH 23. 1 All BRA, 2. No DRE, 3. All HRB, 4. No CRE, 5. All DRA 24. 1 All HRK, 2. No BRA, 3. All CRD, 4. All ERH, 5. No DRK, 6. No BRC. 25 1. All RD, 2. All KRB, 3. All ERH, 4. No RB, 5. All DRC, 6. All HRK 26. 1 All RH, 2. No DRK, 3. All ERB, 4. No HRK, 5. All RE, 6. No BRD 27. 1 All CRD 2. No HRB 3. All RK 4. No CRE 5. All BRD 6. No RC 28 1. No RK 2. All ERB 3. No HRK 4. No DRC 5. No RB 6. All CRH 29. 1 No ERK 2. No BRM 3. No RC 4. All HRE 5. All DRK 6. No CRB 7. All DRL 8. No HRM 31. All NRM 2. All RE 3. No CRL 4. All KRR 5. No RH 6. No DRL 7. No CRN 8. All ERB 9. All MRR 10. All HRD NB. In each example, in sections 8 and 9, it is possible to begin with any premise, at pleasure, and thus to get as many different solutions, all of course yielding the same complete conclusion, as there are premises in the example. Hence 8 really contains 129 different examples, and 9 contains 273. PG 112x99. Sets of concrete propositions, proposed as premises for treatises, conclusions to be found. 1. Babies are illogical. 2. Nobody is despised who can manage a crocodile. 3. Illogical persons are despised. Univ. Persons A equals able to manage a crocodile, B equals babies, C equals despised, D equals logical. 2. 1. My saucepans are the only things I have that are made of tin. 2. I find all your presents very useful. 3. None of my saucepans are of the slightest use. Univ. Things of mine. A equals made of tin, B equals my saucepans, C equals useful, D equals your presents. 3. 1. No potatoes of mine, that are new, have been boiled. 2. All my potatoes in this dish are fit to eat. 3. No unboiled potatoes of mine are fit to eat. Univ. My potatoes, A equals boiled, B equals eatable, C equals in this dish, D equals new. 4. 1. There are no Jews in the kitchen. 2. No Gentiles say Spunge. 3. My servants are all in the kitchen. Univ. Persons, A equals in the kitchen, B equals Jews, C equals my servants, D equals saying Spunge. 5. 1. No ducks waltz. 2. No officers ever decline to waltz. 3. All my poultry are ducks. Univ. Creatures, A equals ducks, B equals my poultry, C equals officers, D equals willing to waltz. 6. 1. Everyone who is sane can do logic. 2. No lunatics are fit to serve on a jury. 3. None of your sons can do logic. Univ. Persons, A equals able to do logic, B equals fit to serve on a jury, C equals sane, D equals your sons. PG 1137. 1. There are no pencils of mine in this box. 2. No sugar plums of mine are cigars. 3. The whole of my property, that is not in this box, consists of cigars. Univ. Things of mine, A equals cigars, B equals in this box, C equals pencils, D equals sugar plums. 8. 1. No experienced person is incompetent. 2. Jenkins is always blundering. 3. No competent person is always blundering. Univ. Persons, A equals always blundering, B equals competent, C equals experienced, D equals Jenkins. 9. 1. No terriers wander among the signs of the zodiac. 2. Nothing that does not wander among the signs of the zodiac is a comet. 3. Nothing but a terrier has a curly tail. Univ. Things, A equals comets, B equals curly-tailed, C equals terriers, D equals wandering among the signs of the zodiac. 10. 1. No one takes in the Times, unless he is well educated. 2. No hedgehogs can read. 3. Those who cannot read are not well educated. Univ. Creatures, A equals able to read, B equals hedgehogs, C equals taking in the Times, D equals well educated. 11. 1. All puddings are nice. 2. This dish is a pudding. 3. No nice things are wholesome. Univ. Things, A equals nice, B equals puddings, C equals this dish, D equals wholesome. 12. 1. My gardener is well worth listening to on military subjects. 2. No one can remember the Battle of Waterloo, unless he is very old. 3. Nobody is really worth listening to on military subjects, unless he can remember the Battle of Waterloo. Univ. Persons, A equals able to remember the Battle of Waterloo, B equals my gardener, C equals well worth listening to on military subjects, D equals very old. PG 11413. 1. All hummingbirds are richly colored. 2. No large birds live on honey. 3. Birds that do not live on honey are dull in color. Univ. Birds, A equals hummingbirds, B equals large, C equals living on honey, D equals richly colored. 14. 1. No Gentiles have hooked noses. 2. A man who is a good hand at a bargain always makes money. 3. No Jew is ever a bad hand at a bargain. Univ. Persons, A equals good hands at a bargain, B equals hook-nosed, C equals Jews, D equals making money. 15. 1. All ducks in this village, that are branded B belong to Mrs. Bond. 2. Ducks in this village never wear lace collars, unless they are branded B. 3. Mrs. Bond has no grey ducks in this village. Univ. Ducks in this village, A equals belonging to Mrs. Bond, B equals branded B, C equals grey, D equals wearing lace collars. 16. 1. All the old articles in this cupboard are cracked. 2. No jug in this cupboard is new. 3. Nothing in this cupboard, that is cracked, will hold water. Univ. Things in this cupboard, A equals able to hold water, B equals cracked, C equals jugs, D equals old. 17. 1. All unripe fruit is unwholesome. 2. All these apples are wholesome. 3. No fruit, grown in the shade, is ripe. Univ. Fruit, A equals grown in the shade, B equals ripe, C equals these apples, D equals wholesome. 18. 1. Puppies, that will not lie still, are always grateful for the loan of a skipping rope. 2. A lame puppy would not say thank you if you offered to lend it a skipping rope. 3. None but lame puppies ever care to do worsted work. Univ. Puppies, A equals caring to do worsted work, B equals grateful for the loan of a skipping rope, C equals lame, D equals willing to lie still. PG 11519. 1. No name in this list is unsuitable for the hero of a romance. 2. Names beginning with a vowel are always melodious. 3. No name is suitable for the hero of a romance if it begins with a consonant. Univ. Names, A equals beginning with a vowel, B equals in this list, C equals melodious, D equals suitable for the hero of a romance. 20. 1. All members of the House of Commons have perfect self-command. 2. No MP, who wears a coronet, should ride in a donkey race. 3. All members of the House of Lords wear coronets. Univ. M.P.S. A equals belonging to the House of Commons, B equals having perfect self-command, C equals one who may ride in a donkey race, D equals wearing a coronet. 21. 1. No goods in this shop, that have been bought and paid for, are still on sale. 2. None of the goods may be carried away, unless labeled sold. 3. None of the goods are labeled sold unless they have been bought and paid for. Univ. Goods in this shop, A equals allowed to be carried away, B equals bought and paid for, C equals labeled sold, D equals on sale. 22. 1. No acrobatic feats, that are not announced in the bills of a circus, are ever attempted there. 2. No acrobatic feat is possible, if it involves turning a quadruple somersault. 3. No impossible acrobatic feat is ever announced in a circus bill. Univ. Acrobatic feats, A equals announced in the bills of a circus, B equals attempted in a circus, C equals involving the turning of a quadruple somersault, D equals possible. 23. 1. Nobody, who really appreciates Beethoven, fails to keep silence while the Moonlight Sonata is being played. 2. Guinea pigs are hopelessly ignorant of music. 3. No one, who is hopelessly ignorant of music, ever keeps silence while the Moonlight Sonata is being played. Univ. Creatures, A equals guinea pigs, B equals hopelessly ignorant of music, C equals keeping silence while the Moonlight Sonata is being played, D equals really appreciating Beethoven. PG 11624. 1. Colored flowers are always scented. 2. I dislike flowers that are not grown in the open air. 3. No flowers grown in the open air are colorless. Univ. Flowers, A equals colored, B equals grown in the open air, C equals liked by me, D equals scented. 25. 1. Showy talkers think too much of themselves. 2. No really well-informed people are bad company. 3. People who think too much of themselves are not good company. Univ. Persons: A equals good company, B equals really well-informed, C equals showy talkers, D equals thinking too much of one's self. 26. 1. No boys under 12 are admitted to this school as boarders. 2. All the industrious boys have red hair. 3. None of the day boys learn Greek. 4. None but those under 12 are idle. Univ. Boys in this school: A equals boarders, B equals industrious, C equals learning Greek, D equals red-haired, E equals under 12. 27. 1. The only articles of food that my doctor allows me are such as are not very rich. 2. Nothing that agrees with me is unsuitable for supper. 3. Wedding cake is always very rich. 4. My doctor allows me all articles of food that are suitable for supper. Univ. Articles of food: A equals agreeing with me, B equals allowed by my doctor, C equals suitable for supper, D equals very rich, E equals wedding cake. 28. 1. No discussions in our debating club are likely to rouse the British lion, so long as they are checked when they become too noisy. 2. Discussions, unwisely conducted, endanger the peacefulness of our debating club. 3. Discussions that go on while Tompkins is in the chair are likely to rouse the British lion. 4. Discussions in our debating club, when wisely conducted, are always checked when they become too noisy. Univ. Discussions in our debating club: A equals checked when too noisy, B equals dangerous to the peacefulness of our debating club, C equals going on while Tompkins is in the chair, D equals likely to rouse the British lion, E equals wisely conducted. PG 11729. 1. All my sons are slim. 2. No child of mine is healthy who takes no exercise. 3. All gluttons, who are children of mine, are fat. 4. No daughter of mine takes any exercise. Univ. My children: A equals fat, B equals gluttons, C equals healthy, D equals sons, E equals taking exercise. 30. 1. Things sold in the street are of no great value. 2. Nothing but rubbish can be had for a song. 3. Eggs of the great auk are very valuable. 4. It is only what is sold in the street that is really rubbish. Univ. Things: A equals able to be had for a song, B equals eggs of the great auk, C equals rubbish, D equals sold in the street, E equals very valuable. 31. 1. No books sold here have gilt edges, except what are in the front shop. 2. All the authorized editions have red labels. 3. All the books with red labels are priced at 5s and upwards. 4. None but authorized editions are ever placed in the front shop. Univ. Books sold here: A equals authorized editions, B equals gilt-edged, C equals having red labels, D equals in the front shop, E equals priced at 5s and upwards. 32. 1. Remedies for bleeding, which fail to check it, are a mockery. 2. Tincture of calendula is not to be despised. 3. Remedies, which will check the bleeding when you cut your finger, are useful. 4. All mock remedies for bleeding are despicable. Univ. Remedies for bleeding: A equals able to check bleeding, B equals despicable, C equals mockeries, D equals tincture of calendula, E equals useful when you cut your finger. 33. 1. None of the unnoticed things met with at sea are mermaids. 2. Things entered in the log as met with at sea are sure to be worth remembering. 3. I have never met with anything worth remembering when on a voyage. 4. Things met with at sea that are noticed are sure to be recorded in the log. Univ. Things met with at sea: A equals entered in log, B equals mermaids, C equals met with by me, D equals noticed, E equals worth remembering. PG 11834. 1. The only books in this library that I do not recommend for reading are unhealthy in tone. 2. The bound books are all well written. 3. All the romances are healthy in tone. 4. I do not recommend you to read any of the unbound books. Univ. Books in this library: A equals bound, B equals healthy in tone, C equals recommended by me, D equals romances, E equals well written. 35. 1. No birds, except ostriches, are 9 feet high. 2. There are no birds in this aviary that belong to anyone but me. 3. No ostrich lives on mince pies. 4. I have no birds less than 9 feet high. Univ. Birds: A equals in this aviary, B equals living on mince pies, C equals my, D equals 9 feet high, E equals ostriches. 36. 1. A plum pudding that is not really solid is mere porridge. 2. Every plum pudding served at my table has been boiled in a cloth. 3. A plum pudding that is mere porridge is indistinguishable from soup. 4. No plum puddings are really solid, except what are served at my table. Univ. Plum puddings: A equals boiled in a cloth, B equals distinguishable from soup, C equals mere porridge, D equals really solid, E equals served at my table. 37. 1. No interesting poems are unpopular among people of real taste. 2. No modern poetry is free from affectation. 3. All your poems are on the subject of soap bubbles. 4. No affected poetry is popular among people of real taste. 5. No ancient poem is on the subject of soap bubbles. Univ. Poems: A equals affected, B equals ancient, C equals interesting, D equals on the subject of soap bubbles, E equals popular among people of real taste, H equals written by you. 38. 1. All the fruit at this show that fails to get a prize is the property of the committee. 2. None of my peaches have got prizes. 3. None of the fruit sold off in the evening is unripe. 4. None of the ripe fruit has been grown in a hothouse. 5. All fruit that belongs to the committee is sold off in the evening. Univ. Fruit at this show: A equals belonging to the committee, B equals getting prizes, C equals grown in a hothouse, D equals my peaches, E equals ripe, H equals sold off in the evening. PG 11939. 1. Promise breakers are untrustworthy. 2. Wine drinkers are very communicative. 3. A man who keeps his promises is honest. 4. No teetotalers are pawnbrokers. 5. One can always trust a very communicative person. Univ. Persons: A equals honest, B equals pawnbrokers, C equals promise breakers, D equals trustworthy, E equals very communicative, H equals wine drinkers. 41. No kitten that loves fish is unteachable. 2. No kitten without a tail will play with a gorilla. 3. Kittens with whiskers always love fish. 4. No teachable kitten has green eyes. 5. No kittens have tails unless they have whiskers. Univ. Kittens: A equals green-eyed, B equals loving fish, C equals tailed, D equals teachable, E equals whiskered, H equals willing to play with a gorilla. 41. 1. All the Eton men in this college play cricket. 2. None but the scholars dine at the higher table. 3. None of the cricketers row. 4. My friends in this college all come from Eton. 5. All the scholars are rowing men. Univ. Men in this college: A equals cricketers, B equals dining at the higher table, C equals Etonians, D equals my friends, E equals rowing men, H equals scholars. 42. 1. There is no box of mine here that I dare open. 2. My writing desk is made of rosewood. 3. All my boxes are painted, except what are here. 4. There is no box of mine that I dare not open, unless it is full of live scorpions. 5. All my rosewood boxes are unpainted. Univ. My boxes: A equals boxes that I dare open, B equals full of live scorpions, C equals here, D equals made of rosewood, E equals painted, H equals writing desks. 43. 1. Gentiles have no objection to pork. 2. Nobody who admires pigsties ever reads Hogg's poems. 3. No Mandarin knows Hebrew. 4. Everyone who does not object to pork admires pigsties. 5. No Jew is ignorant of Hebrew. Univ. Persons: A equals admiring pigsties, B equals Jews, C equals knowing Hebrew, D equals Mandarins, E equals objecting to pork, H equals reading Hogg's poems. PG 12044. 1. All writers who understand human nature are clever. 2. No one is a true poet unless he can stir the hearts of men. 3. Shakespeare wrote Hamlet. 4. No writer who does not understand human nature can stir the hearts of men. 5. None but a true poet could have written Hamlet. Univ. Writers: A equals able to stir the hearts of men, B equals clever, C equals Shakespeare, D equals true poets, E equals understanding human nature, H equals writer of Hamlet. 45. 1. I despise anything that cannot be used as a bridge. 2. Everything that is worth writing an ode to would be a welcome gift to me. 3. A rainbow will not bear the weight of a wheelbarrow. 4. Whatever can be used as a bridge will bear the weight of a wheelbarrow. 5. I would not take, as a gift, a thing that I despise. Univ. Things: A equals able to bear the weight of a wheelbarrow, B equals acceptable to me, C equals despised by me, D equals rainbows, E equals useful as a bridge, H equals worth writing an ode to. 46. 1. When I work a logic example without grumbling, you may be sure it is one that I can understand. 2. These treatises are not arranged in regular order, like the examples I am used to. 3. No easy example ever make my head ache. 4. I can't understand examples that are not arranged in regular order, like those I am used to. 5. I never grumble at an example, unless it gives me a headache. Univ. Logic examples worked by me, A equals arranged in regular order, like the examples I am used to. B equals easy, C equals grumbled at by me, D equals making my head ache, E equals these treatises, H equals understood by me. 47. 1. Every idea of mine, that cannot be expressed as a syllogism, is really ridiculous. 2. None of my ideas about bath buns are worth writing down. 3. No idea of mine, that fails to come true, can be expressed as a syllogism. 4. I never have any really ridiculous idea, that I do not at once refer to my solicitor. 5. My dreams are all about bath buns. 6. I never refer any idea of mine to my solicitor, unless it is worth writing down. Univ. My ideas, A equals able to be expressed as a syllogism, B equals about bath buns, C equals coming true, D equals dreams, E equals really ridiculous, H equals referred to my solicitor, K equals worth writing down. PG 12148. 1. None of the pictures here, except the battle pieces, are valuable. 2. None of the unframed ones are varnished. 3. All the battle pieces are painted in oils. 4. All those that have been sold are valuable. 5. All the English ones are varnished. 6. All those in frames have been sold. Univ. The pictures here, A equals battle pieces, B equals English, C equals framed, D equals oil paintings, E equals sold, H equals valuable, K equals varnished. 49. 1. Animals that do not kick are always unexcitable. 2. Donkeys have no horns. 3. A buffalo can always toss one over a gate. 4. No animals that kick are easy to swallow. 5. No hornless animal can toss one over a gate. 6. All animals are excitable, except buffaloes. Univ. Animals, A equals able to toss one over a gate, B equals buffaloes, C equals donkeys, D equals easy to swallow, E equals excitable, H equals horned, K equals kicking. 50. 1. No one, who is going to a party, ever fails to brush his hair. 2. No one looks fascinating, if he is untidy. 3. Opium eaters have no self-command. 4. Everyone, who has brushed his hair, looks fascinating. 5. No one wears white kid gloves, unless he is going to a party. 6. A man is always untidy, if he has no self-command. Univ. Persons, A equals going to a party, B equals having brushed one's hair, C equals having self-command, D equals looking fascinating, E equals opium eaters, H equals tidy, K equals wearing white kid gloves. 51. 1. No husband, who is always giving his wife new dresses, can be a cross-grained man. 2. A methodical husband always comes home for his tea. 3. No one, who hangs up his hat on the gas jet, can be a man that is kept in proper order by his wife. 4. A good husband is always giving his wife new dresses. 5. No husband can fail to be cross-grained, if his wife does not keep him in proper order. 6. An unmethodical husband always hangs up his hat on the gas jet. Univ. Husbands, A equals always coming home for his tea, B equals always giving his wife new dresses, C equals cross-grained, D equals good, E equals hanging up his hat on the gas jet, H equals kept in proper order, K equals methodical. PG 12252. 1. Everything, not absolutely ugly, may be kept in a drawing room. 2. Nothing, that is encrusted with salt, is ever quite dry. 3. Nothing should be kept in a drawing room, unless it is free from damp. 4. Bathing machines are always kept near the sea. 5. Nothing, that is made of mother of pearl, can be absolutely ugly. 6. Whatever is kept near the sea gets encrusted with salt. Univ. Things, A equals absolutely ugly, B equals bathing machines, C equals encrusted with salt, D equals kept near the sea, E equals made of mother of pearl, H equals quite dry, K equals things that may be kept in a drawing room. 53. 1. I call no day unlucky when Robinson is civil to me. 2. Wednesdays are always cloudy. 3. When people take umbrellas, the day never turns out fine. 4. The only days when Robinson is uncivil to me are Wednesdays. 5. Everybody takes his umbrella with him when it is raining. 6. My lucky days always turn out fine. Univ. Days, A equals called by me lucky, B equals cloudy, C equals days when people take umbrellas, D equals days when Robinson is civil to me, E equals rainy, H equals turning out fine, K equals Wednesdays. 54. 1. No shark ever doubts that it is well fitted out. 2. A fish that cannot dance a minuet is contemptible. 3. No fish is quite certain that it is well fitted out, unless it has 3 rows of teeth. 4. All fishes, except sharks, are kind to children. 5. No heavy fish can dance a minuet. 6. A fish with 3 rows of teeth is not to be despised. Univ. Fishes, A equals able to dance a minuet, B equals certain that he is well fitted out, C equals contemptible, D equals having 3 rows of teeth, E equals heavy, H equals kind to children, K equals sharks. 55. 1. All the human race, except my footman, have a certain amount of common sense. 2. No one, who lives on barley sugar, can be anything but a mere baby. 3. None but a hopscotch player knows what real happiness is. 4. No mere baby has a grain of common sense. 5. No engine driver ever plays hopscotch. 6. No footman of mine is ignorant of what true happiness is. Univ. Human beings, A equals engine drivers, B equals having common sense, C equals hopscotch players, D equals knowing what real happiness is, E equals living on barley sugar, H equals mere babies, K equals my footman. PG 1 2 3 5 6. 1. I trust every animal that belongs to me. 2. Dogs gnaw bones. 3. I admit no animals into my study, unless they will beg when told to do so. 4. All the animals in the yard are mine. 5. I admit every animal that I trust into my study. 6. The only animals that are really willing to beg when told to do so are dogs. Univ. Animals. A equals admitted to my study, B equals animals that I trust, C equals dogs, D equals gnawing bones, E equals in the yard, H equals my, K equals willing to beg when told. 57. 1. Animals are always mortally offended if I fail to notice them. 2. The only animals that belong to me are in that field. 3. No animal can guess a conundrum, unless it has been properly trained in a board school. 4. None of the animals in that field are badgers. 5. When an animal is mortally offended, it always rushes about wildly and howls. 6. I never notice any animal, unless it belongs to me. 7. No animal that has been properly trained in a board school ever rushes about wildly and howls. Univ. Animals. A equals able to guess a conundrum, B equals badgers, C equals in that field, D equals mortally offended, E equals my, H equals noticed by me, K equals properly trained in a board school, L equals rushing about wildly and howling. 58. 1. I never put a check, received by me, on that file, unless I am anxious about it. 2. All the checks received by me, that are not marked with a cross, are payable to bearer. 3. None of them are ever brought back to me, unless they have been dishonored at the bank. 4. All of them that are marked with a cross are for amounts of over £100. 5. All of them that are not on that file are marked not negotiable. 6. No check of yours, received by me, has ever been dishonored. 7. I am never anxious about a check, received by me, unless it should happen to be brought back to me. 8. None of the checks received by me, that are marked not negotiable are for amounts of over £100. Univ. Checks received by me, A equals brought back to me, B equals checks that I am anxious about, C equals honored, D equals marked with a cross, E equals marked not negotiable, H equals on that file, K equals over £100, L equals payable to bearer, M equals your PG 12459. 1. All the dated letters in this room are written on blue paper. 2. None of them are in black ink, except those that are written in the third person. 3. I have not filed any of them that I can read. 4. None of them that are written on one sheet are undated. 5. All of them that are not crossed are in black ink. 6. All of them written by Brown begin with Dear Sir. 7. All of them written on blue paper are filed. 8. None of them written on more than one sheet are crossed. 9. None of them that begin with Dear Sir are written in the third person. Univ. Letters in this room, A equals beginning with Dear Sir, B equals crossed, C equals dated, D equals filed, E equals in black ink, H equals in third person, K equals letters that I can read, L equals on blue paper, M equals on one sheet, N equals written by Brown. 60. 1. The only animals in this house are cats. 2. Every animal is suitable for a pet that loves to gaze at the moon. 3. When I detest an animal, I avoid it. 4. No animals are carnivorous, unless they prowl at night. 5. No cats fails to kill mice. 6. No animals ever take to me, except what are in this house. 7. Kangaroos are not suitable for pets. 8. None but carnivora kill mice. 9. I detest animals that do not take to me. 10. Animals that prowl at night always love to gaze at the moon. Univ. Animals. A equals avoided by me, B equals carnivora, C equals cats, D equals detested by me, E equals in this house, H equals kangaroos, K equals killing mice, L equals loving to gaze at the moon, M equals prowling at night, N equals suitable for pets, R equals taking to me. PG 125 Chapter 2. Answers. And 1 answers to 1. 1 All sign of quantity. Persons represented by the name I, or I's, subject, are copular. Persons who have been out for a walk predicate. Or, more briefly, all eyes are persons who have been out for a walk. 2 All eyes are persons who feel better. 3 No persons who are not John are persons who have read the letter. 4 No members of the class you and I are old persons. 5 No fat creatures are creatures that run well. 6 No not brave persons are persons deserving of the fair. 7 No not pale persons are persons who look poetical. 8 Some judges are persons who lose their tempers. 9 All eyes are persons who do not neglect important business. 10 All difficult things are things that need attention. 11 All unwholesome things are things that should be avoided. 12 All laws passed last week are laws relating to excise. 13 All logical studies are things that puzzle me. 14 No persons in the house are Jews. 15 Some not well-cooked dishes are unwholesome dishes. 16 All unexciting books are books that make one drowsy. 17 All men who know what they are about are men who can detect a sharper. 18 All members of the class you and I are persons who know what they are about. 19 Some bald persons are persons accustomed to wear wigs. 20 All fully occupied persons are persons who do not talk about their grievances. 21 No riddles that can be solved are riddles that interest me. PG 126 and 2 answers to 2. 12 Diagram representing x m and m prime y do not exist. Diagram representing x prime m prime does not exist and all m prime are y. 34 Diagram representing x prime m exists and m y does not exist. Diagram representing all m are x and all m prime are y prime. 56 Diagram representing all m prime are x and all m prime prime r y prime diagram representing all x prime r m prime and y prime m does not exist. 78 diagram representing all x r m and all y prime r m prime diagram representing x prime m prime exists and ym does not exist. 910 diagram representing all mrx prime diagram representing x prime m and ym prime do not exist. 1112 diagram representing x prime m prime and ym do not exist. Diagram representing x m exists and all y prime rm. 1314 diagram representing all x prime rm and ym does not exist. Diagram representing xm prime exists and all mry. 1516 diagram representing x prime m prime does not exist and all yrm diagram representing all x rm prime and ym does not exist. 1718 diagram representing xm prime exists and y prime m prime does not exist. Diagram representing all x rm prime and y prime m prime exists. 1920 diagram representing all mrx and y prime m exists. Diagram representing x prime m does not exist and ym exists. 2122 diagram representing x prime m prime exists and all y prime rm diagram representing xm does not exist and ym exists. 2324 diagram representing xm prime does not exist and all yrm prime diagram representing all mrx and y prime m prime does not exist. PG 1272526 diagram representing xm exists and y prime m does not exist. Diagram representing all m prime rx prime and ym prime exists. 2728 diagram representing x prime m exists and y prime m prime does not exist. Diagram representing xm prime does not exist and mry prime. 2930 diagram representing x prime m and y prime m do not exist. Diagram representing xm does not exist and y prime m prime does exist. 3132 diagram representing xm prime exists and all y prime rm diagram representing all x rm prime and all y rm and 3 answers to 3. 1. Some x y exist, or some x are y, or some y are x2. No information. 3. All y are x. 4. No x y exist, and c5. All y are x6. All x are y7. All x are y8. All x are y, and all y are x9. All x are y. 10. All x are y. 11. No information. 12. Some x y exist, and c13. Some x y exist, and c14. No x y exist, and c15. Some x y exist, and c16. All y are x17. All x are y, and all y are x18. All x are y, and all y are x. 19. All x are y, and all y are x. 20. All y are x. And 4 answers to 4. 1. No x are y. 2. Some x are y. 3. Some x are y. 4. No cancel. Fallacy of like eliminans not asserted to exist. 5. Some x are y. 6. No concal. Fallacy of like eliminans not asserted to exist. 7. Some x are y. 8. Some x are y. 9. No concal. Fallacy of unlike eliminans with an entity premise. 10. All x are y, and all y are x. 11. No concal. Fallacy of like eliminans not asserted to exist. 12. All y are x. 13. No x are y. 14. No x are y. 15. No x are y. 16. All x are y, and all y are x. PG 12817. No x are y. 18. No x are y. 19. Some x are y. 20. No x are y. 21. Some y are x. 22. No concal. Fallacy of unlike eliminans with an entity premise. 23. Some x are y. 24. All y are x. 25. Some y are x. 26. All y are x. 27. All x are y, and all y are x. 28. Some y are x. 29. No concal. Fallacy of like eliminans not asserted to exist. 30. Some y are x. 31. No concal. Fallacy of like eliminans not asserted to exist. 32. No x are y. 33. No concal. Fallacy of like eliminans not asserted to exist. 34. Some x are y. 35. All y are x. 36. Some y are x. 37. Some x are y. 38. No x are y. 39. Some x are y. 40. All y are x. 41. All x are y. 42. No x are y. And 5 answers to 5. 1. Somebody who has been out for a walk is feeling better. 2. No one but John knows what the letter is about. 3. You and I like walking. 4. Honesty is sometimes the best policy. 5. Some greyhounds are not fat. 6. Some brave persons get their deserts. 7. Some rich persons are not Esquimaux. 8. No concal. Fallacy of unlike eliminans with an entity premise. 9. John is ill. 10. Some things that are not umbrellas should be left behind on a journey. 11. No music is worth paying for, unless it causes vibration in the air. 12. Some holidays are tiresome. 13. Englishmen are not Frenchmen. 14. No photograph of a lady is satisfactory. 15. No one looks poetical unless he is phlegmatic. 16. Some thin persons are not cheerful. 17. Some judges do not exercise self-control. 18. Pigs are not fed on barley water. 19. Some black rabbits are not old. PG 12920. No concal. Fallacy of unlike eliminans with an entity premise. 21. No concal. Fallacy of like eliminans not asserted to exist. 22. Some lessons need attention. 23. No concal. Fallacy of like eliminans not asserted to exist. 24 No one, who forgets a promise, fails to do mischief. 25 Some greedy creatures cannot fly. 26 No can kill. Fallacy of unlike eliminans with an entity premise. 27 No bride cakes are things that need not be avoided. 28 John is happy. 29 Some people, who are not gamblers, are not philosophers. 30 No can kill. Fallacy of unlike eliminans with an entity premise. 31 None of my lodgers write poetry. 32 Senna is not nice. 33 No can kill. Fallacy of unlike eliminans with an entity premise. 34 No can kill. Fallacy of like eliminans not asserted to exist. 35 Logic is unintelligible. 36 Some wild creatures are fat. 37 All wasps are unwelcome. 38 All black rabbits are young. 39 Some hard-boiled things can be cracked. 40 No antelopes fail to delight the eye. 41 All well-fed canaries are cheerful. 42 Some poetry is not producible at will. 43 No country infested by dragons fails to be fascinating. 44 No can kill. Fallacy of like eliminans not asserted to exist. 45 Some picturesque things are not made of sugar. 46 No children can sit still. 47 Some cats cannot whistle. 48 You are terrible. 49 Some oysters are not amusing. 50 Nobody in the house has a beard a yard long. 51 Some ill-fed canaries are unhappy. 52 My sisters cannot sing. 53 No can kill. Fallacy of unlike eliminans with an entity premise. 54 Some rich things are nice. 55 My cousins are none of them judges, and judges are none of them cousins of mine. 56 Something wearisome is not eagerly wished for. 57 Senna is nasty. 58 No can kill. Fallacy of unlike eliminans with an entity premise. 59 Niggers are not any of them tall. 60 Some obstinate persons are not philosophers. 61 John is happy. 62 Some unwholesome dishes are not present here, i.e. cannot be spoken of as these. 63 No books suit feverish patients unless they make one drowsy. 64 Some greedy creatures cannot fly. 65 You and I can detect a sharper. 66 Some dreams are not lambs. PG 130. 67 No lizard needs a hairbrush. 68 Some things, that may escape notice, are not battles. 69 My cousins are not any of them judges. 70 Some hard-boiled things can be cracked. 71 No can kill. Fallacy of unlike eliminans with an entity premise. 72 She is unpopular. 73 Some people, who wear wigs, are not children of yours. 74 No lobsters expect impossibilities. 75 No nightmare is eagerly desired. 76 Some nice things are not plum cakes. 77 Some kinds of jam need not be shunned. 78 All ducks are ungraceful. 79 No can kill. Fallacy of like eliminans not asserted to exist. 80 No man, who begs in the street, should fail to keep accounts. 81 Some savage creatures are not spiders. 82 No can kill. Fallacy of unlike eliminans with an entity premise. 83 No travelers, who do not carry plenty of small change, fail to lose their luggage. 84 No can kill. Fallacy of unlike eliminans with an entity premise. 85 Judges are none of them cousins of mine. 86 All my lodgers are sane. 87 Those who are busy are contented, and discontented people are not busy. 88 None of my cousins are judges. 89 No nightingale dislikes sugar. 90 No can kill. Fallacy of like eliminans not asserted to exist. 91 Some excuses are not clear explanations. 92 No can kill. Fallacy of like eliminans not asserted to exist. 93 No kind deed need cause scruple. 94 No can kill. Fallacy of like eliminans not asserted to exist. 95 No can kill. Fallacy of like eliminans not asserted to exist. 96 No cheats are trustworthy. 97 No clever child of mine is greedy. 98 Some things, that are meant to amuse, are not acts of parliament. 99 No tour, that is ever forgotten, is worth writing a book about. 100 No obedient child of mine is contented. 101 Your visit does not annoy me. And 6 Answers to 6. 1 Conclusion right. 2 No can kill. Fallacy of like eliminans not asserted to exist. 3 can kill. Right. 4 can kill. Right. 5 can kill. Right. 6 No can kill. Fallacy of like eliminans not asserted to exist. 7 No can kill. Fallacy of unlike eliminans with an entity premise. 8 can kill. Right. 9 can kill. Right. 10 can kill. Right. 11 can kill. Right. 12 can kill. Right. 13 can kill. Right. 14 can kill. Right. 15 can kill. Right. PG 13116. No can kill. Fallacy of like eliminans not asserted to exist. 17 can kill. Right. 18 can kill. Right. 19 can kill. Right. 20 can kill. Right. 21 can kill. Right. 22 can kill. Wrong, the right one is some x or y. 23 can kill. Right. 24 can kill. Right. 25 Kunkel. Right. 26 Kunkel. Right. 27 Kunkel. Right. 28 No Kunkel. Fallacy of like eliminans not asserted to exist. 29 Kunkel. Right. 30 Kunkel. Right. 31 Kunkel. Right. 32 Kunkel. Right. 33 Kunkel. Right. 34 No Kunkel. Fallacy of unlike eliminans with an entity premise. 35 Kunkel. Right. 36 Kunkel. Right. 37 Kunkel. Right. 38 No Kunkel. Fallacy of like eliminans not asserted to exist. 39 Kunkel. Right. 40 Kunkel. Right. And 7 answers to 7. 1 Kunkel. Right. 2 Kunkel. Right. 3 Kunkel. Right. 4 Kunkel. Wrong. Right 1 is some epicures are not uncles of mine. 5 Kunkel. Right. 6 No Kunkel. Fallacy of unlike eliminans with an entity premise. 7 Kunkel. Wrong. Right 1 is the publication, in which I saw it, tells lies. 8 No Kunkel. Fallacy of unlike eliminans with an entity premise. 9 Kunkel. Wrong. Right 1 is some tedious songs are not his. 10 Kunkel. Right. 11 No Kunkel. Fallacy of unlike eliminans with an entity premise. 12 Kunkel. Wrong. Right 1 is some fierce creatures do not drink coffee. 13 No Kunkel. Fallacy of unlike eliminans with an entity premise. 14 Kunkel. Right. 15 Kunkel. Wrong. Right 1 is some shallow persons are not students. 16 No Kunkel. Fallacy of like eliminans not asserted to exist. 17 Kunkel. Wrong. Right 1 is some business, other than railways, is unprofitable. 18 Kunkel. Wrong. Right 1 is some vain persons are not professors. 19 Kunkel. Right. 20 Kunkel. Wrong. Right 1 is wasps are not puppies. 21 No Kunkel. Fallacy of unlike eliminans with an entity premise. 22 No Kunkel. Same fallacy. 23 Kunkel. Right. 24 Kunkel. Wrong. Right 1 is some chocolate creams are delicious. 25 No Kunkel. Fallacy of like eliminans not asserted to exist. 26 No Kunkel. Fallacy of unlike eliminans with an entity premise. 27 Kunkel. Wrong. Right 1 is some pillows are not pokers. 28 Kunkel. Right. 29 No Kunkel. Fallacy of unlike eliminans with an entity premise. 30 No Kunkel. Fallacy of like eliminans not asserted to exist. 31 Kunkel. right. 32 no cancel. Fallacy of like eliminans not asserted to exist. 33 no cancel. Fallacy of unlike eliminans with an entity premise. PG 13234. Cancel. Wrong. Right one is some dreaded persons are not begged to prolong their visits. 35 cancel. Wrong. Right one is no man walks on neither. 36 cancel. Right. 37 no cancel. Fallacy of unlike eliminans with an entity premise. 38 cancel. Wrong. Right one is some persons, dreaded by children, are not emperors. 39 cancel. Incomplete. The omitted portion is sugar is not salt. 40 cancel. Right. An 8 answers to 8. 1 a 1 B 0 B 1 a 0. 2 D 1 a 0. 3 A C 0. 4 a 1 D 0. 5 C D 0. 6 D 1 C 0. 7 A C 0. 8 C 1 A 0. 9 C D 0. 10 B 1 A 0. 11 D 1 B 0. 12 A D 0. 13 E 1 B 0. 14 D 1 E 0. 15 E 1 A 0. 16 B C 0. 17 A 1 B 0. 18 D 1 C 0. 19 A 1 D 0. 20 A C 0. 21 D 0. 22 A 1 B 0. 23 H 1 C 0. 24 E 1 A 0. 25 E 1 C 0. 26 E 1 C 0. 27 HK 0. 28 E 1 D 0. 29 L A 0. 30 K 1 B 0. And 9 answers to 9. 1 Babies cannot manage crocodiles. 2 Your presents to me are not made of tin. 3 All my potatoes in this dish are old ones. 4 My servants never say spoonge. 5 My poultry are not officers. 6 None of your sons are fit to serve on a jury. 7 No pencils of mine are sugar plums. 8 Jenkins is inexperienced. 9 No comet has a curly tail. 10 No hedgehog takes in the Times. 11 This dish is unwholesome. 12 My gardener is very old. 13 All hummingbirds are small. 14 No one with a hooked nose ever fails to make money. 15 No grey ducks in this village wear lace collars. 16 No jug in this cupboard will hold water. 17 These apples were grown in the sun. 18 Puppies, that will not lie still, never care to do worsted work. 19 No name in this list is unmelodious. 20 No MP should ride in a donkey race, unless he has perfect self-command. 21 No goods in this shop, that are still on sale, may be carried away. PG 13322. No acrobatic feat, which involves turning a quadruple somersault, is ever attempted in a circus. 23 Guinea pigs never really appreciate Beethoven. 24 No scentless flowers please me. 25 Showy talkers are not really well informed. 26 None but red-haired boys learn Greek in this school. 27 Wedding cake always disagrees with me. 28 Discussions that go on while Tompkins is in the chair endanger the peacefulness of our debating club. 29 All gluttons, who are children of mine, are unhealthy. 30 An egg of the great auk is not to be had for a song. 31 No books sold here have gilt edges, unless they are priced at 5s and upwards. 32 When you cut your finger, you will find tincture of calendula useful. 33 I have never come across a mermaid at sea. 34 All the romances in this library are well written. 35 No bird in this aviary lives on mince pies. 36 No plum pudding, that has not been boiled in a cloth, can be distinguished from soup. 37 All your poems are uninteresting. 38 None of my peaches have been grown in a hothouse. 39 No pawnbroker is dishonest. 40 No kitten with green eyes will play with a gorilla. 41 All my friends dine at the lower table. 42 My writing desk is full of live scorpions. 43 No Mandarin ever reads Hogg's poems. 44 Shakespeare was clever. 45 Rainbows are not worth writing odes to. 46 These Srites examples are difficult. 47 All my dreams come true. 48 All the English pictures here are painted in oils. 49 Donkeys are not easy to swallow. 50 Opium eaters never wear white kid gloves. 51 A good husband always comes home for his tea. 52 Bathing machines are never made of mother of pearl. 53 Rainy days are always cloudy. 54 No heavy fish is unkind to children. 55 No engine driver lives on barley sugar. 56 All the animals in the yard gnaw bones. 57 No badger can guess a conundrum. 58 No check of yours, received by me, is payable to order. 59 I cannot read any of Brown's letters. 60 I always avoid a kangaroo. PG 134 Chapter 3 Solutions 1. Propositions of relation reduced to normal form. SL1 Solutions for 1. 1. The univ is persons. The individual I may be regarded as a class of persons, whose peculiar attribute is represented by the name I, and may be called the class of I's. It is evident that this class cannot possibly contain more than one member, hence the sign of quantity is all. The verb have been may be replaced by the phrase are persons who have been. The proposition may be written thus, all sign of quantity. I's subject are copula. Persons who have been out for a walk predicate. Or, more briefly, all I's are persons who have been out for a walk. 2. The univ and the subject are the same as in X. 1. The proposition may be written all I's are persons who feel better. 3 Univ. Is persons. The subject is evidently the class of persons from which John is excluded, i.e. it is the class containing all persons who are not John. The sign of quantity is no. The verb has read may be replaced by the phrase are persons who have read. The proposition may be written no persons who are not John are persons who have read the letter. 4 Univ. Is persons. The subject is evidently the class of persons whose only two members are you and I. Hence the sign of quantity is no. The proposition may be written no members of the class you and I are old persons pg 1355. Univ. Is creatures. The verb run well may be replaced by the phrase are creatures that run well. The proposition may be written no fat creatures are creatures that run well. 6 Univ. Is persons. The subject is evidently the class of persons who are not brave. The verb deserve may be replaced by the phrase are deserving of. The proposition may be written no not brave persons are persons deserving of the fair. 7 Univ. Is persons. The phrase looks poetical evidently belongs to the predicate, and the subject is the class of persons, whose peculiar attribute is not pale. The proposition may be written no not pale persons are persons who look poetical. 8 Univ. Is persons. The proposition may be written some judges are persons who lose their tempers. 9 Univ. Is persons. The phrase never neglect is merely a stronger form of the phrase am a person who does not neglect. The proposition may be written all eyes are persons who do not neglect important business. 10 Univ. Is things. The phrase what is difficult, i.e. that which is difficult, is equivalent to the phrase all difficult things. The proposition may be written all difficult things are things that need attention. 11 Univ. Is things. The phrase what is unwholesome may be interpreted as in X. 10 The proposition may be written all unwholesome things are things that should be avoided. 12 Univ. Is laws. The predicate is evidently a class whose peculiar attribute is relating to excise. The proposition may be written all laws passed last week are laws relating to excise. 13 Univ. Is things. The subject is evidently the class of studies whose peculiar attribute is logical, hence the sign of quantity is all. The proposition may be written all logical studies are things that puzzle me. 14 Univ. Is persons. The subject is evidently persons in the house. The proposition may be written no persons in the house are Jews. 15 Univ. Is dishes. The phrase if not well cooked is equivalent to the attribute not well cooked. The proposition may be written some not well cooked dishes are unwholesome dishes. PG 13616. Univ. Is books. The phrase make one drowsy may be replaced by the phrase are books that make one drowsy. The sign of quantity is evidently all. The proposition may be written: all unexciting books are books that make one drowsy. 17 Univ. Is men. The subject is evidently a man who knows what he's about, and the word when shows that the proposition is asserted of every such man, i.e. of all such men. The verb can may be replaced by are men who can. The proposition may be written: all men who know what they are about are men who can detect a sharper. 18 The univ and the subject are the same as in X. 4 The proposition may be written: all members of the class U and I are persons who know what they are about. 19 Univ. Is persons. The verb where may be replaced by the phrase are accustomed to wear. The proposition may be written: some bald persons are persons accustomed to wear wigs. 20 Univ. Is persons. The phrase never talk is merely a stronger form of are persons who do not talk. The proposition may be written: all fully occupied persons are persons who do not talk about their grievances. 21 Univ. Is riddles. The phrase if they can be solved is equivalent to the attribute that can be solved. The proposition may be written: no riddles that can be solved are riddles that interest me. 2. Method of diagrams. SL4A solutions for 4, numbers 112. 1. No MRX, all MRY. Diagram representing X prime M does not exist and all M prime RY. Diagram representing X prime Y prime does not exist, therefore no X RY. PG 1372. No MRX, some MRY. Diagram representing X M prime does not exist and Y prime M prime exists. Diagram representing X Y prime exists, therefore some X RY. 3. All MRX, all MRY. Diagram representing all M prime RX and all M prime RY prime. Diagram representing X Y prime exists, therefore some X RY. 4. No XRM, all YRM. Diagram representing X prime M prime does not exist and all Y prime RM. There is no conclusion. 5. Some MRX, no YRM. Diagram representing X prime M exists and YM does not exist. Diagram representing X prime Y prime exists, therefore some XRY. 6. No XRM, no MRY. Diagram representing X prime M and YM do not exist, there is no conclusion. 7. No MRX, some YRM. Diagram representing X prime M does not exist and Y prime M exists. Diagram representing X Y prime exists, therefore some XRY. 8. All MRX, no MRY. Diagram representing all M prime RX prime and YM prime does not exist. Diagram representing X prime Y prime exists, therefore some XRY. PG 1389. Some XRM, no MRY. Diagram representing X prime M prime exists and Y prime M does not exist, there is no conclusion. 10. All XRM, all YRM. Diagram representing all XRM and all Y prime RM prime. Diagram representing all XRY and all Y prime RX prime, therefore all XRY, all YRX. 11. No MRX, all yrm. Diagram representing xm does not exist and all y prime rm prime there is no conclusion. 12 no xrm, all yrm. Diagram representing xm does not exist and all yrm. Diagram representing all yrx prime therefore all yrx. SL5A Solutions for 5, numbers 112. 1. I have been out for a walk, I am feeling better. Univ. Is persons, M equals the class of I's, X equals persons who have been out for a walk, Y equals persons who are feeling better. All M are X, all M are Y. Diagram representing all M are X and all M are Y. Diagram representing X Y exists therefore some X are Y i.e. somebody, who has been out for a walk, is feeling better. PG 1392. No one has read the letter but John, no one, who has not read it, knows what it is about. Univ. Is persons, M equals persons who have read the letter, X equals the class of Johns, Y equals persons who know what the letter is about. No X are M, no M are Y. Diagram representing X prime M and Y M prime do not exist. Diagram representing X prime Y does not exist therefore no X are Y i.e. no one, but John, knows what the letter is about. 3. Those who are not old like walking, you and I are young. Univ. Is persons, M equals old, X equals persons who like walking, Y equals you and I. All M are X, all Y are M. Diagram representing all M prime are X and all Y are M prime. Diagram representing all Y are X therefore all Y are X i.e. you and I like walking. 4. Your course is always honest, your course is always the best policy. Univ. Is courses, M equals your, X equals honest, Y equals courses which are the best policy. All M are X, all M are Y. Diagram representing all M are X and all M are Y. Diagram representing X Y exists therefore some X are Y i.e. honesty is sometimes the best policy. 5. No fat creatures run well, some greyhounds run well. Univ. Is creatures, M equals creatures that run well, X equals fat, Y equals greyhounds. No X are M, some Y are M. Diagram representing XM does not exist and YM exists. Diagram representing X prime Y exists therefore some Y are X. i.e. some greyhounds are not fat. PG 146. Some, who deserve the fair, get their deserts, none but the brave deserve the fair. Univ. Is persons, M equals persons who deserve the fair, X equals persons who get their deserts, Y equals brave. Some M are X, no Y are M. Diagram representing XM exists and Y prime M does not exist. Diagram representing XY exists therefore some Y are X i.e. some brave persons get their deserts. 7. Some Jews are rich, all Esquimaux are Gentiles. Univ. Is persons, M equals Jews, X equals rich, Y equals Esquimaux. Some M are X, all Y are M. Diagram representing XM exists all Y are M. Diagram representing XY prime exists therefore some X are Y. i.e., some rich persons are not Esquimaux. 8 sugar plums are sweet, some sweet things are liked by children. Univ. Is things, m equals sweet, x equals sugar plums, y equals things that are liked by children. All x are m, some m are y. Diagram representing all x are m and y m exists. There is no conclusion. 9 John is in the house, everybody in the house is ill. Univ. Is persons, m equals persons in the house, x equals the class of Johns, y equals ill. All x are m, all m are y. Diagram representing all x are m and all m are y. Diagram representing all x are y. Therefore all x are y, i.e. John is ill. PG 14110. Umbrellas are useful on a journey. What is useless on a journey should be left behind. Univ. Is things, m equals useful on a journey, x equals umbrellas, y equals things that should be left behind. All x are m, all m are y. Diagram representing all x are m and all m prime are y. Diagram representing x prime y exists. Therefore some x are y, i.e. some things, that are not umbrellas, should be left behind on a journey. 11 Audible music causes vibration in the air. Inaudible music is not worth paying for. Univ. Is music, m equals audible, x equals music that causes vibration in the air, y equals worth paying for. All m are x, all m are y. Diagram representing all m are x and all m prime are y prime. Diagram representing x prime y does not exist. Therefore no x are y, i.e. no music is worth paying for, unless it causes vibration in the air. 12 Some holidays are rainy, rainy days are tiresome. Univ. Is days, m equals rainy, x equals holidays, y equals tiresome. Some x are m, all m are y. Diagram representing x m exists and all m are y. Diagram representing x y exists. Therefore some x are y, i.e. some holidays are tiresome. SL6A Solutions for 6, numbers 1-10. 1 Some x are m, no m are y. Some x are y. Diagram representing x m and y prime m does not exist. Diagram representing x y exists, hence proposed conclusion is right. PG 1422. All x are m, no y are m. No y are x. Diagram representing all x are m and y m prime does not exist. There is no conclusion. 3 Some x are m, all y are m. Some x are y. Diagram representing x m prime exists and all y prime are m. Diagram representing x y exists, hence proposed conclusion is right. 4 All x are m, no y are m. All x are y. Diagram representing all x are m and y m does not exist. Diagram representing all x are y prime, hence proposed conclusion is right. 5 Some m are x, no m are y. Some x are y. Diagram representing x prime m prime exists and y m prime does not exist. Diagram representing x prime y prime exists, hence proposed conclusion is right. 6 No x are m, all y are m. all YRX diagram representing X prime M does not exist and all YRM prime there is no conclusion. PG 1437. Some M are X, all Y are M. Some X are Y. Diagram representing X prime M prime exists and all Y prime are M prime there is no conclusion. 8 No M are X, all Y are M. All Y are X diagram representing X prime M prime does not exist and all Y prime are M prime diagram representing all Y prime are X hence proposed conclusion is right. 9 Some M are X, no M are Y. Some X are Y. Diagram representing X prime M exists and Y M does not exist. Diagram representing X prime Y prime exists hence proposed conclusion is right. 10 All M are X, all M are Y. Some Y are X. Diagram representing all M prime are X prime and all M are Y. Diagram representing X prime Y exists hence proposed conclusion is right. PG 144 SL7A Solutions 47, numbers 1-6. 1 No doctors are enthusiastic, you are enthusiastic. You are not a doctor. Univ. Persons, M equals enthusiastic, X equals doctors, Y equals U. No X are M, all Y are M. All Y are X. Diagram representing XM does not exist and all Y are M. Diagram representing all Y are X prime therefore all Y are X. Hence proposed conclusion is right. 2 All dictionaries are useful, useful books are valuable. Dictionaries are valuable. Univ. Books, M equals useful, X equals dictionaries, Y equals valuable. All X are M, all M are Y. All X are Y. Diagram representing all X are M and all M are Y. Diagram representing all X are Y therefore all X are Y. Hence proposed conclusion is right. 3 No misers are unselfish, none but misers save eggshells. No unselfish people save eggshells. Univ. People, M equals misers, X equals selfish, Y equals people who save eggshells. No M are X, no M are Y. No X are Y. Diagram representing X prime M and Y M prime do not exist. Diagram representing X prime Y does not exist therefore no X are Y. Hence proposed conclusion is right. PG 1454. Some epicures are ungenerous, all my uncles are generous. My uncles are not epicures. Univ. Persons, M equals generous, X equals epicures, Y equals my uncles. Some X are M. All Y are M. All Y are X. Diagram representing XM prime exists and all Y are M. Diagram representing XY prime exists therefore some X are Y. Hence proposed conclusion is wrong, the right one being some epicures are not uncles of mine. 5 Gold is heavy, nothing but gold will silence him. Nothing light will silence him. Univ. Things, M equals gold, X equals heavy, Y equals able to silence him. All M are X, no M are Y. No XRY. Diagram representing all MRX and YM prime does not exist. Diagram representing X prime Y does not exist, therefore no XRY. Hence proposed conclusion is right. 6. Some healthy people are fat, no unhealthy people are strong. Some fat people are not strong. Univ. Persons, M equals healthy, X equals fat, Y equals strong. Some M are X, no M are Y. Some X are Y. Diagram representing XM exists and YM prime does not exist. There is no conclusion. PG 1463. Method of subscripts. SL4B solutions for 4. 1 mx0 m1 y0 xy0, Fig. I.e. no x are y. 2 mx0 my1 xy1, Fig. 2 i.e. some x are y. 3 m1 x0 m1 y0 xy1, Fig. 3 i.e. some x are y. 4 x m0 y1 m0 nothing. Fallacy of like eliminans not asserted to exist. 5 mx1 ym0 xy1, Fig. 2 i.e. some x are y. 6 x m0 my0 nothing. Fallacy of like eliminans not asserted to exist. 7 mx0 ym1 xy1, Fig. 2 i.e. some x are y. 8 m1 x0 my0 xy1, Fig. 3 i.e. some x are y. 9 x m1 my0 nothing. Fallacy of unlike eliminans with an entity premise. 10 x1 m0 y1 m0 x1 y0 y1 x0, Fig. I, beta. I.e. all x are y, and all y are x. 11 mx0 y1 m0 nothing. Fallacy of like eliminans not asserted to exist. 12 x m0 y1 m0 y1 x0, Fig. I, alpha. I.e. all y are x. 13 m1 x0 ym0 xy0, Fig. I.e. no x are y. 14 m1 x0 m1 y0 xy0, Fig. I.e. no x are y. 15 x m0 my0 xy0, Fig. I.e. no x are y. 16 x1 m0 y1 m0, x1 y0 y1 x0, Fig. I, beta. I.e. all x are y and all y are x. 17 x m0 m1 y0 xy0, Fig. I.e. no x are y. 18 x m0 my0 xy0, Fig. I.e. no x are y. 19 m1 x0 m1 y0 xy1, Fig. 3 i.e. some x are y. 20 mx0 m1 y0 xy0, Fig. I.e. no x are y. 21 x1 m0 my1 xy1, Fig. 2 i.e. some x are y. 22 x m1 y1 m0 nothing. Fallacy of unlike eliminans with an entity premise. 23 m1 x0 ym1 xy1, Fig. 2 i.e. sum x r y. 24x m0 y1 m0 y1 x0, fig. I, alpha. i.e. all y are x. 25 mx1 y0 x y1, fig. 2 i.e. sum x r y. 26 mx0 y1 m0 y1 x0, fig. I, alpha. i.e. all y are x. 27 x1 m0 y1 m0, x1 y0 y1 x0, fig. I, beta. i.e. all x are y, and all y are x. 28 m1 x0 my1 x y1, fig. 2 i.e. sum x r y. 29 mx0 y1 m0 nothing. Fallacy of like eliminans not asserted to exist. 30 x1 m0 y m1 x y1, fig. 2 i.e. sum y are x. 31 x1 m0 y1 m0 nothing. Fallacy of like eliminans not asserted to exist. PG 14732. xm0 m1 y0 x y0, fig. i.e. no x r y. 33 mx0 my0 nothing. Fallacy of like eliminans not asserted to exist. 34 mx0 ym1 x y1, fig. 2 i.e. sum x r y. 35 mx0 y1 m0 y1 x0, fig. I, alpha. i.e. all y are x. 36 m1 x0 ym1 x y1, fig. 2 i.e. sum x r y. 37 m1 x0 ym0 x y1, fig. 3 i.e. sum x r y. 38 mx0 my0 x y0, fig. i.e. no x r y. 39 mx1 my0 x y1, fig. 2 i.e. sum x r y. 40 x m0 y1 m0 y1 x0, fig. I, alpha. i.e. all y are x. 41 x1 m0 ym0 x1 y0, fig. I, alpha. i.e. all x are y. 42 mx0 ym0 x y0, fig. i.e. no x r y. SL5B solutions for 5, numbers 13-24. 13 No Frenchman like plum pudding, all Englishmen like plum pudding. Univ. Men, M equals liking plum pudding, X equals French, Y equals English. xm0 y1 m0 y1 x0, fig. I, alpha. i.e. Englishmen are not Frenchmen. 14 No portrait of a lady, that makes her simper or scowl, is satisfactory. No photograph of a lady ever fails to make her simper or scowl. Univ. Portraits of ladies, M equals making the subject simper or scowl, X equals satisfactory, Y equals photographic. mx0 ym0 xy0, fig. i.e. no photograph of a lady is satisfactory. 15 All pale people are phlegmatic, no one looks poetical unless he is pale. Univ. People, M equals pale, X equals phlegmatic, Y equals looking poetical. M1 X0 My0 XY0, Fig. I.e. No one looks poetical unless he is phlegmatic. 16 No old misers are cheerful, some old misers are thin. Univ. Persons, M equals old misers, X equals cheerful, Y equals thin. Mx0 My1 XY1, Fig. 2 i.e. Some thin persons are not cheerful. 17 No one, who exercises self-control, fails to keep his temper, some judges lose their tempers. Univ. Persons, M equals keeping their tempers, X equals exercising self-control, Y equals judges. XM0 YM1 XY1, Fig. 2 i.e. Some judges do not exercise self-control. PG 14818. All pigs are fat, nothing that is fed on barley water is fat. Univ. Is things, M equals fat, X equals pigs, Y equals fed on barley water. X1 M0 YM0 X1 Y0, Fig. I, alpha. I.e. pigs are not fed on barley water. 19 All rabbits, that are not greedy, are black, no old rabbits are free from greediness. Univ. Is rabbits, M equals greedy, X equals black, Y equals old. M1 X0 YM0 XY1, Fig. 3 i.e. Some black rabbits are not old. 20 Some pictures are not first attempts, no first attempts are really good. Univ. Is things, M equals first attempts, X equals pictures, Y equals really good. XM1 My0 Nothing. Fallacy of unlike eliminans with an entity premise. 21 I never neglect important business, your business is unimportant. Univ. Is business, M equals important, X equals neglected by me, Y equals your. Mx0 Y1 M0 Nothing. Fallacy of like eliminans not asserted to exist. 22 Some lessons are difficult, what is difficult needs attention. Univ. Is things, M equals difficult, X equals lessons, Y equals needing attention. XM1 M1 Y0 XY1, Fig. 2 i.e. Some lessons need attention. 23 All clever people are popular, all obliging people are popular. Univ. Is people, M equals popular, X equals clever, Y equals obliging. X1 M0 Y1 M0 Nothing. Fallacy of like eliminans not asserted to exist. 24 Thoughtless people do mischief, no thoughtful person forgets a promise. Univ. Is persons, M equals thoughtful, X equals mischievous, Y equals forgetful of promises. M1 X0 My0 XY0 i.e. No one, who forgets a promise, fails to do mischief. SL6B Solutions for 6. 1XM1 My0 XY1, Fig. 2. Concl. right. 2x1m0 fallacy of like eliminans not asserted to exist. 3xm1y1m0xy1, fig. 2. Concl. Right. PG 1494. x1m0ym0x1y0, fig. I, alpha, concl. Right. 5mx1my0xy1, fig. 2. Concl. Right. 6xm0y1m0 fallacy of like eliminans not asserted to exist. 7mx1y1m0 fallacy of unlike eliminans with an entity premise. 8mx0y1m0y1x0, fig. I, alpha, concl. Right. 9mx1my0xy1, fig. 2. Concl. Right. 10m1x0m1y0xy1, fig. 3. Concl. Right. 11x1m0ym1xy1, fig. 2. Concl. Right. 12xm0my0xy0, fig. I. Concl. Right. 13xm0y1m0y1x0, fig. I, alpha, concl. Right. 14m1x0m1y0xy1, fig. 3. Concl. Right. 15mx1y1m0xy1, fig. 2. Concl. Right. 16xm0y1m0 fallacy of like eliminans not asserted to exist. 17mx0m1y0xy1, fig. 3. Concl. Right. 18xm0my1xy1, fig. 2. Concl. Right. 19mx1m1y0xy1, fig. 2. Concl. Right. 20xm0my1xy1, fig. 2. Concl. Right. 21mx0m1y0xy1, fig. 3. Concl. Right. 22x1m0ym1xy1, fig. 2. Concl. Wrong, the right one is some x or y. 23m1x0my0xy0, fig. I. Concl. Right. 24x1m0m1y0x1y0, fig. I, alpha, concl. Right. 25xm0m1y0xy0, fig. I. Concl. Right. 26m1x0y1m0y1x0, fig. I, alpha, concl. Right. 27x1m0my0x1y0, fig. I, alpha, concl.
right. 28x1m0ym0 fallacy of like eliminans not asserted to exist. 29xm0my0xy0, fig. I. Control. Right. 30x1m0m1y0x1y0, fig. I. Alpha. Control. Right. 31x1m0ym0x1y0, fig. I. Alpha. Control. Right. 32xm0ym0xy0, fig. I. Control. Right. 33m1x0y1m0y1x0, fig. I. Alpha. Control. Right. 34x1m0ym1 fallacy of unlike eliminans with an entity premise. 35xm1m1y0xy1, fig. 2. Control. Right. 36m1x0y1m0y1x0, fig. I. Alpha. Control. Right. 37mx0m1y0xy1, fig. 3. Control. Right. 38xm0my0 fallacy of like eliminans not asserted to exist. 39mx0my1xy1, fig. 2. Control. Right. 40mx0ym1xy1, fig. 2. Control. Right. PG 150 SL7B Solutions for 7. 1. No doctors are enthusiastic. You are enthusiastic. You are not a doctor. Univ. Persons, M equals enthusiastic, X equals doctors, Y equals U. xm0 y1 m0 y1 x0, fig. I. Alpha. Conclusion right. 2. Dictionaries are useful. Useful books are valuable. Dictionaries are valuable. Univ. Books, M equals useful, X equals dictionaries, Y equals valuable. x1 m0 m1 y0 x1 y0, fig. I. Alpha. Conclusion right. 3. No misers are unselfish, none but misers save eggshells. No unselfish people save eggshells. Univ. People, M equals misers, X equals selfish, Y equals people who save eggshells. mx0 my0 xy0, fig. I. Conclusion right. 4. Some epicures are ungenerous, all my uncles are generous. My uncles are not epicures. Univ. Persons, M equals generous, X equals epicures, Y equals my uncles. xm1 y1 m0 xy1, fig. 2. Conclusion wrong. Right. 1 is some epicures are not uncles of mine. 5. Gold is heavy, nothing but gold will silence him. Nothing light will silence him. Univ. Things, M equals gold, X equals heavy,
y equals able to silence him. M1x0 my0 xy0, Fig. I. Conclusion right. 6. Some healthy people are fat, no unhealthy people are strong. Some fat people are not strong. Univ. People, M equals healthy, X equals fat, Y equals strong. MX1 MY0 No conclusion. Fallacy of unlike eliminans with an entity premise. 7. I saw it in a newspaper, all newspapers tell lies. It was a lie. Univ. Publications, M equals newspapers, X equals publications in which I saw it, Y equals telling lies. X1 M0 M1 Y0 X1 Y0, Fig. I, alpha. Conclusion wrong. Right one is the publication, in which I saw it, tells lies PG 1518. Some cravats are not artistic, I admire anything artistic. There are some cravats that I do not admire. Univ. Things, M equals artistic, X equals cravats, Y equals things that I admire. XM1 M1 Y0 No conclusion. Fallacy of unlike eliminans with an entity premise. 9. His songs never last an hour. A song that lasts an hour is tedious. His songs are never tedious. Univ. Songs, M equals lasting an hour, X equals his, Y equals tedious. X1 M0 M1 Y0 XY1, Fig. 3. Conclusion wrong. Right one is some tedious songs are not his. 10. Some candles give very little light, candles are meant to give light. Some things that are meant to give light give very little. Univ. Things, M equals candles, X equals giving and C. Y equals meant and CMX1 M1 Y0 XY1, Fig. 2. Conclusion right. 11. All who are anxious to learn work hard. Some of these boys work hard. Some of these boys are anxious to learn. Univ. Persons, M equals hard-working, X equals anxious to learn, Y equals these boys. X1 M0 Y M1 No conclusion. Fallacy of unlike eliminans with an entity premise. 12. All lions are fierce, some lions do not drink coffee. Some creatures that drink coffee are not fierce. Univ. Creatures, M equals lions, X equals fierce, Y equals creatures that drink coffee. M1x0 my 1xy1, Fig. 2. Conclusion wrong. Right one is some fierce creatures do not drink coffee. 13. No misers are generous, some old men are ungenerous. Some old men are misers. Univ. Persons, M equals generous, X equals misers, Y equals old men. XM0 YM1 No conclusion. Fallacy of unlike eliminans with an entity premise. 14. No fossil can be crossed in love, an oyster may be crossed in love. Oysters are not fossils. Univ. Things, M equals things that can be crossed in love, X equals fossils, y equals oysters. X m0 y1 m0 y1 x0, Fig. I, alpha. Conclusion right. PG 15215. All uneducated people are shallow, students are all educated. No students are shallow. Univ. People, M equals educated, X equals shallow, Y equals students. M1 x0 y1 m0 x y1, Fig. 3 Conclusion wrong. Right one is some shallow people are not students. 16 All young lambs jump, no young animals are healthy, unless they jump. All young lambs are healthy. Univ. Young animals, M equals young animals that jump, X equals lambs, Y equals healthy. X1 M0 My0 No conclusion. Fallacy of like eliminans not asserted to exist. 17 Ill-managed business is unprofitable, railways are never ill-managed. All railways are profitable. Univ. Business, M equals ill-managed, X equals profitable, Y equals railways. M1 x0 y1 m0 x y1, Fig. 3 Conclusion wrong. Right one is some business, other than railways, is profitable. 18 No professors are ignorant, all ignorant people are vain. No professors are vain. Univ. People, M equals ignorant, X equals professors, Y equals vain. X m0 m1 y0 x y1, Fig. 3 Conclusion wrong. Right one is some vain persons are not professors. 19 A prudent man shuns high-owness. No banker is imprudent. No banker fails to shun high-owness. Univ. Men, M equals prudent, X equals shunning high-owness, Y equals bankers. M1 x0 y m0 x y0, Fig. I conclusion right. 20 All wasps are unfriendly, no puppies are unfriendly. No puppies are wasps. Univ. Creatures, M equals friendly, X equals wasps, Y equals puppies. X1 M0 Y M0 X1 Y0, Fig. I, alpha. Conclusion incomplete. Complete one is wasps are not puppies. 21 No Jews are honest, some Gentiles are rich. Some rich people are dishonest. Univ. Persons, M equals Jews, X equals honest, Y equals rich. MX0 MY1 No conclusion. Fallacy of unlike eliminans with an entity premise. PG 15322. No idlers win fame, some painters are not idle. Some painters win fame. Univ. Persons, M equals idlers, X equals persons who win fame, Y equals painters. MX0 YM1 No conclusion. Fallacy of unlike eliminans with an entity premise. 23 No monkeys are soldiers, all monkeys are mischievous. Some mischievous creatures are not soldiers. Univ. Creatures, M equals monkeys, X equals soldiers, Y equals mischievous. mx0 m1 y0 xy1, Fig. 3 conclusion right. 24 All these bonbons are chocolate creams, all these bonbons are delicious. Chocolate creams are delicious. Univ. Food, m equals these bonbons, x equals chocolate creams, y equals delicious. m1 x0 m1 y0 xy1, Fig. 3 conclusion wrong, being in excess of the right one, which is some chocolate creams are delicious. 25 No muffins are wholesome, all buns are unwholesome. Buns are not muffins. Univ. Food, m equals wholesome, x equals muffins, y equals buns. xm0 y1 m0 No conclusion. Fallacy of like eliminans not asserted to exist. 26 Some unauthorized reports are false, all authorized reports are trustworthy. Some false reports are not trustworthy. Univ. Reports, m equals authorized, x equals true, y equals trustworthy. mx1 m1 y0 No conclusion. Fallacy of unlike eliminans with an entity premise. 27 Some pillows are soft, no pokers are soft. Some pokers are not pillows. Univ. Things, m equals soft, x equals pillows, y equals pokers. xm1 ym0 xy1, Fig. 2 conclusion wrong, right one is some pillows are not pokers. 28 Improbable stories are not easily believed, none of his stories are probable. None of his stories are easily believed. Univ. Stories, m equals probable, x equals easily believed, y equals his. m1 x0 ym0 xy0, Fig. I conclusion right. PG 15429. No thieves are honest, some dishonest people are found out. Some thieves are found out. Univ. People, m equals honest, x equals thieves, y equals found out. xm0 my1 No conclusion. Fallacy of unlike eliminans with an entity premise. 30 No muffins are wholesome, all puffy food is unwholesome. All muffins are puffy. Univ. Is food, m equals wholesome, x equals muffins, y equals puffy. xm0 y1 m0 No conclusion. Fallacy of like eliminans not asserted to exist. 31 No birds, except peacocks, are proud of their tails. Some birds, that are proud of their tails, cannot sing. Some peacocks cannot sing. Univ. Birds, m equals proud of their tails, x equals peacocks, y equals birds that cannot sing. xm0 my1 xy1, Fig. 2 conclusion right. 32 Warmth relieves pain, nothing that does not relieve pain is useful in toothache. Warmth is useful in toothache. Univ. Applications, m equals relieving pain, x equals warmth, y equals useful in toothache. x1 m0 my0 No conclusion. Fallacy of like eliminans not asserted to exist. 33 No bankrupts are rich, some merchants are not bankrupts. Some merchants are rich. Univ. Persons, M equals bankrupts, X equals rich, Y equals merchants. MX0 YM1 No conclusion. Fallacy of unlike eliminans with an entity premise. 34 Bores are dreaded, no bore is ever begged to prolong his visit. No one, who is dreaded, is ever begged to prolong his visit. Univ. Persons, M equals bores, X equals dreaded, Y equals begged to prolong their visits. M1x0 my0 xy1, Fig. 3 Conclusion wrong. The right one is some dreaded persons are not begged to prolong their visits. 35 All wise men walk on their feet, all unwise men walk on their hands. No man walks on both. Univ. Men, M equals wise, X equals walking on their feet, Y equals walking on their hands. M1x0 M1y0 xy0, Fig. I conclusion wrong. Right one is no man walks on neither PG 15536. No wheelbarrows are comfortable, no uncomfortable vehicles are popular. No wheelbarrows are popular. Univ. Vehicles, M equals comfortable, X equals wheelbarrows, Y equals popular. XM0 MX0 XY0, Fig. I conclusion right. 37 No frogs are poetical, some ducks are unpoetical. Some ducks are not frogs. Univ. Creatures, M equals poetical, X equals frogs, Y equals ducks. XM0 YM1 No conclusion. Fallacy of unlike eliminans with an entity premise. 38 No emperors are dentists, all dentists are dreaded by children. No emperors are dreaded by children. Univ. Persons, M equals dentists, X equals emperors, Y equals dreaded by children. XM0 M1 Y0 XY1, Fig. 3 Conclusion wrong. Right one is some persons, dreaded by children, are not emperors. 39 Sugar is sweet, salt is not sweet. Salt is not sugar. Univ. Things, M equals sweet, X equals sugar, Y equals salt. X1 M0 Y1 M0, X1 Y0 Y1 X0, Fig. I, beta. Conclusion incomplete, omitted portion is sugar is not salt. 40 Every eagle can fly, some pigs cannot fly. Some pigs are not eagles. Univ. Creatures, M equals creatures that can fly, X equals eagles, Y equals pigs. X1 M0 Y M1 XY1, Fig. 2 Conclusion right. SL8 Solutions for 8. 1 CD02 A 1D03 B1C0, 1 CD2 Add 3 BCAB0 A 1 B1IE A 1 B0 B1 A02. 1 D1 B02 AC03 BC0, 1 dB3 BC2 AC the 0 D1 IE D1 A 0 3 1 BA0 2 CD0 3 D1 B0 1 BA3 DB2 CDAC 0 4 1 BC0 2 A 1 B03 CD0 1 BC2 AB3 CD add 0 A 1 IE A 1 D0 PG 1565 1 B1 A 0 2 BC0 3 AD0 1 BA2 BC3 ADCD 06 1 A 1 B0 2 BC0 3 D1 A0 1 AB2 BC3 the CD0 D1 IE D1 C07 1 DB0 2 B1 A0 3 CD0 1 DB2 BA3 CDAC08 1 BD0 2 AB0 3 C1 D0 1 BD2 AB3 CDAC0 C1 IE C1 A09 1 B1 A0 2 add 0 3 B1 C0 1 BA2 add 3 BCDC 010 1 CD0 2 B1 C0 3 add 0 1 CD2 BC3 add BA0 B1 IE B1 A0 11 1 BC0 2 D1 A0 3 C1 A0 1 BC3 CA2 the BD0 D1 IE D1 B0 12 1 CB0 2 C1 D0 3 B1 A0 1 CB2 CD3 BA the 0 13 1 D1 E0 2 C1 A0 3 BD0 4 E1 A0 1 D3 BD4 EA2 CABC 0 C1 IE C1 B0 14 1 C1 B0 2 A1 E0 3 D1 B0 4 A1 C0 1 CB3 DB4 AC2 ADA 0 D1 IE D1 E0 15 1 BD0 2 E1 C0 3 B1 A0 4 D1 C0 1 BD3 BA4 DC2 ECAE 0 E1 IE E1 A0 16 1 AE0 2 D1 C0 3 A1 B0 4 E1 D0 1 AE3 AB4 ED2 DC BC 0 17 1 D1 C0 2 A1 E0 3 BD0 4 C1 E0 1 DC3 BD4 CE2 ABA0 A1 IE A1 B0 18 1 A1 B0 2 D1 E0 3 A1 C0 4 B0 1 AB3 AC4 B2 to CD0 D1 IE D1 C0 19 1 BC0 2 E1 H0 3 A1 B0 4 DH0 5 E1 C0 1 BC3 AB5 EC2 A4 DH add 0 A1 IE A1 D0 20 1 DH0 2 CE0 3 H1 B0 4 add 0 5 B0 1 DH3 HB4 add 5 B2 CEAC 0 21 1 B1 A0 2 DH0 3 CE0 4 R0 5 C1 B0 1 BA4 R2 DH5 CB3 CE to 0 22 1 E1 D0 2 BH0 3 C1 D0 4 1 E0 5 CH0 1 ED3 CD4 A5 CH2 BHAB0 A1 IE A1 B0 PG 15723
1B1A02-03H1B04CE05D1A0, 1BA3HB5D2-4CEHC0H1IEH1C024, 1H1K02B003C1D05DK06BC0, 1HK4A5DK3CD6BC2BAEA0E1IE1A025, 1A1D01K1B01E1H05D1C06H1K0, 1AD4AB2KB5DC6HK3ACE0E1IE1C026, 1A1H02DK03E1B05A1C06BD0, 1AH4HK2DK5AC6BD3IBCE0E1IE1C027, 1E1D02HB003A1K04CE05B1D06AC0, 1ED4CE5BD2HB6AC3AKHK028, 1AK02E1B03HK04DC05AB06C1H0, 1AK3HK5AB2IB6CH4DC ED0E1IE1D029, 1EK002BM038C04H1E05D1K07D1L08HM0, 1EK4HE5DK7DL8HM2BM6CB3ACL030, 1N1M02815R05R06DL05R09M1R010H1D0, 1NM7CN3CL6DL9 Mr 4 Crowns 10HD5R2AE8IB KB0K1IEK1B0SL9 Solutions 49, 11B1D02AC03D1C0, 1BD3DC2ACBA0B1, i.e. B1A0 i.e. babies cannot manage crocodiles. 21A1B02D1C03BC0, 1AB3BC2DC add 0D1, i.e. D1A0 i.e. Your presents to me are not made of tin. PG 1583. 1 the 02C1B03AB0, 1 the 3AB2CBDC0C1, i.e. C1D0 i.e. All my potatoes in this dish are old ones. 4 1BA02BD03C1A0, 1BA2BD3CADC0C1, i.e. C1D0 i.e. My servants never say spoonge. 5 1 add 02CD03B1A0, 1 add 2CD3BACB0B1, i.e. B1C0 i.e. My poultry are not officers. 6 1C1A02CB03 the 0, 1CA2CB3 the BD0 i.e. None of your sons are fit to serve on a jury. 7 1CB02 the 03B1A0,
1 CB3B A to the CD0 IE. No pencils of mine are sugar plums. 81 CB02 D1A03 BA0, 1 CB3 BA to the CD0 D1, i.e. D1 C0 i.e. Jenkins is inexperienced. 91 CD02 DA03 CB0, 1 CD2 DA3 CBAB0 IE. No comet has a curly tail. 10 1 DC02 BA03 A1 D0, 1 DC3 AD2 BACB0 IE. No hedgehog takes in the times. 11 1 B1 A02 C1 B03 add 0, 1 BA2 CB3 add CD0 C1, i.e. C1 D0 IE. This dish is unwholesome. 12 1 B1 C02 D03 AC0, 1 BC3 AC2 DAB D0 B1, i.e. B1 D0 IE. My gardener is very old. 13 1 A1 D02 BC03 C1 D0, 1 add 3 CD2 BCAB0 A1, i.e. A1 B0 IE. All hummingbirds are small. PG 15914. 1 CB02 A1 D03 CA0, 1 CB3 CA2 add BD0 IE. No one with a hooked nose ever fails to make money. 15 1 B1 A02 B1 D03 CA0, 1 BA2 BD3 CADC0 IE. No grey ducks in this village wear lace collars. 16 1 D1 B02 CD03 BA0, 1 DB2 CD3 BACA0 IE. No jug in this cupboard will hold water. 17 1 B1 D02 C1 D03 AB0, 1 BD2 CD3 ABCA0 C1, i.e. C1 A0 IE. These apples were grown in the sun. 18 1 D1 B02 C1 B03 CA0, 1 DB2 CB3 CAD0 D1, i.e. D1 A0 IE puppies, that will not lie still, never care to do worsted work. 19 1 BD02 A1 C03 AD0, 1 BD3 AD2 ACBC0 IE. No name in this list is unmelodious. 21 A1 B02 DC03 A1 D0, 1 AB3 AD2 DCBC0 IE. No MP should ride in a donkey race, unless he has perfect self-command. 21 1 BD02 CA03 BC0, 1 BD3 BC2 CA the 0 IE. No goods in this shop, that are still on sale, may be carried away. 22 1 AB02 CD03 DA0, 1 AB3 DA2 CDBC0 IE. No acrobatic feat, which involves turning a quadruple somersault, is ever attempted in a circus. 23 1 DC02 A1 B03 BC0, 1 DC3 BC2 AB the 0 A1, i.e. A1 D0 i.e. guinea pigs never really appreciate Beethoven. PG 16024. 1 A1 D02 B1 C03 BA0, 1 add 3 BA 2 BC DC 0 IE. No scentless flowers please me. 25 1 C1 D0 2 BA0 3 D1 A0, 1 CD3 the 2 BACB0 C1, IE C1 B0 IE. Showy talkers are not really well informed. 26 1 EA0 2 B1 D0 3 A1 C0 4 EB0, 1 EA3 AC4 EB2 BDCD0 IE. None but red-haired boys learn Greek in this school. 27 1 B1 D0 2 AC0 3 E1 D0 4 C1 B0, 1 BD3 Ed 4 CB2 ACEA0 E1, IE E1 A0 IE. Wedding cake always disagrees with me. 28 1 add 0 2 E1 B0 3 C1 D0 4 E1 A0, 1 add 3 CD 4 EA2 EBCB0 C1, IE C1 B0 IE. Discussions that go on while Tompkins is in the chair endanger the peacefulness of our debating club. 29 1 D1 A0 2 EC0 3 B1 A0 4 DE0, 1 the 3 BA4 DE2 ECBC0 B1, IE B1 C0 IE. All gluttons in my family are unhealthy. 31 D1 E0 2 C0 3 B1 E0 4 C1 D0, 1 to 3 B4 CD2 CABA0 B1, IE B1 A0 IE. An egg of the great auk is not to be had for a song. 31 1 DB0 2 A1 C0 3 C1 E0 4 AD0, 1 DB4 AD2 AC3 CEB0 IE. No books sold here have gilt edges unless they are priced at 5s and upwards. 32 1 A1 C0 2 D1 B0 3 A1 E0 4 C1 B0, 1 AC3 A4 CB2 DBE D0 D1, IE D1 E0 IE. When you cut your finger, you will find tincture of calendula useful. 33 1 DB0 2 A1 E0 3 EC0 4 D1 A0, 1 DB4 the 2 A3 ECBC0 IE. I have never come across a mermaid at sea. PG 16134. 1 C1 B0 2 A1 E0 3 D1 B0 4 A1 C0, 1 CB3 DB4 AC2 ADA 0 D1, IE D1 E0 IE. All the romances in this library are well written. 35 1 ED0 2 CA0 3 IB0 4 DC0, 1 ED3 IB4 DC2 CABA0 IE. No bird in this aviary lives on mince pies. 36 1 D1 C0 2 E1 A0 3 C1 B0 4 ED0, 1 DC3 CB4 ED2 EABA0 IE. No plum pudding, that has not been boiled in a cloth, can be distinguished from soup. 37 1 CE0 2 BA0 3 H1 D0 4 A0 5 BD0, 1 CE4 A2 BA5 BD3 HDCH0 H1, IE H1 C0 IE. All your poems are uninteresting. 38 1 B1 A0 2 DB0 3 He0 4 EC0 5 A1 H0, 1B 2DB 5R3 He4 ECDC0 IE. None of my peaches have been grown in a hothouse. 39 1C1D02H1E03C1A04HB05E1D0 1CD3C5ED2 He4HBAB0 IE. No pawnbroker is dishonest. 41 BD02CH03E1B04 the 05 EC0 1 BD3 IP4 the 5 EC2CHR0 IE. No kitten with green eyes will play with a gorilla. 41 1C1A02HB03A04D1C05H1E0 1CA3A4DC5 He2HBDB0D1 IE D1B0 IE. All my friends in this college dine at the lower table. 42 1CA02H1D03C1E04BA05D1E0 1CA3CE4B5D2HDBH0H1 IEH1B0 IE. My writing desk is full of live scorpions. 43 1B1E02R03DC04E1A05BC0-1BE4E2R5BC3DCHD0 No Mandarin ever reads Hobbes' poems. PG 16244 1E1B02AD03C1H04E05DH0 1IB4EA2AD5DH3CHBC0C1 IEC1B0 IE Shakespeare was clever. 45 1E1C02HB03D1A04E1A05C1B0 1EC4EA3 the 5CB2HBDH0D1 IED1H0 IE Rainbows are not worth writing odes to. 46 1C1H02E1A03BD04A1H05DC0 1CH4AH2EA5DC3BD IP0E1 IE1B0 IE. These Schreitz examples are difficult. 47 1A1E02BK03C04A05D1B06KH0 1AE3CA4A6KH2BK5DBCD0D1 IED1C0 IE. All my dreams come true. 48 1AH02CK03A1D05B1K06C1E0 1AH3AD4A6CE2CK5BKDB0B1 IEB1D0 IE. All the English pictures here are painted in oils. 49 1KE1E02C1H03B1A05H06B1E0 1KE4KD6B3BA5HA2CHDC0C1 IEC1D0 IE donkeys are not easy to swallow. 51 AB02HD03E1C04B1D05AK06C1H0 1AB4BD2HD6AK5CH3ECKE0E1 IE 1K0 IE Opiometers never wear white kid gloves. 51 1BC02K1A03A04D1B05HC06K1E0 1BC4DB5HC3A6KE2KA the 0D1 IE D1A0 IE. A good husband always comes home for his tea. 52 1A1K02CH03HK04B1D05EA06D1C018K3HK2CH6D4BD5EAB0B1 IE B1E0 IE bathing machines are never made of mother of pearl. PG 16353 1 the 02K1B03C1H04D1K05E1C06 A1H0 1 the 4DK2KB6R5CH3ECBE0E1 IE1B0 IE rainy days are always cloudy. 54 1KB01803DB04K1H05EA06D1C0 1KB3DB4KH6DC2AC5EAHE0 IE. No heavy fish is unkind to children. 55 1K1B02A03CD04HB05AC06KD0 1KB4HB2A6KD3CD5ACEA0 IE. No engine driver lives on barley sugar. 56 1H1B02C1D03K004E1H05B1A06K1C0 1HB4A5BA3KA6KC2CD ED0E1 IE1D0 IE. All the animals in the yard gnaw bones. 57 1H1D02E1C03K004CB05D1L06EH07KL0 1HD5DL7KL3KA6EH2EC4CBAB0 IE. No badger can guess a conundrum. 58 1BH02D1L03CA04D1K05H1E06MC07AB08E0 1BH5HE7AB3CA6MC8E4DK2DLML0 IE. No check of yours, received by me, is payable to order. 59 1C1L02HE03KD04MC05B1E06N1A07L1D08MB09R0 1CL4MC7LD3KD8MB5BE2HE9R6 NA I cannot read any of Brown's letters. 61 E1C02L1N03D1A05C K06ER07H1N08BK09R1D010M1L0 1EC5CK6ER8BK4MB9RD3 the 10ML2LN7HNAH0H1 IEH1A0 IE. I always avoid a kangaroo. PG 164 notes. A. CP80. One of the favorite objections, brought against the science of logic by its detractors, is that a syllogism has no real validity as an argument, since it involves the fallacy of petitio principii, i.e. begging the question, the essence of which is that the whole conclusion is involved in one of the premises. This formidable objection is refuted, with beautiful clearness and simplicity, by these three diagrams, which show us that, in each of the three figures, the conclusion is really involved in the two premises taken together, each contributing its share. Thus, in Fig. I, the premise xm0 empties the inner cell of the NW quarter, while the premise ym0 empties its outer cell. Hence it needs the two premises to empty the whole of the NW quarter, and thus to prove the conclusion xy0. Again, in Fig. 2, the premise xm0 empties the inner cell of the NW quarter. The premise ym1 merely tells us that the inner portion of the W half is occupied, so that we may place a I in it, somewhere, but, if this were the whole of our information, we should not know in which cell to place it, so that it would have to sit on the fence. It is only when we learn, from the other premise, that the upper of these two cells is empty, that we feel authorized to place the I in the lower cell, and thus to prove the conclusion xy1. Lastly, in Fig. 3, the information that M exists merely authorizes us to place a I somewhere in the inner square, but it has large choice of fences to sit upon. It needs the premise xm0 to drive it out of the n half of that square, and it needs the premise ym0 to drive it out of the W half. Hence it needs the two premises to drive it into the inner portion of the SE quarter, and thus to prove the conclusion xy1. pg 165 Appendix, addressed to teachers. 1. Introductory. There are several matters, too hard to discuss with learners, which nevertheless need to be explained to any teachers, into whose hands this book may fall, in order that they may thoroughly understand what my symbolic method is, and in what respects it differs from the many other methods already published. These matters are as follows: the existential import of propositions, the use of is not, or are not, as a copula. The theory two negative premises prove nothing. Euler's method of diagrams. Venn's method of diagrams. My method of diagrams. The solution of a syllogism by various methods. My method of treating syllogisms and srites. Some account of parts 2, 3. 2. The existential import of propositions. The writers, and editors, of the logical textbooks which run in the ordinary grooves, to whom I shall hereafter refer by the, I hope inoffensive, title The Logicians, take, on this subject, what seems to me to be a more humble position than is at all necessary. They speak of the copula of a proposition with bated breath, almost as if it were a living, conscious entity, capable of declaring for itself what it chose to mean, and that we, poor human creatures, had nothing to do but to ascertain what was its sovereign will and pleasure, and submit to it. pg 166. In opposition to this view, I maintain that any writer of a book is fully authorized in attaching any meaning he likes to any word or phrase he intends to use. If I find an author saying, at the beginning of his book, let it be understood that by the word black I shall always mean white, and that by the word white I shall always mean black, I meekly accept his ruling, however injudicious I may think it. And so, with regard to the question whether a proposition is or is not to be understood as asserting the existence of its subject, I maintain that every writer may adopt his own rule, provided of course that it is consistent with itself and with the accepted facts of logic. Let us consider certain views that may logically be held, and thus settle which of them may conveniently be held, after which I shall hold myself free to declare which of them I intend to hold. The kinds of propositions, to be considered, are those that begin with some, with no, and with all. These are usually called propositions in I, in E, and in O. First, then, a proposition in I may be understood as asserting, or else as not asserting, the existence of its subject. By existence I mean of course whatever kind of existence suits its nature. The two propositions, dreams exist and drums exist, denote two totally different kinds of existence. A dream is an aggregate of ideas, and exists only in the mind of a dreamer, whereas a drum is an aggregate of wood and parchment, and exists in the hands of a drummer. First, let us suppose that I asserts, i.e. asserts the existence of its subject. Here, of course, we must regard a proposition in A as making the same assertion, since it necessarily contains a proposition in I. We now have I and A asserting. Does this leave us free to make what supposition we choose as to E? My answer is no. We are tied down to the supposition that E does not assert. This can be proved as follows: if possible, let E assert. Then, taking X, Y, and Z to represent attributes, we see that, if the proposition no X, Y or Z be true, some things exist with the attributes X and Y, i.e. some X are Y pg 167. Also we know that, if the proposition some X, Y or Z be true, the same result follows. But these two propositions are contradictories, so that one or other of them must be true. Hence this result is always true, i.e. the proposition some X or Y is always true. Quod est absurdum. See note, A, p. 195. We see, then, that the supposition I asserts necessarily leads to A asserts, but E does not. And this is the first of the various views that may conceivably be held. Next, let us suppose that I does not assert. And, along with this, let us take the supposition that E does assert. Hence the proposition no X or Y means some X exist, and none of them are Y, i.e. all of them are not Y, which is a proposition in A. We also know, of course, that the proposition all X are not Y proves no X are Y. Now two propositions, each of which proves the other, are equivalent. Hence every proposition in A is equivalent to one in E, and therefore asserts. Hence our second conceivable view is E and A assert, but I does not. This view does not seem to involve any necessary contradiction with itself or with the accepted facts of logic. But, when we come to test it, as applied to the actual facts of life, we shall find, I think, that it fits in with them so badly that its adoption would be, to say the least of it, singularly inconvenient for ordinary folk. Let me record a little dialogue I have just held with my friend Jones, who is trying to form a new club, to be regulated on strictly logical principles. Author: Well, Jones, have you got your new club started yet? Jones, rubbing his hands: You'll be glad to hear that some of the members, mind, I only say some, are millionaires. Rolling in gold, my boy. Author: That sounds well. And how many members have entered? Jones, staring: None at all. We haven't got it started yet. What makes you think we have? Author: Why, I thought you said that some of the members, PG 168 Jones, contemptuously. You don't seem to be aware that we're working on strictly logical principles. A particular proposition does not assert the existence of its subject. I merely meant to say that we've made a rule not to admit any members till we have at least 3 candidates whose incomes are over 10,000 a year. Author: Oh, that's what you meant, is it? Let's hear some more of your rules. Jones: Another is, that no one, who has been convicted 7 times of forgery, is admissible. Author: And here, again, I suppose you don't mean to assert there are any such convicts in existence. Jones: Why, that's exactly what I do mean to assert. Don't you know that a universal negative asserts the existence of its subject? Of course we didn't make that rule till we had satisfied ourselves that there are several such convicts now living. The reader can now decide for himself how far this second conceivable view would fit in with the facts of life. He will, I think, agree with me that Jones' view, of the existential import of propositions, would lead to some inconvenience. Thirdly, let us suppose that neither I nor E asserts. Now the supposition that the 2 propositions, some x are y and no x are not y, do not assert, necessarily involves the supposition that all x are y does not assert, since it would be absurd to suppose that they assert, when combined, more than they do when taken separately. Hence the third, and last, of the conceivable views is that neither I, nor E, nor A, asserts. The advocates of this third view would interpret the proposition some x are y to mean if there were any x in existence, some of them would be y, and so with E and A. It admits of proof that this view, as regards A, conflicts with the accepted facts of logic. Let us take the syllogism d'Arupti, which is universally accepted as valid. Its form is all m are x, all m are y, therefore some y are x. PG 169 This they would interpret as follows: if there were any m in existence, all of them would be x. If there were any m in existence, all of them would be y, therefore if there were any y in existence, some of them would be x. That this conclusion does not follow has been so briefly and clearly explained by Mr. Keynes, in his Formal Logic, dated 1894, pp 356, 357, that I prefer to quote his words. Let no proposition imply the existence either of its subject or of its predicate. Take, as an example, a syllogism in Darupti: all M is P, all M is S, therefore some S is P. Taking S, M, P, as the minor, middle, and major terms respectively, the conclusion will imply that, if there is an S, there is some P. Will the premises also imply this? If so, then the syllogism is valid, but not otherwise. The conclusion implies that if S exists, P exists, but, consistently with the premises, S may be existent while M and P are both non-existent. An implication is, therefore, contained in the conclusion, which is not justified by the premises. This seems to me entirely clear and convincing. Still, to make sicker, I may as well throw the above, swadhyasa, syllogism into a concrete form, which will be within the grasp of even a non-logical reader. Let us suppose that a boys' school has been set up, with the following system of rules: all boys in the first, the highest, class are to do French, Greek, and Latin. All in the second class are to do Greek only. All in the third class are to do Latin only. Suppose also that there are boys in the third class, and in the second, but that no boy has yet risen into the first. It is evident that there are no boys in the school doing French. Still we know, by the rules, what would happen if there were any. pg 170 we are authorized, then, by the data, to assert the following two propositions: if there were any boys doing French, all of them would be doing Greek; if there were any boys doing French, all of them would be doing Latin. And the conclusion, according to the logicians, would be if there were any boys doing Latin, some of them would be doing Greek. Here, then, we have two true premises and a false conclusion, since we know that there are boys doing Latin, and that none of them are doing Greek. Hence the argument is invalid. Similarly, it may be shown that this non-existential interpretation destroys the validity of dysamis, datasi, philopton, and phasison. Some of the logicians will, no doubt, be ready to reply, but we are not Aldrichians. Why should we be responsible for the validity of the syllogisms of so antiquated an author as Aldrich? Very good. Then, for the special benefit of these friends of mine, with what ominous emphasis that name is sometimes used, I must have a private interview with you, my young friend, says the bland Dr. Birch, in my library, at 9 a.m. tomorrow. And you will please to be punctual, for their special benefit, I say. I will produce another charge against this non-existential interpretation. It actually invalidates the ordinary process of conversion, as applied to proposition in I. Every logician, Aldrichian or otherwise, accepts it as an established fact that some x or y may be legitimately converted into some y or x. But is it equally clear that the proposition if there were any x, some of them would be y may be legitimately converted into if there were any y, some of them would be x?
I trow not. The example I have already used, of a boys' school PG 171 with a non-existent first class, will serve admirably to illustrate this new flaw in the theory of the logicians. Let us suppose that there is yet another rule in this school, viz. In each class, at the end of the term, the head boy and the second boy shall receive prizes. This rule entirely authorizes us to assert, in the sense in which the logicians would use the words, some boys in the first class will receive prizes, for this simply means, according to them, if there were any boys in the first class, some of them would receive prizes. Now the converse of this proposition is, of course, some boys, who will receive prizes, are in the first class, which means, according to the logicians, if there were any boys about to receive prizes, some of them would be in the first class, which class we know to be empty. Of this pair of converse propositions, the first is undoubtedly true, the second, as undoubtedly, false. It is always sad to see a batsman knock down his own wicket. One pities him, as a man and a brother, but, as a cricketer, one can but pronounce him out. We see, then, that, among all the conceivable views we have here considered, there are only two which can logically be held, viz. I and A assert, but E does not. E and A assert, but I does not. The second of these I have shown to involve great practical inconvenience. The first is the one adopted in this book. CP 19. Some further remarks on this subject will be found in Note B, at p. 196. 3. The use of is not, or are not, as a copula. Is it better to say John is not in the house or John is not in the house? Some of my acquaintances are not men I should like to be seen with, or some of my acquaintances are men I should not like to be seen with. That is the sort of question we have now to discuss. PG 172. This is no question of logical right and wrong, it is merely a matter of taste, since the two forms mean exactly the same thing. And here, again, the logicians seem to me to take much too humble a position. When they are putting the final touches to the grouping of their proposition, just before the curtain goes up, and when the copula, always a rather fussy heavy father, asks them, am I to have the not, or will you tack it on to the predicate, they are much too ready to answer, like the subtle cab driver, leave it to you, sir. The result seems to be, that the grasping copula constantly gets a not that had better have been merged in the predicate, and that propositions are differentiated which had better have been recognized as precisely similar. Surely it is simpler to treat some men are Jews and some men are Gentiles as being both of them affirmative propositions, instead of translating the latter into some men are not Jews, and regarding it as a negative propositions. The fact is, the logicians have somehow acquired a perfectly morbid dread of negative attributes, which makes them shut their eyes, like frightened children, when they come across such terrible propositions as all not X are Y, and thus they exclude from their system many very useful forms of syllogisms. Under the influence of this unreasoning terror, they plead that, in dichotomy by contradiction,
the negative part is too large to deal with, so that it is better to regard each thing as either included in, or excluded from, the positive part. I see no force in this plea, and the facts often go the other way. As a personal question, dear reader, if you were to group your acquaintances into the two classes, men that you would like to be seen with, and men that you would not like to be seen with, do you think the latter group would be so very much the larger of the two? For the purposes of symbolic logic, it is so much the most convenient plan to regard the two subdivisions, produced by dichotomy, on the same footing, and to say, of anything, either that it is in the one, or that it is in the other, that I do not think any reader of this book is likely to demur to my adopting that course. pg 1734. The theory that two negative premises prove nothing. This I consider to be another craze of the logicians, fully as morbid as their dread of a negative attribute. It is, perhaps, best refuted by the method of instantia contraria. Take the following pairs of premises: none of my boys are conceited, none of my girls are greedy. None of my boys are clever, none but a clever boy could solve this problem. None of my boys are learned, some of my boys are not choristers. This last proposition is, in my system, an affirmative one, since I should read it are not choristers, but, in dealing with the logicians I may fairly treat it as a negative one, since they would read it are not choristers. If you, dear reader, declare, after full consideration of these pairs of premises, that you cannot deduce a conclusion from any of them, why, all I can say is that, like the Duke in Patience, you will have to be contented with our heartfelt sympathy. See note, c. p. 196.5. Euler's method of diagrams. Diagrams seem to have been used, at first, to represent propositions only. In Euler's well-known circles, each was supposed to contain a class, and the diagram consisted of two circles, which exhibited the relations, as to inclusion and exclusion, existing between the two classes. Diagram of circle X inside circle Y. Thus, the diagram, here given, exhibits the two classes, whose respective attributes are X and Y, as so related to each other that the following propositions are all simultaneously true: all X are Y, no X are not Y, some X are Y, some Y are not X, some not Y are not X, and, of course, the converses of the last four. pg 174. Diagram of circle Y inside circle X. Similarly, with this diagram, the following propositions are true: all Y are X, no Y are not X, some Y are X, some X are not Y, some not X are not Y, and, of course, the converses of the last four. Diagram of two separate circles X and Y. Similarly, with this diagram, the following are true: all X are not Y, all Y are not X, no X are Y, some X are not Y, some Y are not X, some not X are not Y, and the converses of the last four. Diagram of two intersecting circles X and Y. Similarly, with this diagram, the following are true: some X are Y, some X are not Y, some not X are Y, some not X are not Y, and of course, their four converses. Note that all Euler's diagrams assert some not x are not y. Apparently it never occurred to him that it might sometimes fail to be true. Now, to represent all x are y, the first of these diagrams would suffice. Similarly, to represent no x are y, the third would suffice. But to represent any particular proposition, at least 3 diagrams would be needed, in order to include all the possible cases, and, for some not x are not y, all the 4. 6. Venne's method of diagrams. Let us represent not x by x. Mr. Venne's method of diagrams is a great advance on the above method. He uses the last of the above diagrams to represent any desired relation between x and y, by simply shading a compartment known to be empty, and placing a and in one known to be occupied. Thus, he would represent the 3 propositions some x are y, no x are y, and all x are y, as follows. Venn diagram representing xy exists. Venn diagram representing xy does not exist. Venn diagram representing all x are y. pg 175. It will be seen that, of the 4 classes, whose peculiar sets of attributes are xy, 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 and xy, only 3 are here provided with closed compartments, while the 4th is allowed the rest of the infinite plane to range about in. This arrangement would involve us in very serious trouble, if we ever attempted to represent no x r y. Mr. Venn once, at p. 281, encounters this awful task, but evades it, in a quite masterly fashion, by the simple footnote we have not troubled to shade the outside of this diagram. To represent 2 propositions, containing a common term, together, a 3-letter diagram is needed. This is the one used by Mr. Venn. Venn diagram of 3 intersecting circles x, y and z. Here, again, we have only 7 closed compartments, to accommodate the 8 classes whose peculiar sets of attributes are xym, xym, and c with 4 terms in request. Mr. Venn says, the most simple and symmetrical diagram seems to me that produced by making 4 ellipses intersect one another in the desired manner. This, however, provides only 15 closed compartments. Venn diagram of 4 intersecting ellipses A, B, C and D for 5 letters. The simplest diagram I can suggest, Mr. Venn says, is one like this. The small ellipse in the center is to be regarded as a portion of the outside of C, i.e. its 4 component portions are inside B and D but are no part of C. It must be admitted that such a diagram is not quite so simple to draw as one might wish it to be, but then consider what the alternative is if one undertakes to deal with 5 terms and all their combinations, nothing short of the disagreeable task of writing out, or in some way putting before us, all the 32 combinations involved. Venn diagram of 5 intersecting ellipses A, B, C, D and E and an interior ellipse PG 176. This diagram gives us 31 closed compartments. For 6 letters, Mr. Venn suggests that we might use 2 diagrams, like the above, one for the F part, and the other for the not F part, of all the other combinations. This, he says, would give the desired 64 subdivisions. This, however, would only give 62 closed compartments, and one infinite area, which the two classes, ABCDEF and ABCDEF, would have to share between them. Beyond 6 letters Mr. Venn does not go. 7. My method of diagrams. My method of diagrams resembles Mr. Venn's, in having separate compartments assigned to the various classes, and in marking these compartments as occupied or as empty, but it differs from his method, in assigning a closed area to the universe of discourse, so that the class which, under Mr. Venn's liberal sway, has been ranging at will through infinite space, is suddenly dismayed to find itself cabined, cribbed, confined, in a limited cell like any other class. Also I use rectilinear, instead of curvilinear, figures, and I mark an occupied cell with a I, meaning that there is at least one thing in it, and an empty cell with a O, meaning that there is no thing in it. For 2 letters, I use this diagram, in which the north half is assigned to X, the south to not X, or X, the west to Y, and the east to Y. Thus the NW cell contains the XY class, the NE cell the XY class, and so on. Empty biliteral diagram for 3 letters, I subdivide these 4 cells, by drawing an inner square, which I assign to M, the outer border being assigned to M. I thus get 8 cells that are needed to accommodate the 8 classes, whose peculiar sets of attributes are XYM, XYM, and C. Empty triliteral diagram. This last diagram is the most complex that I use in the elementary part of my symbolic logic. But I may as well take this opportunity of describing the more complex ones which will appear in Part 2. PG 177 for 4 letters, which I call A, B, C, D. I use this diagram, assigning the north half to A, and of course the rest of the diagram to A, the west half to B, the horizontal oblong to C, and the upright oblong to D. We have now got 16 cells. Empty quadrilateral diagram for 5 letters, adding E. I subdivide the 16 cells of the previous diagram by oblique partitions, assigning all the upper portions to E, and all the lower portions to E. Here, I admit, we lose the advantage of having the E class altogether, in a ring fence, like the other 4 classes. Still, it is very easy to find, and the operation of erasing it is nearly as easy as that of erasing any other class. We have now got 32 cells. Empty pentalateral diagram for 6 letters, adding H. As I avoid tailed letters, I substitute upright crosses for the oblique partitions, assigning the 4 portions, into which each of the 16 cells is thus divided, to the 4 classes A, EH, EH. We have now got 64 cells. Empty hexalateral diagram PG 178 for 7 letters, adding K, I add, to each upright cross, a little inner square. All these 16 little squares are assigned to the K class, and all outside them to the K class, so that 8 little cells, into which each of the 16 cells is divided, are respectively assigned to the 8 classes EK, and C. We have now got 128 cells. Empty heptalateral diagram for 8 letters, adding L, I place, in each of the 16 cells, a lattice, which is a reduced copy of the whole diagram, and, just as the 16 large cells of the whole diagram are assigned to the 16 classes apt, and C, so the 16 little cells of each lattice are assigned to the 16 classes ekel, and C. Thus, the lattice in the NW corner serves to accommodate the 16 classes ABCD ekel, ABCD AKL, and C. This octoliteral diagram, see next page, contains 256 cells. For 9 letters, I place 2 octoliteral diagrams side by side, assigning one of them to M, and the other to M. We have now got 512 cells. PG179 empty octoliteral diagram. Finally, for 10 letters, I arrange 4 octoliteral diagrams, like the above, in a square, assigning them to the 4 classes MN, 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 MN. We have now got 1024 cells. 8. Solution of a syllogism by various methods. The best way, I think, to exhibit the differences between these various methods of solving syllogisms, will be to take a concrete example, and solve it by each method in turn. Let us take, as our example, number 29, CP 102. No philosophers are conceited, some conceited persons are not gamblers. Therefore some persons, who are not gamblers, are not philosophers. PG 180, 1. Solution by ordinary method. These premises, as they stand, will give no conclusion, as they are both negative. If by permutation or obversion, we write the minor premise thus, some conceited persons are not gamblers, we can get a conclusion in physician, viz. No philosophers are conceited, some conceited persons are not gamblers. Therefore some not gamblers are not philosophers. This can be proved by reduction to theorio, thus, no conceited persons are philosophers, some not gamblers are conceited. Therefore some not gamblers are not philosophers. The validity of theorio follows directly from the axiom de omni it nullo. 2. Symbolic representation. Before proceeding to discuss other methods of solution, it is necessary to translate our syllogism into an abstract form. Let us take persons as our universe of discourse, and let X equals philosophers, M equals conceited, and Y equals gamblers. Then the syllogism may be written thus: no X are M, some M are Y. Therefore some Y are X. 3. Solution by Euler's method of diagrams. The major premise requires only one diagram, viz. One diagram representing XM does not exist. PG 181. The minor requires 3, viz. 2 diagram representing ym does not exist. 3 diagram representing ym exists. 4 diagram representing all yrm. The combination of major and minor, in every possible way, requires 9, viz. Figs. 1 and 2 give 5 diagram representing no xy or xm or ym exist. 6 diagram representing xm and ym do not exist and xy exists. 7 diagram representing x and y are identical and xm does not exist. 8 diagram representing xm does not exist and all y are x. 9 diagram representing ym does not exist and all x are y. Figs 1 and 3 give 10 diagram representing no xy or xm exist and ym exists. 11 diagram representing no xrm and xy and ym exist. 12 diagram representing all x are y and ym exists and xm does not exist. Figs 1 and 4 give 13 diagram representing no x are y and all m are y. From this group, Figs 5 to 13, we have, by disregarding m, to find the relation of x and y. On examination we find that Figs 5, 10, 13 express the relation of entire mutual exclusion, that Figs 6, 11 express partial inclusion and partial exclusion, that Fig 7 expresses coincidence, that Figs 8, 12 express entire inclusion of x in y, and that Fig 9 expresses entire inclusion of y in x. Pg 182. We thus get 5 bilateral diagrams for x and y, viz. 14 diagram representing xy does not exist. 15 diagram representing xy exists. 16 diagram representing x and y are identical. 17 diagram representing all x are y. 18 diagram representing all y are x, where the only proposition represented by them all is some not y are not x, i.e. some persons who are not gamblers, are not philosophers, a result which Euler would hardly have regarded as a valuable one, since he seems to have assumed that a proposition of this form is always true. 4. Solution by Ven's method of diagrams. The following solution has been kindly supplied to me Mr. Venn himself. The minor premise declares that some of the constituents in my must be saved. Mark these constituents with a cross. Venn diagram of 3 intersecting circles. The major declares that all xm must be destroyed, erase it. Then, as some my is to be saved, it must clearly be my x. That is, there must exist my x, or eliminating m, yx. In common phraseology, some y are x or, some not gamblers are not philosophers. Pg 183, 5. Solution by my method of diagrams. The first premise asserts that no xm exist, so we mark the xm compartment as empty, by placing AO in each of its cells. The second asserts that some my exist, so we mark the my compartment as occupied, by placing a I in its only available cell. Diagram representing xm does not exist and y'm exists. The only information that this gives us as to x and y is that the xy compartment is occupied, i.e. that some xy exist. Hence some x are y, i.e. some persons, who are not philosophers, are not gamblers. 6. Solution by my method of subscripts. xm0 my 1 xy1, i.e. some persons, who are not philosophers, are not gamblers. 9. My method of treating syllogisms and srites. Of all the strange things that are to be met with in the ordinary textbooks of formal logic. Perhaps the strangest is the violent contrast one finds to exist between their ways of dealing with these two subjects. While they have elaborately discussed no less than 19 different forms of syllogisms, each with its own special and exasperating rules, while the whole constitute an almost useless machine, for practical purposes, many of the conclusions being incomplete, and many quite legitimate forms being ignored, they have limited rights to two forms only, of childish simplicity, and these they have dignified with special names, apparently under the impression that no other possible forms existed. As to syllogisms, I find that their 19 forms, with about a score of others which they have ignored, can all be arranged under 3 forms, each with a very simple rule of its own, and the only question the reader has to settle, in working any one of the 101 examples given at p. 101 of this book, is does it belong to Fig. I, 2, or 3. pg 184 as to Srites. The only 2 forms, recognized by the textbooks, are the Aristotelian, whose premises are a series of propositions in a, so arranged that the predicate of each is the subject of the next, and the Goclenian, whose premises are the very same series, written backwards. Goclenius, it seems, was the first who noticed the startling fact that it does not affect the force of a syllogism to invert the order of its premises, and who applied this discovery to us rights. If we assume, as surely we may, that he is the same man as that transcendent genius who first noticed that 4 times 5 is the same thing as 5 times 4, we may apply to him what somebody, Edmund Yates, I think it was, has said of Tupper, viz., here is a man who, beyond all others of his generation, has been favored with glimpses of the obvious. These puerile, not to say infantine, forms of us rights I have, in this book, ignored from the very first, and have not only admitted freely propositions in E, but have purposely stated the premises in random order, leaving to the reader the useful task of arranging them, for himself, in an order which can be worked as a series of regular syllogisms. In doing this, he can begin with any one of them he likes. I have tabulated, for curiosity, the various orders in which the premises of the Aristotelians rights 1. All A are B, 2. All B are C, 3. All C are D, 4. All D are E, 5. All E are H, therefore all A are H may be syllogistically arranged, and I find there are no less than 16 such orders, viz. 12,345, 21,345, 23,145, 23,415, 23,451, 32,145, 32,415, 32,451, 34,215, 34,251, 34,521, 43,215, 43,251, 43,521, 45,321, 54,321. Of these the first and the last have been dignified with names, but the other 14, first enumerated by an obscure writer on logic, towards the end of the 19th century, remain without a name. pg 18510. Some account of parts 2, 3. In part 2 will be found some of the matters mentioned in this appendix, viz., the existential import of propositions, the use of a negative copula, and the theory that two negative premises prove nothing. I shall also extend the range of syllogisms, by introducing propositions containing alternatives, such as not all x are y, propositions containing three or more terms, such as all a b are c, which, taken along with some b c are d, would prove some d are a, and c. I shall also discuss rights containing entities, and the very puzzling subjects of hypotheticals and dilemmas. I hope, in the course of Part 2, to go over all the ground usually traversed in the textbooks used in our schools and universities, and to enable my readers to solve problems of the same kind as, and far harder than, those that are at present set in their examinations. In Part 3, I hope to deal with many curious and out-of-the-way subjects, some of which are not even alluded to in any of the treatises I have met with. In this part will be found such matters as the analysis of propositions into their elements. Let the reader, who has never gone into this branch of the subject, try to make out for himself what additional proposition would be needed to convert summa RB into summa RBC, the treatment of numerical and geometrical problems, the construction of problems, and the solution of syllogisms and rights containing propositions more complex than any that I have used in Part 2. I will conclude with 8 problems, as a taste of what is coming in Part 2. I shall be very glad to receive, from any reader, who thinks he has solved any one of them, more especially if he has done so without using any method of symbols, what he conceives to be its complete conclusion. It may be well to explain what I mean by the complete conclusion of a syllogism or a rights. I distinguish their terms as being of 2 kinds. Those which can be eliminated pg 186, for example the middle term of a syllogism, which I call the eliminans, and those which cannot, which I call the retinans, and I do not call the conclusion complete, unless it states all the relations among the retinans only, which can be deduced from the premises. 1. All the boys, in a certain school, sit together in one large room every evening. They are of no less than 5 nationalities: English, Scotch, Welsh, Irish, and German. One of the monitors, who is a great reader of Wilkie Collins novels, is very observant, and takes MS notes of almost everything that happens, with the view of being a good sensational witness, in case any conspiracy to commit a murder should be on foot. The following are some of his notes. 1. Whenever some of the English boys are singing Rule Britannia, and some not, some of the monitors are wide awake. 2. Whenever some of the Scotch are dancing reels, and some of the Irish fighting, some of the Welsh are eating toasted cheese. 3. Whenever all the Germans are playing chess, some of the 11 are not oiling their bats. 4. Whenever some of the monitors are asleep, and some not. Some of the Irish are fighting. 5. Whenever some of the Germans are playing chess, and none of the Scotch are dancing reels. Some of the Welsh are not eating toasted cheese. 6. Whenever some of the Scotch are not dancing reels, and some of the Irish not fighting, some of the Germans are playing chess. 7. Whenever some of the monitors are awake, and some of the Welsh are eating toasted cheese, none of the Scotch are dancing reels. 8. Whenever some of the Germans are not playing chess, and some of the Welsh are not eating toasted cheese, none of the Irish are fighting. PG 187. 9. Whenever all the English are singing Rule Britannia and some of the Scotch are not dancing reels, none of the Germans are playing chess. 10. Whenever some of the English are singing Rule Britannia, and some of the monitors are asleep, some of the Irish are not fighting. 11. Whenever some of the monitors are awake, and some of the 11 are not oiling their bats, some of the Scotch are dancing reels. 12. Whenever some of the English are singing Rule Britannia, and some of the Scotch are not dancing reels. Asterisk 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 asterisk. Here the MS breaks off suddenly. The problem is to complete the sentence, if possible. NB. In solving this problem, it is necessary to remember that the proposition all x are y is a double proposition, and is equivalent to some x are y, and none are y. CP 17.2. 1. A logician, who eats pork chops for supper, will probably lose money. 2. A gambler, whose appetite is not ravenous, will probably lose money. 3. A man who is depressed, having lost money and being likely to lose more, always rises at 5 a.m. 4. A man, who neither gambles nor eats pork chops for supper, is sure to have a ravenous appetite. 5. A lively man, who goes to bed before 4 a.m., had better take to cab driving. 6. A man with a ravenous appetite, who has not lost money and does not rise at 5 a.m., always eats pork chops for supper. 7. A logician, who is in danger of losing money, had better take to cab driving. 8. An earnest gambler, who is depressed though he has not lost money, is in no danger of losing any. 9. A man, who does not gamble, and whose appetite is not ravenous, is always lively. PG 188. 10. A lively logician, who is really in earnest, is in no danger of losing money. 11. A man with a ravenous appetite has no need to take to cab driving, if he is really in earnest. 12. A gambler, who is depressed though in no danger of losing money, sits up till 4 a.m. 13. A man, who has lost money and does not eat pork chops for supper, had better take to cab driving, unless he gets up at 5 a.m. 14. A gambler, who goes to bed before 4 a.m., need not take to cab driving, unless he has a ravenous appetite. 15. A man with a ravenous appetite, who is depressed though in no danger of losing, is a gambler. Univ. Men. A equals earnest, B equals eating pork chops for supper, C equals gamblers, D equals getting up at 5, E equals having lost money, H equals having a ravenous appetite, K equals likely to lose money, L equals lively, M equals logicians, N equals men who had better take to cab driving, R equals sitting up till 4. NB. In this problem, clauses, beginning with though, are intended to be treated as essential parts of the propositions in which they occur, just as if they had begun with and. 3. 1. When the day is fine, I tell Froggy you're quite the dandy, old chap. 2. Whenever I let Froggy forget that £10 he owes me, and he begins to strut about like a peacock, his mother declares he shall not go out a-wooing. 3. Now that Froggy's hair is out of curl, he has put away his gorgeous waistcoat. 4. Whenever I go out on the roof to enjoy a quiet cigar, I'm sure to discover that my purse is empty. 5. When my tailor calls with his little bill, and I remind Froggy of that £10 he owes me, he does not grin like a high-earner. PG 189. 6. When it is very hot, the thermometer is high. 7. When the day is fine, and I'm not in the humor for a cigar, and Froggy is grinning like a high-earner, I never venture to hint that he's quite the dandy. 8. When my tailor calls with his little bill and finds me with an empty purse, I remind Froggy of that £10 he owes me. 9. My railway shares are going up like anything. 10. When my purse is empty, and when, noticing that Froggy has got his gorgeous waistcoat on, I venture to remind him of that £10 he owes me, things are apt to get rather warm. 11. Now that it looks like rain, and Froggy is grinning like a high-earner, I can do without my cigar. 12. When the thermometer is high, you need not trouble yourself to take an umbrella. 13. When Froggy has his gorgeous waistcoat on, but is not strutting about like a peacock, I betake myself to a quiet cigar. 14. When I tell Froggy that he's quite the dandy, he grins like a high-earner. 15. When my purse is tolerably full, and Froggy's hair is one mass of curls, and when he is not strutting about like a peacock, I go out on the roof. 16. When my railway shares are going up, and when it is chilly and looks like rain, I have a quiet cigar. 17. When Froggy's mother lets him go a-wooing, he seems nearly mad with joy, and puts on a waistcoat that is gorgeous beyond words. 18. When it is going to rain, and I am having a quiet cigar, and Froggy is not intending to go a-wooing, you had better take an umbrella. 19. When my railway shares are going up, and Froggy seems nearly mad with joy, that is the time my tailor always chooses for calling with his little bill. 20. When the day is cool and the thermometer low, and I say nothing to Froggy about his being quite the dandy, and there's not the ghost of a grin on his face, I haven't the heart for my cigar. PG 1904. 1. Anyone, fit to be an MP, who is not always speaking, is a public benefactor. 2. Clear-headed people, who express themselves well, have had a good education. 3. A woman, who deserves praise, is one who can keep a secret. 4. People, who benefit the public, but do not use their influence for good purpose, are not fit to go into Parliament. 5. People, who are worth their weight in gold and who deserve praise, are always unassuming. 6. Public benefactors, who use their influence for good objects, deserve praise. 7. People, who are unpopular and not worth their weight in gold, never can keep a secret. 8. People, who can talk forever and are fit to be members of Parliament, deserve praise. 9. Anyone, who can keep a secret and who is unassuming, is a never-to-be-forgotten public benefactor. 10. A woman, who benefits the public, is always popular. 11. People, who are worth their weight in gold, who never leave off talking, and whom it is impossible to forget, are just the people whose photographs are in all the shop windows. 12. An ill-educated woman, who is not clear-headed, is not fit to go into Parliament. 13. Anyone, who can keep a secret and is not forever talking, is sure to be unpopular. 14. A clear-headed person, who has influence and uses it for good objects, is a public benefactor. 15. A public benefactor, who is unassuming, is not the sort of person whose photograph is in every shop window. 16. People, who can keep a secret and who use their influence for good purposes, are worth their weight in gold. 17. A person, who has no power of expression and who cannot influence others, is certainly not a woman. PG 191. 18. People, who are popular and worthy of praise, either are public benefactors or else are unassuming. Univ. Persons, A equals able to keep a secret, B equals clear-headed, C equals constantly talking, D equals deserving praise, E equals exhibited in shop windows, H equals expressing oneself well, K equals fit to be an MP, L equals influential, M equals never to be forgotten, N equals popular, R equals public benefactors, S equals unassuming, T equals using one's influence for good objects, V equals well-educated, W equals women, Z equals worth one's weight in gold. 5. 6 friends, and their 6 wives, are staying in the same hotel, and they all walk out daily, in parties of various size and composition. To ensure variety in these daily walks, they have agreed to observe the following rules. 1. If Akers is with, i.e. is in the same party with, his wife, and Barry with his, and Eden with Mrs. Hall, Cole must be with Mrs. Dix. 2. If Akers is with his wife, and Hall with his, and Barry with Mrs. Cole, Dix must not be with Mrs. Eden. 3. If Cole and Dix and their wives are all in the same party, and Akers not with Mrs. Barry, Eden must not be with Mrs. Hall. 4. If Akers is with his wife, and Dix with his, and Barry not with Mrs. Cole, Eden must be with Mrs. Hall. 5. If Eden is with his wife, and Hall with his, and Cole with Mrs. Dix, Akers must not be with Mrs. Barry. 6. If Barry and Cole and their wives are all in the same party, and Eden not with Mrs. Hall, Dix must be with Mrs. Eden. The problem is to prove that there must be, every day, at least one married couple who are not in the same party. PG 1926. After the 6 friends, named in Problem 5, had returned from their tour, 3 of them, Barry, Cole, and Dix, agreed, with 2 other friends of theirs, Lang and Mill, that the 5 should meet, every day, at a certain table d'hôte. Remembering how much amusement they had derived from their code of rules for walking parties, they devised the following rules to be observed whenever beef appeared on the table. 1. If Barry takes salt, then either Cole or Lang takes one only of the 2 condiments, salt and mustard. If he takes mustard, then either Dix takes neither condiment, or Mill takes both. 2. If Cole takes salt, then either Barry takes only one condiment, or Mill takes neither. If he takes mustard, then either Dix or Lang takes both. 3. If Dix takes salt, then either Barry takes neither condiment or Cole take both. If he takes mustard, then either Lang or Mill takes neither. 4. If Lang takes salt, then Barry or Dix takes only one condiment. If he takes mustard, then either Cole or Mill takes neither. 5. If Mill takes salt, then either Barry or Lang takes both condiments. If he takes mustard, then either Cole or Dix takes only one. The problem is to discover whether these rules are compatible, and, if so, what arrangements are possible. NB. In this problem, it is assumed that the phrase "if Barry takes salt" allows of two possible cases, viz. 1. He takes salt only, 2. He takes both condiments. And so with all similar phrases. It is also assumed that the phrase "either Cole or Lang takes one only of the two condiments" allows three possible cases, viz. 1. Cole takes one only, Lang takes both or neither. 2. Cole takes both or neither, Lang takes one only. 3. Cole takes one only, Lang takes one only. And so with all similar phrases. It is also assumed that every rule is to be understood as implying the words and vice versa. Thus the first rule would imply the addition "and", if either Cole or Lang takes only one condiment, then Barry takes salt, pg 1937. 1. Brothers, who are much admired, are apt to be self-conscious. 2. When two men of the same height are on opposite sides in politics, if one of them has his admirers, so also has the other. 3. Brothers, who avoid general society, look well when walking together. 4. Whenever you find two men, who differ in politics and in their views of society, and who are not both of them ugly, you may be sure that they look well when walking together. 5. Ugly men, who look well when walking together, are not both of them free from self-consciousness. 6. Brothers, who differs in politics, and are not both of them handsome, never give themselves airs. 7. John declines to go into society, but never gives himself airs. 8. Brothers, who are apt to be self-conscious, though not both of them handsome, usually dislike society. 9. Men of the same height, who do not give themselves airs, are free from self-consciousness. 10. Men, who agree on questions of art, though they differ in politics, and who are not both of them ugly, are always admired. 11. Men, who hold opposite views about art and are not admired, always give themselves airs. 12. Brothers of the same height always differ in politics. 13. Two handsome men, who are neither both of them admired nor both of them self-conscious, are no doubt of different heights. 14. Brothers, who are self-conscious, and do not both of them like society, never look well when walking together. NB. See note at end of problem 2. pg 1948. 1. A man can always master his father. 2. An inferior of a man's uncle owes that man money. 3. The father of an enemy of a friend of a man owes that man nothing. 4. A man is always persecuted by his son's creditors. 5. An inferior of the master of a man's son is senior to that man. 6. A grandson of a man's junior is not his nephew. 7. A servant of an inferior of a friend of a man's enemy is never persecuted by that man. 8. A friend of a superior of the master of a man's victim is that man's enemy. 9. An enemy of a persecutor of a servant of a man's father is that man's friend. The problem is to deduce some fact about great-grandsons. NB. In this problem, it is assumed that all the men, here referred to, live in the same town, and that every pair of them are either friends or enemies, that every pair are related as senior and junior, superior and inferior, and that certain pairs are related as creditor and debtor, father and son, master and servant, persecutor and victim, uncle and nephew. 9. Jack Sprat could eat no fat, his wife could eat no lean, and so, between them both, they licked the platter clean. Solve this as a Srites problem, taking lines 3 and 4 as the conclusion to be proved. It is permitted to use, as premises, not only all that is here asserted, but also all that we may reasonably understand to be implied. PG 195 Notes to Appendix A. CP 167, line 6. It may, perhaps, occur to the reader, who has studied formal logic, that the argument, here applied to the propositions I and E, will apply equally well to the propositions I and O, since, in the ordinary textbooks, the propositions all x, y are z and some x, y are not z are regarded as contradictories. Hence it may appear to him that the argument might have been put as follows: we now have I and A asserting. Hence, if the proposition all x, y are z be true, some things exist with the attributes x and y, i.e. some x are y. Also we know that, if the proposition some x, y are not z be true, the same result follows. But these two propositions are contradictories, so that one or other of them must be true. Hence this result is always true, i.e. the proposition some x are y is always true. Quod est absurdum. Hence I cannot assert. This matter will be discussed in Part 2, but I may as well give here what seems to me to be an irresistible proof that this view, that A and I are contradictories, though adopted in the ordinary textbooks, is untenable. The proof is as follows: with regard to the relationship existing between the class X, Y and the two classes Z and not Z, there are four conceivable states of things, viz. 1. Some Z are Z and some I are not Z. 2. None. 3. No X, Y some. 4. None of these four, no. 2. Is equivalent to all X, Y are Z, no. 3. Is equivalent to all X, Y are not Z, and no. 4. Is equivalent to no X, Y exist. Now it is quite undeniable that, of these four states of things, each is, a priori, possible, some one must be true, and the other three must be false. Hence the contradictory to 2 is either 1, or 3, or 4, is true. Now the assertion either 1, or 3, is true is equivalent to some X, Y are not Z, and the assertion 4, is true is equivalent to no x, y exist. Hence the contradictory to all x, y or z may be expressed as the alternative proposition either some x, y are not z, or no x, y exist but not as the categorical proposition some y are not z. Pg 196, b. cp 171, at end of section 2. There are yet other views current among the logicians, as to the existential import of propositions, which have not been mentioned in this section. One is, that the proposition some x or y is to be interpreted, neither as some x exist and are y, nor yet as if there were any x in existence, some of them would be y, but merely as some x can be y, i.e. the attributes x and y are compatible. On this theory, there would be nothing offensive in my telling my friend Jones some of your brothers are swindlers, since, if he indignantly retorted, "What do you mean by such insulting language, you scoundrel?" I should calmly reply, "I merely mean that the thing is conceivable, that some of your brothers might possibly be swindlers." But it may well be doubted whether such an explanation would entirely appease the wrath of Jones. Another view is, that the proposition all x are y sometimes implies the actual existence of x, and sometimes does not imply it, and that we cannot tell, without having it in concrete form, which interpretation we are to give to it. This view is, I think, strongly supported by common usage, and it will be fully discussed in Part 2, but the difficulties, which it introduces, seem to me too formidable to be even alluded to in Part I, which I am trying to make, as far as possible, easily intelligible to mere beginners. C. CP 173, 4. The three conclusions are: no conceited child of mine is greedy, none of my boys could solve this problem, some unlearned boys are not choristers. PG 197 Index 1. Tables. Bilateral diagram. Attributes of classes, and compartments, or cells, assigned to them 25.2.do. Representation of unilateral propositions of existence 34.3.do. Representation of bilateral propositions of existence and of relation 35.4. Trilateral diagram. Attributes of classes, and compartments, or cells, assigned to them 42v.do. Representation of particular and universal negative propositions, of existence and of relation, in terms of x and m46.6.do. Do, in terms of y and m47.7.do. Representation of universal affirmative propositions of relation, in terms of x and m48.8.do. Do. In terms of y and m49.9. Method of subscripts. Formulae and rules for syllogisms 78.2. Words and see explained. Abstract proposition 59. Adjuncts 1. Affirmative proposition 10. Attributes 1. Bilateral diagram 22. Bilateral proposition 27. Class 1.5 classes, arbitrary limits of 3.5 classes, Subdivision of 4 PG198 Classification 1.5 Codivisional Classes 3 Complete Conclusion of Us Rights 85 Conclusion of Us Rights Conclusion of a Syllogism 56 Concrete Proposition 59 Consequent in Us Rights 85 Consequent in a Syllogism 56 Converse Propositions 31 Conversion of a Proposition Copula of a proposition 9 Definition 6 Dichotomy 3.5 Differentia 1.5 Division 3 Eliminans of Us Rights 85 Eliminans of a Syllogism 56 Entity 70 Equivalent Propositions 17 Fallacy 81 Genus 1.5 Imaginary Class Imaginary Name 4.5 Individual 2 Like, and unlike Signs of terms 70 Name 4 Negative proposition 10 Normal form of a proposition 9 Normal form of a proposition of existence 11 Normal form of a proposition of relation 12 Nullity 70 Partial Conclusion of Us Rights 85 Particular Proposition 9 Peculiar Attributes 1.5 Predicate of a Proposition 9 Predicate of a Proposition of Existence 11 Predicate of a Proposition of Relation 12 Premises of Us Rights 85 Premises of a Syllogism 56 PG 199 Proposition 8 Proposition in I, in E and in a 9 proposition in terms of certain letters 27 proposition of existence 11 proposition of relation 12 real class 1.5 retinence of Us Rights 85 retinence of a syllogism 56 Sign of quantity in a proposition 9 Sitting on the fence 26 Some Technical meaning of 8 rights 85 Species 1.5 Subject of a proposition 9 Subject of a proposition of existence 11 Subject of a proposition of relation 12 Subscripts of terms 70 Syllogism 56 Symbol Therefore symbol and 70 Terms of a proposition 9 Things 1 Translation of proposition from concrete to abstract 59 Translation of proposition from abstract to subscript 72 Triliteral diagram 39 Underscoring of letters 91 Unilateral proposition 27 Universal proposition 10 Universe of discourse, or univ 12 Unreal class 1.5 Unreal name 4.5 PG 200 The End PX_1 Works by Lewis Carroll. Published by Macmillan & Co., Limited, London. Alice's Adventures in Wonderland. With 42 illustrations by Tenniel. First published in 1865. CR8 Vo, cloth, gilt edges, price 6s. Net. 86,000. The same, People's Edition. First published in 1887. CR8 Vo, cloth, price 2s. 6d net. 48,000. Aventures d'Alice aux Pays des Merveilles. Traduit de l'anglais par Henry Bouet. Ouvrage illustré de 42 vignettes par John Tenniel. First published in 1869. CR8 Vo, cloth, gilt edges, price 6s. Net. 2,000. Alice's Abentur im Wunderland. AUSDEM Englischen von Antoni Zimmermann. MIT 42 Illustrationen von John Tenniel. First published in 1869. Crown 8 Vo, cloth, gilt edges, price 6s. Net. La avventura di Alice nel Paese del Meraviglie. Tradotto dall'inglese the T. Pietrocola Rossetti. Con 42 Vignette di Giovanni Tenniel. First published in 1872. Crown 8vo, cloth, gilt edges, price 6s. Net. Alice's Adventures Underground. Being a facsimile of the original MS book, which was afterwards developed into Alice's Adventures in Wonderland. With 37 illustrations by the author. Begun, July 1862, finished, February 1863, first published, in facsimile, in 1886. Crown 8vo, cloth, gilt edges, price 4s. Net. 3,000. The Nursery Alice. Containing 20 colored enlargements from Tenniel's illustrations to Alice's Adventures in Wonderland. With text adapted to nursery readers. Cover designed by E. Gertrude Thompson. First published in 1890. 4-2, boards, price 1s. Net. 11,000. PX_2 Through the Looking Glass, and What Alice Found There. With 50 illustration by Tenniel. First published in 1871. CR 8vo, cloth, gilt edges, price 6s. Net. 61,000. Through the Looking Glass, and What Alice Found There, People's Edition. First published in 1887. Crown 8vo, cloth, gilt edges, price 2s. 6d net. 30,000. Alice's Adventures in Wonderland, and Through the Looking Glass, People's Editions. Both books together in one volume. First published in 1887. Crown 8vo, cloth, gilt edges, price 4s. 6d net. 12,000. The Hunting of the Snook. An Agony in 8 fits. With 9 illustrations, and 2 large gilt designs on cover, by Henry Holiday. First published in 1876. Crown 8vo, cloth, gilt edges, price 4s. 6d net. 20,000. Rhyme and Reason. With 65 illustrations by Arthur B. Frost, and 9 by Henry Holiday. First published in 1883, being a reprint, with a few additions, of the comic portion of Phantasmagoria and Other Poems published in 1869, and of The Hunting of the Snook published in 1876. Crown 8vo, cloth, gilt edges, price 4s. 6d net. 6,000. Symbolic Logic. In 3 parts, which will be issued separately, Part I. Elementary. First published in 1896. Crown 8vo, limp cloth, price 2s. Net. 2,000, 4th edition. Part 2. Advanced. In preparation. Part 3. Transcendental. N.B. An envelope, containing 2 blank diagrams, biliteral and triliteral, and 9 counters, 4 red and 5 gray, can be had for 3D, by post 4D. PX_3 A Tangled Tale. Reprinted from the monthly packet. With 6 illustrations by Arthur B. Frost. First published in 1885. Crown 8vo, cloth, gilt edges, price 4s. 6d net. 4000. Sylvie and Bruno. With 4 to 6 illustrations by Harry Furness. First published in 1889. Crown 8vo, cloth, gilt edges, price 7s. 6d net. 12,000. N.B. This book contains 395 pages, nearly as much as the 2 Alice books put together. Sylvie and Bruno concluded. With 4 to 6 illustrations by Harry Furness. First published in 1893. Crown 8vo, cloth, gilt edges, price 7s. 6d net. 3,000. N.B. This book contains 411 pages. Original games and puzzles. Crown 8vo, cloth, gilt edges. In preparation. 3 sunsets, and other poems. With 12 illustrations by E. Gertrude Thompson. FCAP. 4-2, cloth, gilt edges. N.B. This will be a reprint, possibly with a few additions, of the serious portion of Phantasmagoria, and other poems published in 1869. Advice to writers. Buy the Wonderland case for postage stamps invented by Lewis Carroll, the 29th of October, 1888, size 4 inches by 3, containing 12 separate pockets for stamps of different values. 2 colored pictorial surprises taken from Alice in Wonderland, and 8 or 9 wise words about letter writing. It is published by Messrs. Berlin and Son, 4 Magdalene Street, Oxford. Price 1s. N.B. If ordered by post, an additional payment will be required, to cover cost of postage, as follows: 1 copy, 1/2d. 2 or 3 do, 2d. 4 do, 2/2d. 5 to 14 do, 3d. Each subsequent 14 or fraction thereof, 1/2d. PX_4 transcribers note this book contains a large number of line-drawn illustrations which are UN credited. These did not reproduce well in this medium and have been redrawn electronically as close as possible to the original. A number of transcription errors were found in the original book. As these were clearly not part of the author's intention, they have, as far as possible, been identified and corrected in accordance with the methods given by the author. These corrections have also been marked with an underline as for example construct, so that the original text may be seen by hovering the mouse cursor over the corrected element. In these notes the word natural identifies a letter symbol occurring without a prime mark. In the original book at the top of page 97, the following text occurred: NB. The numbers at the foot of each page indicate the pages where the corresponding matter may be found. In accordance with the UN paged medium here, this has been changed to NB reference tags for examples. Answers and solutions will be found in the right margin. The part of the book to which this relates contains, by sections, examples, exercises for the student, answers to the examples, and solutions, worked answers. All example sections have corresponding answer sections. For sections 2 and 3, worked solutions are not supplied. For sections 4-7, solutions are given by two different methods. In association with this, the original text contained editorial notes at the foot of each page giving the page numbers for the related sections. In this version, these notes are replaced with hyperlinks. For each section, the marginal marker which is given at the top of the section identifies the current location, and by clicking on it the reader is taken on a round tour of the related sections. End of the Project Gutenberg ebook Symbolic Logic ******** Updated editions will replace the previous one. The old editions will be renamed. Creating the works from print editions not protected by U.S. copyright law means that no one owns a United States copyright in these works, so the Foundation, and you, can copy and distribute it in the United States without permission and without paying copyright royalties. Special rules, set forth in the general terms of use part of this license, apply to copying and distributing Project Gutenberg trademark symbol electronic works to protect the Project Gutenberg trademark symbol concept and trademark. Project Gutenberg is a registered trademark, and may not be used if you charge for an ebook, except by following the terms of the trademark license, including paying royalties for use of the Project Gutenberg trademark. If you do not charge anything for copies of this ebook, complying with the trademark license is very easy. You may use this ebook for nearly any purpose, such as creation of derivative works, reports, performances and research. Project Gutenberg ebooks may be modified and printed and given away. You may do practically anything in the United States with ebooks not protected by U.S. copyright law. Redistribution is subject to the trademark license, especially commercial redistribution. Start. Full license. The full Project Gutenberg license. Please read this before you distribute or use this work to protect the Project Gutenberg trademark symbol mission of promoting the free distribution of electronic works. By using or distributing this work, or any other work associated in any way with the phrase Project Gutenberg, you agree to comply with all the terms of the full Project Gutenberg trademark symbol license available with this file or online at www.gutenberg.org/license. Section 1. General Terms of Use and Redistributing Project Gutenberg Trademark Symbol Electronic Works 1.0. By reading or using any part of this Project Gutenberg trademark symbol electronic work, you indicate that you have read, understand, agree to and accept all the terms of this license and intellectual property, trademark/copyright, agreement. If you do not agree to abide by all the terms of this agreement, You must cease using and return or destroy all copies of Project Gutenberg trademark symbol electronic works in your possession. If you paid a fee for obtaining a copy of or access to a Project Gutenberg trademark symbol electronic work and you do not agree to be bound by the terms of this agreement, you may obtain a refund from the person or entity to whom you paid the fee as set forth in paragraph 1.e.8. 1.b Project Gutenberg is a registered trademark. It may only be used on or associated in any way with an electronic work by people who agree to be bound by the terms of this agreement. There are a few things that you can do with most Project Gutenberg trademark symbol electronic works even without complying with the full terms of this agreement. See paragraph 1.c below. There are a lot of things you can do with Project Gutenberg trademark symbol electronic works if you follow the terms of this agreement and help preserve free future access to Project Gutenberg trademark symbol electronic works. See paragraph 1.e below. 1.c The Project Gutenberg Literary Archive Foundation, the Foundation or PGLAF, owns a compilation copyright in the collection of Project Gutenberg trademark symbol electronic works. Nearly all the individual works in the collection are in the public domain in the United States. If an individual work is unprotected by copyright law in the United States and you are located in the United States, we do not claim a right to prevent you from copying, distributing, performing, displaying or creating derivative works based on the work as long as all references to Project Gutenberg are removed. Of course, we hope that you will support the Project Gutenberg trademark symbol mission of promoting free access to electronic works by freely sharing Project Gutenberg trademark symbol works in compliance with the terms of this agreement for keeping the Project Gutenberg trademark symbol name associated with the work. You can easily comply with the terms of this agreement by keeping this work in the same format with its attached full Project Gutenberg trademark symbol license when you share it without charge with others. 1.d The copyright laws of the place where you are located also govern what you can do with this work. Copyright laws in most countries are in a constant state of change. If you are outside the United States, check the laws of your country in addition to the terms of this agreement before downloading, copying, displaying, performing, distributing or creating derivative works based on this work or any other Project Gutenberg trademark symbol work. The Foundation makes no representations concerning the copyright status of any work in any country other than the United States. 1.e Unless you have removed all references to Project Gutenberg. 1.e.1 The following sentence, with active links to, or other immediate access to, the full Project Gutenberg trademark symbol license must appear prominently whenever any copy of a Project Gutenberg trademark symbol work, any work on which the phrase Project Gutenberg appears, or with which the phrase Project Gutenberg is associated, is accessed, displayed, performed, viewed, copied or distributed. This ebook is for the use of anyone anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. You may copy it, give it away or reuse it under the terms of the Project Gutenberg license included with this ebook or online at www.gutenberg.org. If you are not located in the United States, you will have to check the laws of the country where you are located before using this ebook. 1.e.2 If an individual Project Gutenberg trademark symbol electronic work is derived from texts not protected by U.S. copyright law, does not contain a notice indicating that it is posted with permission of the copyright holder, the work can be copied and distributed to anyone in the United States without paying any fees or charges. If you are redistributing or providing access to a work with the phrase Project Gutenberg associated with or appearing on the work, you must comply either with the requirements of paragraphs 1.e.1 through 1.e.7 or obtain permission for the use of the work and the Project Gutenberg trademark symbol trademark as set forth in paragraphs 1.e.8 or 1.e.9. 1.e.3 If an individual Project Gutenberg trademark symbol electronic work is posted with the permission of the copyright holder, your use and distribution must comply with both paragraphs 1.e.1 through 1.e.7 and any additional terms imposed by the copyright holder. Additional terms will be linked to the Project Gutenberg trademark symbol license for all works posted with the permission of the copyright holder found at the beginning of this work. 1.e.4 Do not unlink or detach or remove the full Project Gutenberg trademark symbol license terms from this work, or any files containing a part of this work or any other work associated with Project Gutenberg trademark symbol. 1.e.5 Do not copy, display, perform, distribute or redistribute this electronic work, or any part of this electronic work, without prominently displaying the sentence set forth in paragraph 1.e.1 with active links or immediate access to the full terms of the Project Gutenberg trademark symbol license. 1.e.6 You may convert to and distribute this work in any binary, compressed, marked up, non-proprietary or proprietary form, including any word processing or hypertext form. However, if you provide access to or distribute copies of a Project Gutenberg trademark symbol work in a format other than plain vanilla ASCII or other format used in the official version posted on the official Project Gutenberg trademark symbol website, www.gutenberg.org, you must, at no additional cost, fee or expense to the user, provide a copy, a means of exporting a copy, or a means of obtaining a copy upon request, of the work in its original plain vanilla ASCII or other form. Any alternate format must include the full Project Gutenberg trademark symbol license as specified in paragraph 1.e.1. 1.e.7 Do not charge a fee for access to, viewing, displaying, performing, copying or distributing any Project Gutenberg trademark symbol works unless you comply with paragraph 1.e.8 or 1.e.9. 1.e.8 You may charge a reasonable fee for copies of or providing access to or distributing Project Gutenberg trademark symbol electronic works, provided that you pay a royalty fee of 20% of the gross profits you derive from the use of Project Gutenberg trademark symbol works calculated using the method you already use to calculate your applicable taxes. The fee is owed to the owner of the Project Gutenberg trademark symbol trademark, but he has agreed to donate royalties under this paragraph to the Project Gutenberg Literary Archive Foundation. Royalty payments must be paid within 60 days following each date on which you prepare, or are legally required to prepare, your periodic tax returns. Royalty payments should be clearly marked as such and sent to the Project Gutenberg Literary Archive Foundation at the address specified in Section 4. Information about donations to the Project Gutenberg Literary Archive Foundation. You provide a full refund of any money paid by a user who notifies you in writing, or by email, within 30 days of receipt that he does not agree to the terms of the full Project Gutenberg trademark symbol license. You must require such a user to return or destroy all copies of the works possessed in a physical medium and discontinue all use of and all access to other copies of Project Gutenberg trademark symbol works. You provide, in accordance with paragraph 1.f.3, a full refund of any money paid for a work or a replacement copy, if a defect in the electronic work is discovered and reported to you within 90 days of receipt of the work. You comply with all other terms of this agreement for free distribution of Project Gutenberg trademark symbol works. 1.e.9. If you wish to charge a fee or distribute a Project Gutenberg trademark symbol electronic work or group of works on different terms than are set forth in this agreement, you must obtain permission in writing from the Project Gutenberg Literary Archive Foundation, the manager of the Project Gutenberg trademark symbol trademark. Contact the Foundation as set forth in Section 3 below. 1.f1.f.1. Project Gutenberg volunteers and employees expend considerable effort to identify, do copyright research on, transcribe and proofread works not protected by U.S. copyright law in creating the Project Gutenberg trademark symbol collection. Despite these efforts, Project Gutenberg trademark symbol electronic works, and the medium on which they may be stored, may contain defects such as, but not limited to, incomplete, inaccurate or corrupt data, transcription errors, a copyright or other intellectual property infringement, a defective or damaged disk or other medium, a computer virus, or computer codes that damage or cannot be read by your equipment. 1.f.2. Limited warranty, disclaimer of damages, except for the right of replacement or refund described in paragraph 1.f.3, the Project Gutenberg Literary Archive Foundation, the owner of the Project Gutenberg trademark symbol trademark, and any other party distributing a Project Gutenberg trademark symbol electronic work under this agreement, disclaim all liability to you for damages, costs and expenses, including legal fees. You agree that you have no remedies for negligence, strict liability, breach of warranty or breach of contract except those provided in paragraph 1.f.3. You agree that the foundation, the trademark owner, and any distributor under this agreement will not be liable to you for actual, direct, indirect, consequential, punitive or incidental damages even if you give notice of the possibility of such damage. 1.f.3. Limited right of replacement or refund. If you discover a defect in this electronic work within 90 days of receiving it, you can receive a refund of the money, if any, you paid for it by sending a written explanation to the person you received the work from. If you received the work on a physical medium, you must return the medium with your written explanation. The person or entity that provided you with the defective work may elect to provide a replacement copy in lieu of a refund. If you received the work electronically, the person or entity providing it to you may choose to give you a second opportunity to receive the work electronically in lieu of a refund. If the second copy is also defective, you may demand a refund in writing without further opportunities to fix the problem. 1.f.4. Except for the limited right of replacement or refund set forth in paragraph 1.f.3, this work is provided to you as is, with no other warranties of any kind, express or implied, including but not limited to warranties of merchantability or fitness for any purpose. 1.f.5. Some states do not allow disclaimers of certain implied warranties or the exclusion or limitation of certain types of damages. If any disclaimer or limitation set forth in this agreement violates the law of the state applicable to this agreement, the agreement shall be interpreted to make the maximum disclaimer or limitation permitted by the applicable state law. The invalidity or unenforceability of any provision of this agreement shall not void the remaining provisions. 1.f.6. Indemnity. You agree to indemnify and hold the foundation, the trademark owner, any agent or employee of the foundation, anyone providing copies of Project Gutenberg trademark symbol electronic works in accordance with this agreement, and any volunteers associated with the production, promotion and distribution of Project Gutenberg trademark symbol electronic works, harmless from all liability, costs and expenses, including legal fees, that arise directly or indirectly from any of the following which you do or cause to occur. A. Distribution of this or any Project Gutenberg trademark symbol work. B. Alteration, modification, or additions or deletions to any Project Gutenberg trademark symbol work, and c. any defect you cause. Section 2. Information about the mission of Project Gutenberg trademark symbol. Project Gutenberg trademark symbol is synonymous with the free distribution of electronic works in formats readable by the widest variety of computers, including obsolete, old, middle-aged and new computers. It exists because of the efforts of hundreds of volunteers and donations from people in all walks of life. Volunteers and financial support to provide volunteers with the assistance they need are critical to reaching Project Gutenberg trademark symbol's goals and ensuring that the Project Gutenberg trademark symbol collection will remain freely available for generations to come. In 2001, the Project Gutenberg Literary Archive Foundation was created to provide a secure and permanent future for Project Gutenberg trademark symbol and future generations. To learn more about the Project Gutenberg Literary Archive Foundation and how your efforts and donations can help, see sections 3 and 4 and the Foundation information page at www.gutenberg.org. Section 3. Information about the Project Gutenberg Literary Archive Foundation. The Project Gutenberg Literary Archive Foundation is a non-profit 501(c)(3) educational corporation organized under the laws of the state of Mississippi and granted tax-exempt status by the Internal Revenue Service. The Foundation's IN or Federal Tax Identification Number is 64-6221541. Contributions to the Project Gutenberg Literary Archive Foundation are tax-deductible to the full extent permitted by U.S. federal laws and your state's laws. The Foundation's business office is located at 809 North 1500 West, Salt Lake City, UT 84116, 801-596-1887. Email contact links and up-to-date contact information can be found at the Foundation's website and official page at www.gutenberg.org/contact section 4. Information about donations to the Project Gutenberg Literary Archive Foundation. Project Gutenberg trademark symbol depends upon and cannot survive without widespread public support and donations to carry out its mission of increasing the number of public domain and licensed works that can be freely distributed in machine-readable form accessible by the widest array of equipment including outdated equipment. Many small donations, $1 to $5,000, are particularly important to maintaining tax-exempt status with the IRS. The Foundation is committed to complying with the laws regulating charities and charitable donations in all 50 states of the United States. Compliance requirements are not uniform and it takes a considerable effort, much paperwork and many fees to meet and keep up with these requirements. We do not solicit donations in locations where we have not received written confirmation of compliance. To send donations or determine the status of compliance for any particular state, visit www.gutenberg.org/donate. While we cannot and do not solicit contributions from states where we have not met the solicitation requirements, we know of no prohibition against accepting unsolicited donations from donors in such states who approach us with offers to donate. International donations are gratefully accepted, but we cannot make any statements concerning tax treatment of donations received from outside the United States. U.S. laws alone swamp our small staff. Please check the Project Gutenberg web pages for current donation methods and addresses. Donations are accepted in a number of other ways including checks, online payments and credit card donations. To donate, please visit www.gutenberg.org/donate. Section 5. General information about Project Gutenberg trademark symbol electronic works. Professor Michael S. Hart was the originator of the Project Gutenberg trademark symbol concept of a library of electronic works that could be freely shared with anyone. For 40 years, he produced and distributed Project Gutenberg trademark symbol ebooks with only a loose network of volunteer support. Project Gutenberg trademark symbol ebooks are often created from several printed editions, all of which are confirmed as not protected by copyright in the US unless a copyright notice is included. Thus, we do not necessarily keep ebooks in compliance with any particular paper edition. Most people start at our website, which has the main PG search facility, www.gutenberg.org. This website includes information about Project Gutenberg trademark symbol, including how to make donations to the Project Gutenberg Literary Archive Foundation, how to help produce our new ebooks, and how to subscribe to our email newsletter to hear about new ebooks.